Brian, I can't hear you.
Getting started. Today we're going to cover electrical as well as going back for a quick review of the interior class. Our goal is to very quickly get you up and running on these main issues. So from that, I also expect, obviously, with these classes being remote, we have to rely on you guys actually taking a lot of initiative. I'll teach you as best I can, but the initiative will come in simple things like going to Home Depot and taking a look around, looking around your house, inspecting your house, inspecting your apartment. An apartment is really the same thing, and all of these different things you can do will help you to get ready to do the home inspection better. So again, it looks like you can see my screen, and we're going to be covering chapter 9 in the book. If you are in the newer book, it is chapter 5, and we'll cover most of the same issues, I believe. If anyone sees issues that you want to cover or mention, feel free to give me a yell, and we'll do our best to cover everything. My goal, of course, is to get you ready to start, honestly, a lifetime of learning. Now, like many things we're doing these days, we are in a virtual learning environment. The days of classrooms may very well be over. This is your classroom. Now, that said, this is a hands-on business. And even in a classroom, you're limited in what you can do. So, again, I want to emphasize lots of alternate teaching methods. First of all, look around your own place with the checklist and the software that you're looking at. And second of all, again, I love YouTube. YouTube is a fantastic resource for helping identify what's out there. Hold on for a second. I've got to do a little switch. Hopefully this doesn't knock us offline. Okay, so far so good. I'm going to wire the network in so I get a better connection. As always,
Hey, Brian.
at any time, feel free to ask questions.
Brian, can you turn your volume up a little? It's a little low.
Hold on, I hear something.
Yeah, I can't hear you either.
Hold on for a second.
Yeah, same here.
Hold on for a second.
Can somebody give me a sound check? I'm getting good sound on my side.
I think I heard somebody talking. Okay, again, sound check. Okay, the network seems to have just knocked me off. Hope you guys are still there.
Everything good now.
Oh, great. There we go. Yeah, there's definitely a little bit of nuance. I was just watching a thread with a financial investor last night, and he had 50,000 people on the YouTube and or on the Zoom, and his audio kicked out. So I don't know. Let's get started. So, what do you guys think? What are you here for? What do you want to get out of this class? I'm going to go around very quickly and ask that. Taryn, you were just talking. What do you want to get out of this class? What's your goal?
I want to get the knowledge, the basic knowledge of being a home inspector and using it to not only do inspections, but for when I invest in real estate as well.
Good. Yeah, that's a common thread. Actually, a lot of investors are realizing, this is something I need to pay a little more attention to. So good. Hey, Tanya, how about you? What brings you to this craziness?
I want to be a home inspector.
You want to be, that's your goal professionally. Okay, great.
Yes.
And let's see, Baijun, I think you have I'm sorry, I forgot your other name, your English name, but Baijun, what are you here for? What do you want to do this class for?
Well, I may become a inspector, but I just want to learn something first and see how that goes.
Okay. how about what's your background? You're a salesperson, right?
Yes, I'm a broker in
Okay.
real estate. Yeah.
A broker. Okay.
Yeah.
Calogero, I think that's your last name. I forget. No, actually, first name.
That's my
Calogero,
first.
what brings you to this class?
So like I said, the first class, I'm in the construction industry right now. I'm a super foreman for a plumbing fire suppression company.
That's right.
So I'm looking to get into this just to build my construction and ultimately my engineering career. That's the path I would like to take. So I feel like with the
Okay.
home inspection, learning through residential, it's just another notch to
Uh,
build my career.
Good strategy. Very
Mhm.
interesting. And of course, with FPSC, a lot of that stuff is working its way down into the residential. World.
Yes. Yeah, I heard you mentioning last time about the like the FDNY certs. I
Did you look
me
at the website?
Yeah, well, me personally, I already have a few. I already have my F60, my G60,
Oh,
which
yeah,
is
you're
yeah, because I was in the trades before I became a super. I was a
right.
pipe fitter. So which is to hold the fire watch and to use a torch. And now I'm going for the S ones, which are supervising sprinkler systems.
Yeah, I know guys that are, they have a stack of cards from FDNY, 2 inches tall.
Yeah, yeah, exactly. That's basically the goal as someone in the construction industry. The more you have, the more qualified you are, and
The more
it's
flexible you are on the site.
exactly. So
And that goes to all of you, by the way. While he's focused on larger construction, if you're being in the New York City area, on the FDNY website, they have not only the certifications that they ask for working on construction sites, but actually almost as valuable, they have thousands of pages of test preparation, and that test preparation is incredible packages. I know the sprinkler one in particular, I've given to a bunch of clients for, in terms of just understanding these systems. Now, as a home inspector, you're not going to worry too much about some of the construction aspects, but it does give you an insight. I always like to say you got to know how a building was built to understand what you're looking at. So the FDNY is a great example, and particularly if you're in the trades. Okay, Thomas, let me pick on you.
Yep. So yeah, no, I just want to get more knowledge. I'm in real estate now, and I want to do this on the side as well, alongside real estate.
Okay. Well, it's definitely a good parallel. And, being able to help out if you're a salesperson now, you know, although you got to be careful of the conflict of interest factor, it definitely can add some value at different unexpected points along the way.
Sure. Thank you.
Okay. I'm not sure who R is. Who's that? Anybody there? Well, anyway, I just wanted to do the quick intro to everybody because I've been doing all the talking, and I definitely want to hear bi-directional. So, as always, feel free to ask the questions, and sometimes I'll be too simple for you, and sometimes I'll be giving you a different perspective. So, I definitely share your perspectives because literally, it's the old cliche: every building's different, and especially in this area, things like electrical in particular, you're dealing with you may come across the oldest electric wiring in the United States. Westinghouse and Edison actually wired with DC current. Edison wired downtown Manhattan and parts of Brooklyn Heights for the very wealthy houses, in the early 1890s. And I've come across some of that stuff where, again, the wiring is wrapped in horsehair and paper, and you kind of wonder why it didn't explode. But like anything, if it's done right the first time, you'll get good quality. So let's jump off to the class. Looks like you guys, can't see my screen. Let me share my screen again. I want to look at my mug, that's for sure. Okay, let's hope we don't have any more hiccups as the day goes on. And iPad just joined. Welcome in. And as I said, actually, I might as well pick on who just came in. Who just came in? Oh, actually, I got two people to pick on. Ryan, Mr. R on the logo. Tell me about yourself quickly. Why are you taking this course? And that goes for iPad as well. I'm looking at input quickly. What's in it for you guys? Why are you taking this course? Once, twice. Whoever's iPad, your mic is on, so it's a good time to talk.
Okay, good morning. This is Cesar Castro.
Hi, Caesar.
This is the inspection class I'm taking, M2. I am taking it to be a home inspector. I want to go into business for myself, actually.
Okay.
I did plan on start to work for a company just to get my feet wet, get a feel of the business, get to network and meet people, and take it from there and enterprise myself.
Okay. Well, all the best for again. So the classes vary. Sounds like a lot of you actually are planning on going to home inspection. A lot of the classes have been a mix 50-50 investors and home inspectors. But hey, I'm here either way. So let's make this happen.
Question real quick, Brian.
Yeah.
I was told that New York State houses are going to need inspections mandatory now. Appraisals have always been necessary, but now inspections are going to be mandatory on all sales.
A couple of different layers to that. HUD, for instance, requires a inspection for HUD loans and FHA loans. In terms of New York State, I don't think so, because I think it's a voluntary part of the transaction. It is needed, though. What you're probably referring to is the fact that it is absolute a appraisal inspection is required to get federally funded loans, which is FHA. Now, what most people don't realize is 10 years ago, um, the federal government only underwrote about 25% of loans. Today, it's about 95%. So maybe that's what you're referring to. Home inspection definitely is going to be on the upswing because of the complexity of houses as well. And and quite honestly, your banks probably won't let you buy it. Obviously, the appraiser is going to take a look, but the appraiser is relying on your home inspection. It used to be that appraisers would inspect a house just like a home inspector. Today, this may sound hard to believe, but New York Times did an article recently that JP Morgan Chase has about 500 home appraisers that they use to do their loans. The home appraisers are sitting in an office park in Chennai, India. And when they do an appraisal on a house, they're only looking at online data, things like Street View and any property data that's available. So because of that, the home inspection does become more valuable as what used to be one of two tactical analysis of a property. It does provide that tactical review of the property indoors and out. I mean, would you buy a house based on the Street View? You know, clearly these are things to think about. As to specific laws, I don't know. And hey, if you find out, let me know. Okay. Again, my email, skyscraperfoundry@gmail.com. Write it down. Some of you have contacted me by email. I think Mr. Zhu, I believe, I had missed a lecture, so I was able to forward a copy of a lecture or part of the lecture. Today, actually, at the break, last night, I created some PDF files of these lectures, and I guess I should send them out before class. But would it help you if you had a PDF as well as the class? Obviously, during the class,
Yes.
you're looking at it.
Yes, sir.
I will try to shoot this out on the first break. I'll get it out.
Did you do module 3?
No, we haven't. Module
Oh,
3,
okay.
I believe we're going to be doing it. John usually skips 1 week, so you can take your test on the module 2, and then I believe module 3 will be starting on the 6th, but I'm not sure.
Okay.
John will confirm the test start. Module 3 is pretty important. It's mechanical stuff. And actually, it's a tough one to teach because there's so many different things you might see in a house, ranging from coal boilers to, ultra efficient natural gas stuff. Both plumbing and mechanical systems and electrical systems are really changing fast. You guys, as you probably have heard of the Green New Deal, the goal of politicians to make buildings more efficient. Well, that's obviously in places like Texas where the buildings are very thin and no insulation, and they get a once in 100-year storm like they just had. This can be quite tragic. I mean, sadly, when they're done, we're going to have hundreds of people dead from that. And perhaps if houses were obviously being more electric wouldn't have helped because there was no electricity, but which is a reminder to all of us. But which is why I know everybody I'm dealing with, they won't even think about building a system that doesn't have backup power, that doesn't have backup generators, backup gas, etc. It's funny actually that given what's happened in Texas this week, have you guys been following this? It's from a architectural and home inspection perspective, it's quite fascinating to think about. I mean, a blackout is bad, but when everybody relies on electric heat and electric everything, and this is a cautionary tale for us as New York State laws are requiring us to switch to electric everything. Um, the Everybody had electric down there, basically no insulation, very little insulation in their houses, and they had 100-year freeze. They're going to have pipe bursts. I mean, God forbid how many people they're going to find frozen, but they're going to have pipe bursts everywhere. And that gets to the plumbing chapter, of course, but it's a reminder to you of the fragility of electrical systems. And also, with again, because of that, a lot of, or in expectation of that, a lot of buildings you're going to inspect today will have things, of course, simple things we know about, like solar panels, but also for electrical, battery packs are more and more common. And these are things that are actually kind of not part of your inspection, but really you still have to have a very good working knowledge of them, because we are in an environment where you're going to look at a lot of material. Okay, let's kick it off quickly. By the way, I'm going to go back through the other one, last week's lecture, very quickly. I'll try to do about a half hour spin through that just to make sure we're good. This is me. If you guys haven't, again, there's my card. I'll send you a copy of that. I think it was in previous emails. There's somebody else. I have been very blessed in doing a lot of things, and I believe if you get to do things, you should share them. I've gone from everything from being a building official to a trustee of construction unions to, designing skyscrapers. And it's funny because I haven't designed a house in 30 years. So the last residence I designed was on the 43rd floor of an apartment building in Park Avenue. So residential's an interesting beast, but renovation of residential is quite tricky. I'm advising on one right now. I actually should show you some pictures today, now that we finally have permits, of a building up in the Bronx. It's 120 years old. And of course, one of the challenges was stripping out all the electric and putting new electric in. Quickly, the outline of the course. Again, we went through chapter 7 last time. Today is chapter 9. 7 and 9 make up HI2, home inspection module 2. And as I said, HI3 will be chapter 8, which is the mechanical systems. Again, every one of these, guys, make it perfectly clear. I can't stress this enough. What I'm teaching in the class is only the tip of the iceberg. I speak fast and go fast because I want to get in as much as I can for you. But you really, all of you have to be engaged in constantly learning. And this is the curious person's, dealing with construction is the ultimate thing for curious people. Hey, Mike, since you got your microphone on, I didn't hear you. Let you do your introduction. Can you ask? I've passed out to everybody. Why are you here? So
Yes.
I'm throw the question to you. Why are you here?
Good morning. I'm just a stay-at-home dad for a few years, and my wife's a real estate agent recently. So
Hey, little complimentary skills.
she thought, yeah, it'd be a good idea.
And I want you to take one word out of that phrase, my friend, and that's just. You are not just a stay-at-home dad. You are a stay-at-home dad, and it's a hell of a lot of work, my friend. And and you're smart to be looking around. I always tell people, if you're ever at home, and this goes to all of us, I have probably watched maybe 2 movies since COVID started. I don't watch. Watching television is a self-administered lobotomy. So everything you can do to be learning instead of sucking up mindless crap is great for your life. And A, I hope this class helps you. B, I hope it is a complimentary thing for your wife. And C, let's face it, real estate's hot as hell right now. It's complete death in New York City, but everywhere else in the country, this is one of the biggest years ever. So again, to all of us, probably most of us are in New York City. I'm telling people, I call this the echo effect. I believe that as markets go down, at certain point, we're going to get a boomerang back. And the numbers I'm seeing are that COVID's going to be fading pretty fast by April. That's federal government numbers, not mine. And because of that, we might see a pretty big splashback in New York. And we got a new victim just stepped in. Ron.
Yeah, I went
Ron,
to downtown Brooklyn
I'm sorry, Mike, go ahead.
right after high school. I went to study architecture and
Uh-huh.
Institution of Design and Construction down in downtown Brooklyn. Small
That
space.
man was a genius.
Yeah.
I loved him. Forget his name suddenly. A lot of passion and a lot of great people came out of that. I was deputy commissioner for Brooklyn for several years for the building department, and I was down the street. And I actually have several of his books. Why buildings stand up and why buildings fall down.
Yeah.
And in particular, I've ordered about 100 buildings demolished in Brooklyn. And sadly, that book was a good reference guide as to why things fall down. Although my knowledge goes a little more than that, because again, I was getting to be a commissioner. You do spend a little time in construction. Okay, Mike, great. As I said, Ron John, you just came online. Quickly, give me 5 seconds. Tell me about yourself.
Brian. I've been in the class, since last year. I just taking
Yeah.
review for the class, so I'm
Okay.
planning to take my exam soon.
Excellent. You're more than welcome, of course, and that goes to everybody, by the way. When we do these, feel free to look in the future. You may have seen me send the email. I've copied out previous classes. You will be more than welcome to listen several times. In fact, I update the material quite significantly each time. So, in fact, today I'll make sure to within the next hour, I'll send a presentation around to you, which I usually only put on the Dropbox, but today I'm going to try to shove it into email. Has everybody, by the way, been able to get into the Dropbox? If you have not been able to, please let me know. Okay, send me an email because I want to make sure you get access to all the stuff I have. Now, there's a lot of other resources online, like the Internachi site and YouTube generally, but the collection I have is what I put together. Some are my pictures, some are pictures I found online as useful resources, and the goal of all of them is to help you be a good, safe, and profitable home inspector. Okay, let's moving on. Let's see where we are. Again, why a home inspector? This is really important. You're getting a license from the state of New York. Okay, your job is to inform the buyer of reasonable risk. Reasonable. Remember, you are inspecting a building in a way that is non-invasive, non-destructive, and therefore you can't see everything. But from your experience, you can infer a lot of things, and those inferences can be valuable to your customer. Okay, so that's really the game. Again, New York State Department of State issues the license, and you should just Google New York State Home Inspector License. The law is right there, and I want you to read it, guys. You're going to be paying for insurance. You're going to be running a business. Therefore, I want you to know the letter of the law. Some of it I put in earlier presentations, so you'll have copies of it. But I always want you to go to the website and always follow, because they're going to change the law on you, as was mentioned. Possibly there's a law change, which I was on the home inspection website this morning. I did not see it, but there may be a change out there that says every house has to be inspected. Again, from reference, because you can buy a cash simply with you can buy a building with simply a suitcase and a quitclaim deed. I'm a little questionable about whether home inspectors are mandatory, but as I said, they are mandatory for certain types of loans. Well, we already did the class intros, so welcome all. This is me very quickly. I think we might have even seen this before. Bryan Winter. I live in Rego Park, Queens. I've lived in Manhattan. I've lived in Brooklyn. I've been very blessed. I've traveled the world as well. Again, one of the things that we do think about in New York City, because it's a higher density city, and instinctively this makes sense, but it's actually written into law. And that law says that in much of New York City, most of New York City, all of Brooklyn, all of Manhattan, most of the Bronx, and excepting only a few parts of Staten Island and Queens, the areas are referred to by building codes as a fire district. And within a fire district, you're limited to how you build your house. Sounds stupid, but it obviously, if you think about it, of course, it makes a little sense, simply because the goal is to, ironically, one of the jobs, as you might have seen with one of the pictures earlier with a burning building, one of the things of a building code is not to prevent your building from burning. It's going to burn. That's not, you can't do anything about it. What the building code job is to prevent your house from burning down the neighbors. Crazy, but it's something you want to think about, and how and what the logic is for building codes. As I said many times, I think one of you guys is a firefighter. The building codes are written on the bodies of dead firefighters and dead people. I know that sounds gross, but let's face it. Look at Texas. You think they're going to change a whole bunch of laws now? You better believe it. Your houses are going to be required to have little backup systems. Insulation is going to be a little more needed. Chances are they're going to spend a lot of money on upgrading their electrical grid, which is actually a national strategy. So I think a lot of things are going to change. But again, as they say, the more things change, the more things stay the same. Now, with the electrical inspection, as we walk around the house, we are sweeping a house. We've gone around the outside and we walk room to room on the inside. And as we do, we're looking for interior stuff. The walls, ceilings, floors, water damage. Water damage can go, of course, to electrical as well. In fact, electrical outlets, particularly on exterior walls, are kind of a problem, because if you look at them, they're often a break in the insulation. So if you look at a thermal image of an electrical outlet, you'll find that very often they're like a hole in the wall, letting air or cold, cold air or just energy through because of that lack of insulation. And that goes for many systems. Today we have everything from Bluetooth ceiling fans to just all kinds of devices. And I'd remind you that as you're doing a home inspection, kind of make sure they have the devices. It's like, oh, you got a great ceiling fan. Oh, but they lost the remote. Okay, great. That's a new ceiling fan you got to buy. These are little things, but again, they do add up. And as you're checking switches, you're checking outlets, as you're walking the room, you are trying to identify things that, first, are safety issues, and second, are potential cost issues. Um, Safety is a pretty big thing with electric, because very simply, um, I think YouTube is full of videos where people do something unfortunate and then they're dead. It's I think I mentioned once, I had a lady in my real estate class, salesperson's class once. She sat in the front row. She was in her 50s, nice lady, but her arms, her forearms, were looked like something out of Freddy's face from the horror movie. They look leatherish, and sadly, she had been shocked thousands of times. But hey, she had been safe relatively, and she was still okay. And I asked her, first of all, what are you doing in the class? Well, she said she had 30 years of electrical experience, 30 years in local 3, and she was looking for a new career as a real estate broker in this case. Well, I kind of laughed, and knowing that if you're in local 3, she also snickered and said, "Oh, don't worry, I've got 5 million in the bank. I don't have, because of my pensions and my annuities, but I'm doing this for fun." So I guess you never know who you're going to come across in the classes, and you never know what skill's going to be a hot one. I hate to say it, it's literally true. I was telling my daughter and my daughter last night, if I could advise her to do anything, she should forget her international relations degree and become a plumber. I say that, of course, because again, the trades of the infrastructure of houses and buildings generally, there's a lot to be done here. So inspecting electrical systems, of course, we think about the building codes themselves, but today, think about, just take your apartment or your house. You might have integrated. I mean, actually, with some of the newer systems, we don't need as many wires anymore. Wireless. You may not remember it, but 20 years ago, houses would be wired with, you know, coaxial cable, and then RJ45. Today you've got all that wireless, so much of that goes away. Ironically, a lot of people are now, as I mentioned in the shielding discussion before, a lot of people now are saying, I don't want wireless in my house. I want to get rid of all the wireless in my house, wire everything. That's, by the way, important for government contractors, but that's another story. Wireless is an option that some people are starting to move away from. So again, the trends change every year. Things like, people used to wire their stereos. You can do that Bluetooth these days. Big picture is, as you're going through the house, think about that layer of first lighting and power, which is your primary concern, and pay attention to the other issues. Good news is most of those other issues, the video, the data, are not part of your inspection. You're not going to certify the quality of Wi-Fi in the rooms. Those a buyer might want to know that. But again, that's something that's fixable by others. That which gets generally to the question of low voltage electricity, which those systems are many like this, and they, for the most part, are not part of a home inspection. Again, you're focused on light and power primarily. So the book itself, the old book, this is the outline of what we're going to cover today. Again, conductors, voltage, etc. We're going to spend some time in the main panel board. You're not required to open it up, but you are. Let's just say, if you don't, you're not really, in my opinion, you're not doing an adequate inspection. Okay, just quickly, I want to talk about if you have the newer book. What I refer to the newer book is this one. You may have this one. You may have the older book. It has some pretty good value. Both of them, though, have the list of do's and don'ts. And that perhaps is probably the most important thing you're going to deal with. One of the things we deal with in a building is, in an inspection, is how can I get through this inspection, provide a rough report, and get out without going bankrupt? So you always ask the question, what are you inspecting? Okay. Again, you're going to check the service entrance. You're going to follow the power. The service entrance as it comes into the building from above or below. You're going to check the meter in the main panel. Obviously, the meter is owned by somebody else, but you want to make sure there's no damage. So you got the meter, the cutoff, and the main panel. Okay. And then as you're walking around, you're looking at the branch circuit wiring. Now, obviously, the branch circuit wiring's in the wall. I have some devices that look inside of a wall, but that's not something I bring along on a home inspection.
Excuse me, Brian.
Hi, Sarah.
Hi, we're on the menu page. Are we supposed to be looking at visuals?
Right now you're on the menu page. That's
okay. Just making sure.
Yeah.
Thank you.
No, I'm copying. I have a second screen that shows me exactly what you're looking at, but I'm just looking broadly through this. There's the do's and don'ts page, which ironically I don't have a slide. But of course it is in the book, and the branch circuit wiring, junction boxes, etc. Now, chapter 9, this is again the older book. Novice inspectors do get a little worried about the electrical system, and for good reason. If you screw up, you die. That's a pretty good motivator. If you don't know what you're doing, learn or don't touch. The actual requirements for a home inspection for electrical are somewhat limited. Remember, you're doing a visual inspection primarily. So you don't have to know. I mean, ideally, you're going to test that outlet and make sure it works. But if you don't, at least, if there's a char mark on the outside of the outlet, that's something you want to report. Again, the inspector does. I can't emphasize safety enough. And quite honestly, PPE was a big thing before COVID. Okay, in construction industry, very big thing. The N95 masks had just become required in the construction industry officially a couple of months before COVID hit. So everybody already knew what they were, and ironically, a lot of construction companies had pretty big stockpiles. And when the price went from 50 cents to $10 per mask, I know a couple of guys who kind of wiped out their company supply for the use of making a little profit. Anyway, that's for another day. Again, you really need to be prepared on electrical. As we said, there are several primary standards. The book, the ASHI and the NAHI and the NACHI standards are all out there. Want to make sure you think about the key terms. Again, overall, what tools do you use? You're going to stick a screwdriver in an outlet? That goes without saying. It's pretty dumb. I'm sorry I don't have one with me, but I do have a circuit tester, and that's something I do use. Normally, you're not required to test things like voltage drop, but it is, again, tools become cheaper and more efficient and you can do a lot more add value with no extra effort on your part. NEC is a national code. Review the general procedures of going around, as I think we've started to discuss that. Again, the main panel board itself. Anybody comfortable opening up a panel board? I am. You may not be, so don't. Pay attention today. Watch videos online as well. Unfortunately, I can't stream videos with this with YouTube, with Zoom, without worrying about it crashing. Otherwise, I'd show you some tours, more visual tours. If I were in the classroom, obviously we'd be able to do this more. But hey, we're going to adapt to what we got. The good news is there are a lot. I want you to Google, electrical home inspection. There are a lot of great classes online that'll supplement what we discussed today and help you get more comfortable. Again, electrical panels are really serious, so you don't want to play with it. And quite honestly, even watching videos isn't enough. So be very cautious in what you do. Junction boxes, plugins. As you're walking around, you're going to look for non-standard or non-spec electrical work, stuff that's not done right, not closed up, not safe. The question with electrical is very simple. Is every electrical wire protected? Is every connection properly protected? Is every outlet working? And does it look like there's enough power for the building? And then last but not least, we'll cover smoke detectors. Of course, smoke detectors have been supplemented by law in the last couple of years with carbon monoxide detectors. New York City is actually looking to, but has not yet passed, a third detector requirement, which I actually like. And I was trying to find one recently, but I couldn't find it. And that is a fuel gas detector. And that's kind of good. I have come home several times where, for whatever reason, our stove had been left on with gas and the apartment had been filled with gas. If you've never seen the explosion that can happen with gas, it's quite severe. In fact, I was just had about a 2-hour discussion with a lady the other day, because she's in an apartment building where her gas is turned off because somebody smelled gas. And because of that, somebody smelling it, Con Ed will not let the gas get turned back on again until an engineer certifies the gas line. And the only way for the engineer to certify it is if he replaces the line, which can get pretty expensive. So again, smoke detectors are a big deal. Carbon monoxide detectors, we'll go through those. This red area is just the outline of the class. You'll be able to see this when I send you the PowerPoint. Let's see. Again, this is available already on the Dropbox. If you look at the HI2-2 lecture on the Dropbox, this should already be there. It's labeled as June 2020, I believe. It's a slightly older lecture, but it's 99% of what we're discussing today. So you definitely should go online while you're listening and grab those lectures from the Dropbox. And again, if you don't have access to the Dropbox, let me know. So the red is literally the outline of the class. I'm not going to go through that because you're going to get it now during the day today. And so, ironically, congratulations. We've made it to the electrical section. Now, guess what? I'm going to play. Let's see. I'm debating whether to go back to the interior section now or after lunch. I think I'm going to do it after lunch. That'll be more efficient. Okay, so let's go pounding through the electrical section. This graphic is, by the way, I'm putting these slides up on the screen. Now, what devices are you guys looking at these on? This particular image is kind of fuzzy at full resolution. I believe my Zoom signal is going out at 1920 by 1080 or 1080p. So the question for you is, what device are you guys watching this on, and can you see the graphics well? Can anybody give me a quick survey? Mike Urbano, what device are you watching this on? A laptop, a desktop, or a mobile?
Laptop.
A laptop. Okay, so you got a full screen of what I'm showing you right now?
Yeah, I can see it. A little fuzzy, but it's good.
Yeah, that's not a very good image. No, the reason why I ask is when when I started this lecture series about 6 years ago, we were usually not broadcasting over the internet. So it was designed for a classroom, and it was a lower resolution because my projector was like not as good. Um, I say this because I'm trying to kind of upgrade the presentation for online. And generally, who else? Let me bust somebody else. Calogero, how are you watching this? Are you watching this on a phone or a laptop?
A laptop.
Okay.
I'm on a laptop. Yep, and I see everything pretty well. The smaller
This one's
print
fuzzy,
is a
so
little
it's
fuzzy,
okay.
but everything you're able to read it. It's not a
Okay.
problem.
Yeah, because I've been kind of making an effort to zoom in on things in the past. I'm not going to bother as much on that today, but again, the graphics, uh, understanding what you guys are viewing it on, as we all know with the internet today, the it helps me understand what visuals I'm going to put online. So again, those two of you, thank you very much. So I'm going to assume everybody's watching this on a laptop, and that's probably the best way to handle it for a whole day lecture. Because although I know some of you do it on the phones, but hey, go for it. Although ironically, my phone has higher resolution screen than my laptop does. Right? Key terms. Hopefully you'll know all of these terms by the end of the day. What's the difference between a service lateral and a service entrance cable? What's a GFCI? Hey, what's an AFCI? Circuit breakers versus fuses, amperage versus voltage versus wattage versus ohms, and how those things all work together. The rules of electrical are pretty amazing. And by the way, I don't recommend I haven't watched very many movies in the last couple of years, but one I did watch recently was a Netflix movie, I think, called The Current War. And it's actually about the interaction between George Westinghouse and Thomas Edison, and of course Nikola Tesla. And it explains how our modern electrical system came about, and it's quite interesting. Ironically, it ranges from one of the largest financial investments of all time to the shocking to death of a large elephant in Coney Island. Crazy stuff. Back to the definitions. The basic concepts of electricity we'll go through today, but also the entrance, as I said, the panel box, and we'll take a look at some pictures on circuitry itself. Now, all of this, for the most part, is regulated by the National Electrical Code. Now, New York City was a smartass up until 2011, and they had their own code. The reason why you want to kind of understand these old codes is because really things change over time. If you're an electrician today, and if you put a paper and horsehair wire wrapped line in your building, you're not going to get passed by the electrical inspector. Codes have changed a lot, and as you understand the historical perspective and the fact that things changed, people learned, they got smarter, they realized GFCI is a good thing. Then they realized AFCI is a better thing, but the first generation of AFCI failed, so they fixed it again. And hey, in the 60s, they said, hey, aluminum wire's good. And then by the 70s, enough houses had burned down that they said, maybe we're going to stop using that aluminum wire. But hey, it's still legal today. So these are an evolution of codes constantly moves forward. Things like, I could go on and on. Each one of these things, as we'll talk about today, is a constantly evolving standard. You may not want, I doubt highly you're going to want to buy the electrical codes. And you know why? Because they're online for free. New York City and New York State both have the building, all of the construction codes online. You may not be able to print them, but you do have access to them. Are you going to read them all? Probably not. As an alternative, by the way, there is a book called Code Check. That's a really good contractor reference out in the field, and it's something you may want to invest 30 or 40 bucks in to have as a reference as you're doing a home inspection. My inspectors at the Department of Building, I had one guy that insisted on bringing the entire code and zoning with him every day. He was carrying 40 pounds of books in a rolling bag all day, every day. He was very thorough. He was afraid to be wrong. So he literally pulled these paper books around. Now, obviously, I kept telling him, dude, they're online. They're online. You don't need to do that. But he viewed it as a point of pride that he had the codes books with him, because building inspectors actually have to cite the section of something that is in violation. When we talk about inspection procedure, as I said, when we're looking at the wiring themselves as they go through the building, now a lot of the time you're simply not going to be able to see the wiring of the building. One of the few times you can see it in a non-destructive home inspection where you're not opening things up. One of the few things you should open up, but you are not required to do, is the panel itself. Now, as I said about history, this is a good example. This is a master switch for a building, and you could tell by if you're an art aficionado, you would recognize in that blue box a very sophisticated Art Deco design. In fact, in the 1920s and 1930s, electricity for buildings was very, very, very high tech and high fashion and expensive. So they could afford to actually pay artists to design the materials, things like this panel box. So you can see those vertical lines. That's really an Art Deco sign that really dates this panel box to the 30s or 40s. Is it okay to still be around 30s and 40s? Corrosion's a kind of a tricky thing. In this case, this is a master switch and it has probably 2 fuses inside. So again, as long as the fuses are updated, it's probably okay. Individual breakers, clearly this was added later because this is a 1930s box and they didn't have breakers in the 1930s. So this is probably a 1970s box added on later. No panel cover, exposed breakers, crappy wiring up top. That's, again, this is the investigation. I like to say you got to be a little bit of a Sherlock Holmes as you're walking around buildings. You find clues where you can to try to make inferences as to potential problems that might cost that buyer money. Things we want to look at are things like copper versus aluminum. Aluminum, as I said earlier, was a bit of a problem. Sometimes the only time you can see that, you're not going to cut the wires open, right? Well, you might not see it except at the panel box at the connection. Protection, insulation, or like I said, is everything in boxes. The wiring itself, is it well done? Is it connected properly? Are there nails going through the lines? I'm not kidding. 3 things I care about, guys. What destroys a building? Water, water, water. What destroys a home inspector? Safety, safety, safety. Okay. What happened here? Do you want to find out? Can this happen? Yes, it can. A short circuit, water dripping onto a panel box, a screw accidentally falling and creating an arc. If you're going to play with panels, you need to be properly protected. Is this guy wearing a face mask? I bet he wishes he is. Is he wearing a safety goggles? I bet he wishes he is. Right? Is he wearing heavy electrical gloves? You can see where that goes. So this is a reminder to you to think about the safety requirements that you're going to need as you do an inspection. If you're going to be opening the panel box, are you properly bringing gear to investigate it? Again, you watch the videos online and they're not wearing protection, but they also tell you, hey, I should be wearing this, but for the video, I'm not wearing it. So I can't stress enough. And remember, you might be inspecting a building alone. You may be walking down here. You told somebody at your office, hey, I'm going to be, inspecting that house. If I'm not back by 1 o'clock, send the ambulance, right? That's so important. If you're not walking around with somebody, or even worse, probably the worst part is you're walking around with a broker or a homeowner and they are not taking safety seriously either. Sometimes it's good to put you between them and the potential problem. So again, think about safety, not only for yourself, but also people you're with. I said this, and I want to reemphasize this, especially when you're inspecting alone. Always think about that fact of safety, which is at everything you're doing, you should be asking that question. Who's got my back? Who is going to drag me out of this building when I get shocked? If you don't have an answer, you better have a buddy system. Let people know you're there. As some of you are trained in construction, you know what confined space is. One of the requirements of confined space safety, guys. I helped write chapter 33, so I did spend a little time on this. One of the things about confined spaces is you have to let, believe it or not, the fire department know that you're going to be in a confined space. Why? Because when the stuff hits the fan, the fire department guy's got to come and rescue you. Things to think about. Again, tools of the trade. A lot of discussion as to how many tools you bring in. As I explained this in a previous class, I love this box, not because its equipment is very good. I don't think I'm ever going to use a pair of scissors out in the field, but the concept of having all my equipment in a slot. And most importantly, everything's got to be in that slot before I leave. Sounds a slot for a Sharpie? Yeah. Is the Sharpie valuable on site? You're damn straight it is. You may be doing home inspections with, a little bit of advisory to the potential buyer or the seller. I like to use Post-it notes. They're pretty unintrusive. I've also, again, you also want to think about as a marketing tool, you want to think about how you're adding value. To the buyer, potential buyer, you can add value by giving manuals. To to the seller, has not even done that yet. They may not know things like, "Hey, can I have a label for this?" And little simple things like a post-it note can be a little helpful. Although, don't put a post-it note in an electrical panel. Again, testers. Some of the things that I definitely bring: a 2 to 3 prong tester. Uh, for a 2-prong, you have like 2 probes. It's a little different, but the 3-prong one, again, well, you'll see in a minute, they will test you for the GFCI, as well as a voltage test. Gas test, this will come later during the mechanical chapter. But honestly, I'm going to be honest with you guys, it's not such a bad idea to have a carbon monoxide tester on your body when you are, especially when you're dealing with older houses. Obviously, you're not going to wear a big, 8-inch carbon monoxide thing as a necklace, but they do make about a 1-inch necklace. And yes, it's expensive, but yes, it might save your life. I recently was joking with somebody for inspecting houses upstate that he should also, because there's so much radon upstate, that he also should get a nuclear dosimeter. He took my advice and he actually bought one. And ironically, he was in a house that it started ticking. The house had enough radon in it that it was getting measurable quantities. He was getting measurable quantities of radioactive dose in inspecting a cellar because of the radon gas in a cellar. Is that going a little overboard? I don't know. I got to tell you, down in New York City, radon detector is not as necessary, but upstate New York, guys, radon is everywhere. Now, what does it have to do with electrical? It's the broad spectrum of how many tools you're going to bring to a home inspection. Again, tools serve 2 purposes. One, they have a function. And 2, I don't want to be tacky, but they're also a prop. If you show up with a screwdriver and a notepad, maybe they're going to love it because you're going to be in and out fast. But the buyer, if you're walking through with the buyer might want you to do a little more. And so again, having that balance of gear is a question. I like this set because the idea is whatever I'm taking in, it's only gonna be in this box. So it's a small amount of equipment, but it is professionally done. Again, you open up this at the client's office thing, and it looks pretty professional. And remember, don't ever forget that you're working for the buyer, but the seller is probably going to go buy a house too. So always treat every person you're dealing with as a potential client. The home inspector has an interesting perspective in that they can work both sides. Every transaction. Usually, again, working for the buyer, but the seller, like as I said, becomes the buyer as well. Oh, here we go. Here's some of the electrical devices. Now, on the left, I'm kind of laughing at this because everybody knows what a digital thermometer is these days. I actually would highly recommend you go one step further and buy some of the relatively inexpensive digital cameras. They range from utility ones that are a couple $100s that are shaped like this to again more expensive FLIR equipment. Uh, I was just looking at a phone at B&H the other day. It's like made by Caterpillar. It actually has a thermal camera built into the smartphone. Not a nighttime camera, but a thermal camera. Of course, our smartphones are becoming incredible devices these days in terms of all the different things they can do. But I like having equipment that's disposable and losable. This is a little box I bought recently. Again, it does the GFCI testing on outlets. It also tells me what I consider to be very valuable, which is the voltage. Now, of course, a typical house voltage is usually 115 to 125 volts. So this house, for instance, is coming in at 121. That's within an acceptable range. But if you're very far into a house or there's voltage leak somewhere, you might be testing an outlet. It comes in at 95 volts. That's a sign something's wrong. And again, so these are devices that used to cost lots of money, now are getting much cheaper. This is a heavy duty voltage checker for cables. It'll measure the voltage or amperage going through a cable without touching it. It's called a clamp. This is a good thing for safety. If you are suspicious that a line is dead, this may be something you want along. Again, not very expensive these days. We talk about general inspection, room to room inspection. Just as we've walked the perimeter, we've gone clockwise around each room or counterclockwise, whichever works for you. Marines go counterclockwise, as I said before. I'm dopey, I go clockwise. What are you looking at? You're looking at, for electrical, you're looking at things like wear and tear, outlet locations. What if I told you extension cords are illegal? Well, technically they are. And a firefighter will tell you that extension cords are a nightmare because very often people will run an extension cord, even worse, a light duty extension cord. And of course, it gets hot, just as wires do in your wall. The wires in your wall, when they get hot, they're designed to be at a reasonable temperature at full circuit. 15, you run all 15 amps. It's a lot of energy. And it'll heat up in the wall, but the wires are thick enough so they won't get too hot and cause a fire. We'll talk more about that later. Again, as we inspect the room, we look at wear and tear. We look at the level of use. Does it look like the outlet's been plugged in 1,000 times? Or does it look like there's, a dozen, what do you call them? Extension cords or something coming out of the outlet or power strips. I'm a hypocrite, by the way. Yes, my computer desk has something like 15 outlets coming off of the power strip, but at least I have a battery backup on it. The good news is, by the way, the average electrical device uses less power these days. So a house may be designed so that and this is good, there's less than 6 feet for every outlet. Now, older houses, very simply, if you're very lucky, you'll get one outlet per wall. In older buildings, in 1920s, when they were rewired, much older houses were given wiring after the fact. If you're really lucky, you might get one outlet per room. I actually had to vacate a very large apartment building in Brooklyn, and very sadly, in about 2009. And in this case, the apartment building, each apartment had only one quad outlet. So four outlets and one circuit, one 15 amp circuit for the entire apartment. Wow. Unfortunately, of course, everybody was hooking up air conditionings in this building. The whole circuit of the building was flipping out all the time, and everybody was losing power all the time. And instead of upgrading the system, the owners kind of jumped the wires. They jumped around the fuses. So instead of having a 150 amp fuse for the whole building, the guy put a huge, about a odd zero wire jumping the fuse, and he was taking wire directly in with no fuse. And unfortunately, with that, he had a 2 alarm, and then a 4 alarm, and then a 5 alarm fire. And with a 5 alarm fire, I had to go out. And when I went down to my electrical chief called me to come down to the electrical room as we were doing the forensic inspection. And I saw the most insane wiring I've ever seen in my life. But it was all about ignoring and jumping the fuses and breakers that were in the system. And because of that, the lines and wires in the walls had gotten so hot that the building had literally caught on fire. Not once, but 3 separate times. Ironically, all 3 fires were basically in the same guy's apartment. Luckily, he survived, but the miracle was unfortunately short-lived, because when we vacated the building to get it rewired, City Hall, I was coordinating with City Hall, and they were calling up like, can we get the people back in? I said, no, not till the building's rewired and recertified. And one day she said something amazing. She said, these people have got to get back in. I'm like, look, we can't until it's safe. It's not safe. And she says, I don't care about safety. 2 of them have committed suicide already. Wow. So the point being there is we're in a fragile world. And if these systems don't work properly, a lot of people can get hurt, and sadly in unexpected ways. And as I said, I know to be brutal, we're definitely seeing that. You guys should pay attention to what happens in Texas the next couple of weeks, because that collapse of the electrical system has revealed to a lot of people that, maybe we better have our own microgrid or a way of, providing for ourselves. I actually did something odd. Because of I'm kind of I don't want to say a prepper or survivalist, but I'm a person who believes you should take care of yourself. And with that, I actually ordered a solar panel system for my brother. Now he's kind of laughing. It's like, Bryan, you ordering solar? I said, yeah, it's a good system. And I told him, I said, Bill, that's my brother's name. I said, I want to make sure you have enough power to run the most important thing in your house when there's a power outage. And he says, what's that? He says, I told him your water well. So I got him enough power to create about 2 kilowatts, which is about roughly 100 square foot, a 10 by 10 solar panel, because I want him to be able to have enough power to run uh, the water for his house. Again, this is something to think about with the interaction of electrical, water, and mechanical systems in the building. Unsafe conditions. I saw us grab some of these pictures. In all fairness, again, I didn't. Is one of the reasons why I don't release my PowerPoints, is because these are images I found on the internet. I didn't take these, so in deference and respect to the people who did do them, I usually don't want to circulate it on the internet. So when I do give the PowerPoints out, everybody, you're not going to post them, okay? Because they are for educational purposes, and I'm legally allowed to show the images, but I want to be respectful. And anyway, with this, clearly you can see this is just stupid stuff you're going to see along the way. Anybody want to turn that water on? It's not going to end up very well. This, of course, the water meter coming in right next to, I'm not sure you can see this, but that is the backside of the electrical box for a washing machine. So again, a 30 amp circuit right next to a water meter. That ain't real bright. And not only is it next to a water meter, it's next to the jumping ground for the water meter, which is the white wire. So again, keep an eye out as you're going through for things that are just, they look stupid. Never forget, when you're inspecting a house, people do stuff to get by. I call it DIY. People do just enough to make things work and not to do it right. And you, in your home inspection, are trying to find all those DIY things that are half fixes, because those half fixes are dangerous. Clearly, this one, quick thoughts. What would be wrong with this outlet? First of all, it should be GFCI. Second of all, obviously, it should be 3 feet away from the water source. Okay, things to think about. Just a quick reminder of this is a typical image, as from an architect, of what the typical switches are. And this, as you're walking around a house, you're looking at, as again, the walls, floors, and ceilings. You're also looking at the walls, floors, and ceilings for the electrical, the lighting. What switch controls the lights? So you can see here on the right that this switch right here by the bedroom entry, that's going to control a lot of different lights. That's probably a quad switch, and it's controlling several different circuits of lights, down lights, can lights, area lights, fans. But then there's another circuit that covers outlets and wall outlets. This is just a lighting diagram. This is not the outlets diagram as well. But there's a lot going on, and these diagrams are you want to kind of build this in your mind as you walk through the apartment or house. As we talk about a property, how would you do it? Remember, you can inspect up to 4 families. So this is a typical 2-family. We looked at this one last time as an example. And again, you're doing your sweep, we're going around each room, you're checking the outlets, but there chances are the electrical is going to be centrally located down either in the basement or on the wall lights outside the house. So you again want to keep an eye out for that. And as I said, there today you're going to come across a lot of stuff that is looks like electrical, but is not part of your inspection. This is actually a guy who has a both a very heavy power line, but in this case, he also has a lot of fiber optics running into his house. By the way, don't you wish every house inspection the wiring looks like this? These are clearly the electrical paneling. Is is this a crazy way to do it? No, this is beautiful. I love this. It's very clear. My 15 of my 20 amp circuits. Ooh, there's a big red one over there. That's probably a 30 or 40 amp circuit. That is a beautiful way of laying out the electrical panels. But on the other hand, over here, you also have a data panel that is low voltage and not part of your inspection. So would you feel comfortable opening this door and seeing stuff? To me, I'm just loving it. I see the quality and craftsmanship done with this electrical work, and I'm saying, oh baby, I'm not going to worry too much about this house. This is going to be a good inspection. All right. But then you open the panel up and find out that he's played with a bunch of crazy things and a gerbil's living or a rat's living inside. You never know what you're going to find. I've heard somebody was talking about they had found a snake in here once. My brother actually got bitten by was doing a building inspection and got bitten by a cottonmouth snake. And if you know what that is, that's a highly poisonous snake. That's a little reminder to you again about safety. I got a new one coming in. Whoever joined in, welcome. And let's keep pushing on. So again, as I say here, can anybody click? You okay there? Pablo, as you join, are you in the home inspection or a real estate class part of it?
I was trying to join the notary.
Notary. Pablo, I think you're in the wrong class. You want to go check this is the home inspection class. Check on the website to make sure you have the right thing. And good luck with the notary class. It's a good thing to have. And that, by the way, goes for all of you, that the notary public is a good thing to do. So Pablo, this isn't it. So,
all right, thanks.
But you're more than welcome to listen in if you wish.
Okay.
Take care. Again, this image is a reminder of what you would hope every home looks like. But what else you might come across? Obviously, shared data, video, power backup, security, camera banks. People are, it isn't just for the James Bond types today. I know a person that just ran 32 cameras in his house. Does his wife like it? I don't know. It depends on where the cameras are. But we are in a world where a lot of stuff is going about. And here's the important thing to remember one more time. The left side, the yellow and white lines, 15 and 20 amp circuits, those are the power that we care to inspect. The low voltage data, etc., not part of our inspection. Okay, very important to emphasize that. Fiber, and it sounds funny, but copper phones, it seems rather odd, but yes, believe it or not, some people still have copper lines. In the old days, the copper could have been installed when the house was built. Often it runs in the baseboards of much older houses. Okay, moving on. Again, what not to inspect. Don't inspect security alarms, low voltage, signal, networking, video, wireless. From the book, what are you not to inspect? You are not inspecting a tool you are not going to be inserting a tool, probe, or testing a device inside the panels. You're not required to. Okay, you are not required to operate or test any overcurrency devices. Except GFCI and FCI. So GFCI and FCI you can test by pressing the button. They're may be more advanced electrical systems for battery packs and stuff, you're not required to test them. Those are specialized testing. The example there would be a Tesla Powerwall. That is a large battery system, or a generator that might be in a house. Those are not things you will inspect. There'll be a custom person to inspect that. Can you get certified to inspect it? Yes. Can you inspect it because if you know what you're doing? Yes. Why wouldn't you want to inspect something? Why not inspect? Because if you inspect it and you say it's okay, then potentially it's when something's wrong, they might say, hey, you told me it was okay, and it's not. Give me some money. And it sounds dumb, but that's what we care about. We want to make sure we're not going to get sued for things. Again, you're not required to observe low voltage systems. This has a good example. One of the things that's very popular, freeze sensors for water coming in. Make sure your pipes don't freeze. That's pretty important. A lot of people, you may be inspecting a second home. Let's say up on a lake, let's say Lake George is an example, upstate. Upstate New York is cold as hell. Okay. And even in the spring, you may have snow. I recently, a couple of years ago, I went up to Cornell with my son. He ended up going to St. Andrews in Scotland, but Cornell was interesting. And it was funny because we were up there in early May and they still had the snow shovels out. So I know it's hard to believe, but this state gets pretty darn cold. So things like freeze sensors and stuff, those are pretty important. One of the ones actually I really encourage is the water detectors on the floor and the freeze detectors. Again, not only for broken pipes, but broken foundations. Electric, of course, as we talk about electricity, we're looking at what is it? Now, a modern house today, I think somebody mentioned about some recent law changes. Here's a recent law change in 2019. As of 2019, every October 20th, November 20th, because I gave a lecture. No, excuse me, October 15th, 2019. Every house permitted after that point is going to have a rooftop solar. But every new house is also going to be required to have an electric car charging station. That doesn't sound like much, but that's 30 amps. That's a big chunk of service. And these are all things that just have come into play in the last couple of years. But we're going to generally talk about this diagram as we move forward. Everything from the technology of the central server to your microgrid and the grid you're providing to yourself, as well as all of the devices that are out there today. Of course, measuring electric is based upon the kilowatts. Up until the last 10 years, the most efficient way of creating electricity for a house was buying it from a central power plant. As of yesterday, I cannot believe it. I actually found something I agree with Bill Gates on. And he actually has come out and said, wow, we should retrofit the United States with nuclear reactors, and then we won't have to worry about it as much. And obviously, if you've had your as many buildings blown up as I have, you would look at other aspects of that, potential terrorism, etc. But the simple fact is our power supply, centralized, is evolving. Today, houses, through the solar panels that are now legally required, are going to be having a little bit of the ability to protect themselves and defend themselves in emergency events. And again, I can't stress Texas enough right now. If you're not following what's going on there, you should take a very good eye on what is happening, because what's the most terrible part? Is it you can't turn on the lights? Nope. It's actually that, as I said earlier, most people get their water from pumps, from wells. So they actually don't have power and they don't have water. Trust me, guys, you can survive a long time without food, but you can't survive very long without water. And even worse, when the water is contaminated, people start getting sick. Some people actually are predicting that Texas thing is going to be a really epic humanitarian crisis. So keep an eye on it and think about it as as it impacts what you're looking for in a home. It seems we think of homes as okay, it's good, it's an investment, it's a commodity, but its first purpose is to let people live well. Okay, units, AC and DC. No, it's not only one of my own favorite bands of all time, but it, of course, the alternating current and direct current. This, by the way, was Thomas Edison on DC and George Westinghouse and Nikola Tesla for AC. The genius of Nikola Tesla was he viewed electricity not only as a tool and something of science, he viewed it as something philosophical and mystical. And whatever he viewed it as, he did come up with the idea, which seemed quite odd at the time, of AC current, and that discussion was quite valuable for being able to get the power underway. Sawaba, I see you joining. Are you for the the notary class or the home inspection class?
In the home inspection
Oh,
class.
yes, right. You've been here before. Good. Welcome.
Yeah, sorry I'm late.
No problem. As always, guys, actually, so I've done it to everybody else. I haven't done it to you, which is give me a quick answer. Why are you taking this class?
I want to increase my knowledge of the real estate business and also want to become a home inspector.
Okay, great. Thanks. So back to the fun. And as we are going forward today, of course, AC/DC, what does it matter? DC, what is it? It's safer. We kind of like that, right? AC can be, again, a little dangerous, but in the end, well, they both can kill you if done wrong. But the AC is usually used for longer transmission, and which because it's more efficient. And then when it's local, it'll convert to DC, and then you can use it to power devices. As I said, we are with solar panels. We're coming upon a day where DC is coming back in vogue again because 24-volt DC is the typical circuit for solar panels. And with that, 12 and 24-volt, you can run one of the major things that hurt us. Two major things that used to hurt a modern house in electrical consumption was the television, which is about 400 watts or about 3 amps at 120 volts. And the other one was light bulbs. When light bulbs were 100 watts, that was quite a bit of power, right? That was almost 1 amp per light bulb. But now with LED coming along, suddenly those 100-watt light bulbs are now 12 or 15 watts. So we are now literally looking at a significant amount of places. In fact, off-grid people, if you ever inspect an off-grid house upstate, I was recently advising on a house in Africa, in South Africa, and the guy's off the grid. So his entire house is actually wired not at 120 volt, but his entire house is wired with 24-volt fixtures. The only thing that he can't run very well is the refrigerator. So he actually has a propane powered refrigerator. Very interesting client, and he doesn't do it for prepping or anything like that. He just is in a place where he can't get electricity. I was just wandering around Arizona a couple of months ago, and you see the lonely power lines running through the desert. I was at this one point on Route 66, and other than a train line running through the valley, there wasn't another house within 10 miles in every direction. That sounds kind of banal, but we are quite, although not in high desert, but upstate New York, it's like that. You will have people that might be a mile or two away. You might inspect a house. Again, maybe somebody says, go look at this second house for me upstate. And I mention this because actually several of my former students have been inspecting houses that people were, doing the COVID retreat from. And, one of the guys had to drive 300 miles to do the inspection. And I said, I hope you're billing by the hour. And he was, and he got paid very well, but he was essentially looking at a house that had a combination system, and it was essentially off the grid. 12 volt has and 24 volt has a lot of advantages. It's much lower voltage, so it's safer. The wires are smaller, easier to run, and in this particular person's case, because he's completely off the grid, he has to, really account for every watt that he uses. So, of course, the different conductors you're going to see over time. If you are looking 100-year-old wires. I think I showed you last time the interior of a wall that was ripped open that had been burnt by a fire. And inside that wall, the 1920 building in the Bronx that had burned, it had these old ancient BX wire cables. Probably not that one because that one is a 4-wire system. That's more of a green field. But these old wire systems, are armored, uh, for the purpose of protecting the wires inside. And great news is, after the fire, they were still armored. Yay. So let's go through some of our units. Wires, of course, are also known as conductors. A conductor's job is to move heat as efficiently as, or excuse me, electricity as efficiently as possible. Occasionally, they'll take the electricity at the terminus point and convert it to electromagnetic radiation. What the hell is that? Well, if you remember your 8th grade physics, electromagnetic radiation in the infrared spectrum, right, is also known as heat. In the visible spectrum is also known as a light bulb. A little further up is ultraviolet. Everybody's getting ultraviolet these days to try to kill the germs, right? And of course, as we go up the spectrum, of course, the frequency disappears again, and that electromagnetic radiation becomes Wi-Fi. And further up, the microwave ovens, which was actually just an accidental discovery of radar makers. They were trying to make radar for detecting planes, and at one particular frequency, they noticed that a lot of birds were dying at the end of the runway. And of course, unfortunately, of course, this is also one of the weapons of the future, but that's another story. The Chinese recently wiped out a large chunk of an Indian company of infantry by turning a microwave device on them. And you may also know the United States State Department people that were hit by microwave. Anyway, what does that have to do with it? The simple fact is electricity is just the flow of electrons. How those electrons get used is what becomes a little crazy. Now, again, electricity, in an ideal world, electricity moves forever, no resistance. But the simple fact is electricity can go through, officially goes through everything. It's can it go through wood? Yes, but not very well. So wood is an insulator. Can it go through silicone? Yes, but not very well. But sometimes it goes very well. And of course, that's the nature of silicon computers. Today, of course, copper is actually, and if you're smart like me, you're actually looking at the copper markets right now because they're going through the roof. Copper has become very expensive because a lot of people believe that we are going to rewire the world in the next couple of years for the green revolution, which means lots of new copper wire everywhere. Copper prices, by the way, have doubled in the last several weeks. So much so that does anybody have a nickel? Pull a nickel out of your pocket if you have one. The copper in a nickel, I'm jokingly doing this with my kids, copper penny. If it's before, it shows you how expensive these things are. This stuff is. A copper penny today is worth it's mostly zinc. It's not even copper. It's worth about 2 cents. A penny before 1982 is actually worth it. The copper penny before 1982 actually has 2 cents worth of copper in it. It's actually worth twice its weight. A nickel is worth 6 cents this morning. Crazy? I'm saying this rhetorically, but it's a reminder of how price and materials change. In the 1880s, when they built the Washington Monument in Washington, D.C., the capstone, the very top of the Washington Monument, was built with the most expensive material in the entire world. That material was more expensive, most expensive metal. It was more expensive than gold. And it was a great electrical conductor. So it was the perfect thing to put on the top of the capstone of the Washington Monument, which would be hit by lightning a lot. Well, in 1883, that unbelievably expensive metal was aluminum. Sounds ironic, but again, prices will change over time. This is a little bit of a thing about thinking about in economics, because really real estate is economics. People are trying to get the most bang for their buck in a house. Aluminum went down in price 10,000-fold. Literally, we used to consider it the most valuable metal in the world, and today we, you know, throw it away for the drink we just had. So one thing that has kept its price over time, and actually is going up considerably right now, is copper. Why? Because copper is a safe, efficient way of transmitting electricity. But it doesn't do it perfectly, and in fact, it heats up. And the key thing, the thickness of wire is determined by just how much a typical copper line is going to heat up over given a certain amount of amperage. If you're putting, like I said, if you're putting um, 15 amps through a typical NM non-metallic, that's a modern day plastic wrapped material. Let me actually get my good old trusty dusty laser pointer out. You know, this typical material, it's going to be at full power, hot going in, neutral coming back, and a ground there sitting for safety. This wire is going to be 150 degrees, but the plastic doesn't melt till 400, so you're okay. Now, if you start putting 30 amps through this, that copper goes to 500 degrees, the wire starts melting, and you can see that doesn't end well. Now, the plastic is trying to shield it to prevent copper loss. Copper is pretty efficient, but again, you're going over a long distance of time. So as you carry more and more electricity, you want the wires to be thicker and the wires to be more shielded. We all know that. That's pretty basic stuff. Shielding is interesting. Not only are you shielding for the electrical field of the wire, but as we know with the Bronx or BX cable, it actually, you're as worried about animals and things that might be attacking inside the walls. Of course, insulators are poor conductors. One of ceramics, glass, nice but not very malleable, plastics, etc. Okay, here's our quick reminder for you physics heads. Power, current, voltage, and resistance, right? V for voltage. It says E here, but think V. That's the pressure on the electricity. The amperage, the current, that's the actual amount of electricity, electrons that are moving through. The ohms is resistance. That's how efficiently it's moving. And that has a lot of very similar to watts, which is once the electricity's gotten here, this is the current. This is how much how hard it's moving towards you. The ohms is how much is being lost along the way. And then in the end, you're getting to a motor or a light. And that is, of course, releasing the energy, and that's watts. When we talk about lighting, we look at, 1 watt per unit of light for electric bulb, an incandescent bulb. And then, with fluorescent bulbs and LED bulbs today, you're looking at 20 and 30 watts of illuminating light per watt. So that greater efficiency is, of course, one of the reasons why we're switching to the newer electricity. It's just something simple. Some people estimate by, I don't know if anybody's flown over the country lately. I saw this especially when I was flying in a product I was doing in China recently. Actually, I saw in Italy. It was recently in Italy. And when you're flying over at night, you actually see the streetlights of a city. And the older streetlights are kind of a yellowish light, and the newer streetlights are a super bright white light. Now, irony of it is they're actually too bright, and the LED upfitting they're so much more efficient that again, it literally changes the nature of cities. But that's for another story. Big picture is we look at these 4 things: voltage, pressure; amperage, amount of current; ohms, which is the resistance along the way and kind of the drag on the current; and the watts, which is the end product, which is the power that's created by the delivered power to the end unit. Okay. And of course, how much gets delivered is a function of how many ohms slow it down. The ohms, the slowing it down, are a function of how high quality the wire is. A good conductor is copper. A little less good conductor is aluminum. Aluminum is cheaper. Again, we think about these variables: resistance, but also cost. And in the 60s, for instance, copper became very expensive. So when they switched to aluminum, a lot of people used thicker wires of aluminum, which was really cheap, even though it had once been the most expensive metal in the world. Again, my dumb graphic on voltage and amperage. This is a pretty simple one. The voltage is the pressure, the amperage is the actual amount, and the ohms are the resistance to energy flow. By the way, I just remembered, John may not have mentioned it to you. I am teaching the real estate equivalent of this class on Wednesday night. To get your further hours for the class, you probably want to log on Wednesday night at 4 to 8 p.m. Did everybody hear that? I hope you caught that. I'll put a slide up there on the break. But on Wednesday night from 4 to 8 p.m., I'm covering the real estate section on the environment and construction. It's like, for you, it'll be a super fast overview. Anyway, again, we talk about voltage. Now, typical voltage in the United States is 120 volt and 200. When you combine two 120s, you get 240 volt, which is a little more efficient, and that's common for larger devices. Okay, let's start working our way through. What's a transformer and how does it work? The answer is you don't care. You just want to make sure it's not damaging your house. Well, you do care. You want to understand it, of course. A typical line in a suburb is 7,200 volts coming across, right? And when you need it, they grab it down into a transformer. They bring the voltage and a neutral ground, and they transform that 7,200 volt. See, you have 7,200 volt with 20 winds, okay? And then 120 volt at this is inside the transformer. Actually, the amount of winds is a function, wind of the wire is a function of how the voltage is transformed. So if you have, let's use 100. 7,200 volt has 100 winds on the inside. And it is going up against one that'll, on the other side, only has one wind. Bad comparison. So it's going to come out at 1/100th of the wattage or the voltage. Okay. And then once the idea is they're going to do whatever the conversion necessary to get to 120 volts, then goes into the house, over the thing, down into the line and into your place. Now sometimes it is delivered by the poles, which we're all aware of. And the other times it is delivered underground by a service lateral. And this is a box you might see in suburbs. Why do they do this? Why do they put service laterals in the ground? Two things. One, it looks nicer. You don't have any of those stupid overhead poles. Two, it is probably longer lasting. If you do it underground, it is much, if you build it well, it's going to last a long time and you don't worry about lightning storms and stuff. And three, it's easier to maintain because all the maintenance is done at the ground level. Again, here's that diagram of the transformer. Again, I kind of tried to explain it to you. The concept of wiring, high voltage, a lot of wires, down to lower voltage, a few wires, and that converts literally the ratio of windings to winding so it's got twice as many. You're dropping the voltage by 50%. Now, one of the key elements is you think about this is all happening in that bucket, this gray bucket up here. And in this winder, as the circuits are going down, it creates a lot of heat. So the goal is for a transformer that wastes as little heat as possible. If heat is used in this transaction, that means voltage is being lost, energy is being lost. Again, typical up on a house, again, you get a power line and a neutral line, the black and the white lines going into the top of each transformer. And then from there, the transformer powers out and then goes down to power your house. Typical ground transformers, as we said, there's a big honking, super huge service lateral coming into this transformer. And from here, it might go out and power 3 or 4 houses. On the right side, that's not this server. That's actually a panel box. So that's not the picture I should be showing you. Now, what I was trying to show in this picture on the left, on the right, excuse me, is the number of lines coming in. Older houses will only have 2 lines, a neutral and a hot line coming in, which means you only have 120 volt service. So frequently the 120 volts are combined to make a decent circuit. But again, this is the service supply that you're going to see if you have if the box is open on an outside transformer on the ground. And let's make it clear, you are not going to open this box, right? Right. Again, this is high voltage equipment only for use by the electrical utility. You no touch. And obviously that goes with the transformers on the pole as well. But I do want you to understand it. Welcome to Brooklyn. Anybody ever seen these? This is a reminder of what may want to be in your report. What if the transformer going into your house has a bunch of parrots on it? This is, guys, if you don't know this, this is actually all over southern Brooklyn, where thousands and thousands of birds live next to the transformers. Clearly, you would say to yourself, wow, that's electricity. That's, a flammable substance. These birds are dead man walking. Well, actually, of course, as long as the ground, the hot line never touches the neutral line, everybody's okay. But clearly, things like this are an example in the site class you'd think about as something in your report as to a debris that might cause a future problem with your electrical service. Amperage. Amperage is, again, the amount of current coming into the building. That is actually something you're going to note at many different points along the way. The idea, of course, is the amperage is the actual amount flowing, and the resistance to it, just like a water level, when you're putting resistance, it's taking a lot of power. Now, when you're doing panel boxes, for instance, one of the things you're going to note is the amperage. Now, high amperage is really dangerous, okay? With a Tesla coil, you can take 1,000,000 volts at 0.001 amps, and it's no big deal. It'll make your hair stand up. But if you have a 12-volt battery like a car battery at 100 amps, it's going to kill you. The general rule of thumb is some people have said 1 amp will kill you if it passes over your heart. Some people have said 0.1 amp will kill you if it passes over your heart. I don't really want to find out. But obviously, that's what an EKG machine is, which is it's going to stimulate your heart by electrical transmission. And reminding, that's actually also a reminder to you as we go think about safety. Anytime you're dealing with heavy, high voltage electricity or low voltage, you always want to think about kind of detecting it before you touch it. Thermal cameras are good for that, and some of those clamps and testers I showed you already. The parts, wow, I think I'm missing a slide. Anyway, as we talked about wire thicknesses, different types of wires from number 18, which is a low voltage, to number 6 or number 2 or number 0. Those are high voltage lines. The actual line size goes as the number goes up, the size goes down. So the like 0 or 00, those are the big honking lines. Service entries. Now, quickly on this diagram, we look at, this is a good overall summary in one page. Just read this one page and we're done, right? Well, older buildings might have a fuse panel where you'll have this pull-out box. Others may have a lever to disconnect. These are particular fuse boxes. Again, the different types of glass and screw fuses, the Edison and Type S, the cartridge fuses or ferrules you might come across. And then, of course, the breakers, and many things to talk about later about these. These are, again, go to Home Depot, take a look, hold a 50 amp knife blade fuse in your hand and understand what it is. Okay. Circuit, hopefully you don't have older fuses anymore, but the problem with fuses isn't the fuse. The fuses are great. They're really good at keeping you safe. When the wire gets hot, the fuse gets hot. When the fuse gets hot, the fuse melts. Very wonderfully simple. Good protection. A breaker, when the line gets, the wires get hot, the breaker starts get real hot. If all goes well, the breaker flips. But my brother's got a Federal Pacific panel, and it's not going to flip. It may not flip in a fire. Again, amperage, we talk about different voltage sizes. Usually with fuses, it's printed on the fuse. Again, the larger the fuse, the bigger the capability mostly. And the again with oh, excuse me. Again, if you've never played with a fuse, go to Home Depot, play around, or Lowe's or whatever, and just understand how these things work if you've never seen them before. In New York City area, most people have seen them because so much of the housing stock in this area is old. But as you might inspect a single family house in the suburbs or something, they'll be, of course, using a more typical breaker panels. On the left side is the primary switches for the building. This is the primary service cutoff. And why is it on the outside of the building? Wow, some smart ass can come up and like turn off my power at night. That wouldn't be very nice. Well, it's outside of the building for an important reason, which is if there's a fire in the building, they need to be able to cut it off before the firefighter starts pumping water into the building. Kind of a scary thought to think about. This is a typical panel. Again, a typical house panel today would be at least 100 amps. An apartment, like for instance, my apartment has a 60 amp service. Just a much smaller panel box with only about 12 fuses, and that's enough for my apartment. The 1960, they were still using fuses. I'm quite intrigued at that. Now, when you're doing an inspection, you're going to open up. Do you feel comfortable opening up this door? Come on, you got to be able to do that. Do you feel comfortable removing the 6 screws on the panel to look behind? You need to get acquainted with that. You may not want to, you definitely don't want to do it on a live panel, but again, go to Home Depot or something, watch some of the videos online and understand that if you don't take this panel off, you're still performing a fine inspection, but honestly, you're going to add value and really make sure you identify potential major problems if you do take the panel off, as you'll see in a few minutes. Again, infrastructure we talked about quickly. We all know the power plant to the high voltage lines, to the lower voltage lines, to the substation, to the house. So it's like, I think it's like 150K, 50K, 72K, and 7.2K, and then in your house, which is 0.12K. Of course, as the electrical comes in, the high voltage lines comes in, they are then going to drop into your house at the service drop. And at that drop, we got to make sure we're respecting the lines. As I mentioned earlier, you might have breakers that don't turn off properly. These red tabs, my brother has one in his house I just discovered. These were put in the 1950s, 1960s, and they were kind of the earliest breakers, and they are considered to be unacceptable. And that red tab means you're going to put a note that this panel, you're going to record the panel type, which is on the inside label, and the panel size, and you're going to note Federal Pacific, and you're going to say, for this particular ones, there is a recall out on them, and you're going to say to the inspection report, have a professional electrician look at this panel because these panels are subject to failure. Would you like it if your circuit breaker fails? Not very good. Now, with every service, you usually have obviously the main service in, and then a master switch coming off. Sometimes the master switch is a separate box. Most of the time for residential uses, there is a master master breaker or a master fuse that is limiting the amount of circuit in the house. Now look at this. I've got, this is a typical General Electric panel. It's rated at 125 amps. So the wires coming in are like number 2s, number 4s, big enough to carry 125 amps. Once they get there though, you're going through 150 amp breaker, and then surprise, surprise, you have 24 circuits that are each good for 15 amps. So does that make sense? You've got 360 amps of potential service with only 125 coming in. And of course, the answer there is simple, which is at any given time, all of the circuits in the house are not going to be on. So at any given time, from that main panel, a couple of lights are going to be on, a couple of switches are going to be on, the refrigerator will be on, and you're okay until you crank up that central air conditioner, and then bam, you're up 100 over 120 volts. You're up, or excuse me, over 120 amps. Actually, you jump up to 180 amps, and voila, boom, your breaker trips or your fuse blows, and you have no power for the house. Why did the system shut you down? Because you're using 180 amps of circuit, which means all these wires are getting really, really hot. And if they've gotten so hot that they trip the breaker, that breaker may have just saved your life, because that means there was wires getting hot inside the wall, and those wires inside the wall being hot are basically screaming to you, hi, I want to burn your house down. Today, again, electrical circuits may be, it's typical to have an electrical circuit for each large thing, each large device. Obviously, electric stoves, dishwashers, refrigerators would each have their own circuit. Special items like dishwashers and dryers. Larger devices may actually have their own sub panel. So you might have a sub panel for you typically will have a sub panel for an outside heat pump. And you may also, again, have dedicated circuits for things like the oil burner. Maybe something, a very small circuit, which is just the perhaps just the pilot light, but it could be on its own circuit. Where in a house, you might have, again, 4 or 5 outlets on a circuit. And actually, it's very important to think about, because one of the things I emphasize extremely in home inspection is that no house is ever the original design. So it's very common that you'll come across a house that has one panel in the original part of the house, and then you see that it's got a big addition, and there might be an additional panel. In this case, where is your service panel located? It's a house I just happened to see. I snapped a shot of it. A couple different issues I could discuss here, but in this case, I just want to discuss it's a 3-family house. So as you can see right here, on the outside of the house, very easily accessible from the outside, wham, there's 4 meters. Huh? Why 4 meters? The answer very simply is 1 for each apartment, and then 1 for the shared spaces like the cellar and the central boiler, etc. So 4 meters, 3 apartments. Because you see that, and this is actually quite useful, because this is actually I took this picture, but you could get this off a street view, and you can actually see, bang, 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 three units. Con Ed is not going to put a meter on for an illegal apartment. Okay, usually not. They can get tricked into it, but that's another story. So this is very clear that this is a 3-family plus public. So this is legally a 3-family house before you even get to the site. Okay, conductor sizes. This is a good simple chart regarding some of that larger size conductors. Excuse me, on the left side, there's the smaller ones. The white typically is a 15 amp, yellow is typically 20 amp. Those are ones you're going to really frequently see. But as you look here, you're also noting a couple of different strategies. One is your 3-line, hot, neutral, ground. And in this one, it's a 12-3, because that is hot, neutral, ground, which means it is a 240 volt, 20 amp circuit. In this case, that's 240 volt, 20 amps carries about 2.5 times as much power as the 120 volt, 20 amps, because each one is carrying 15 amps of service, but 240 volt runs more efficiently. So you actually get about a 30% boost in that efficiency. And that's why you like to use the 240 when you can, because you're saving, you're having a much more efficient unit. And same thing with the 30 amp circuits. You won't see 10 gauge like this frequently. 120 volt, 30 amps, that's a lot of service. And most of the time you're running a 30 amp circuit, they're going to run a 4-line 240 volt circuit. What am I talking about? Well, the answer is, first of all, notice the colors: white for 15, yellow for 20, orange for 30. Second of all, notice the question of whether you're 120 or 240. And this one, it's 120, hot, neutral, ground. And this one is hot, neutral, ground for 4-line. And again, that's important when you go back to the panel, because when you're in the panel, to make 240, you have to combine 220 circuit breakers to create that panel. And as you can also see, the sizes. 14 gauge is the number. That's the size of the wire, the copper, the thickness of the copper section. And
Brian, I have a question.
Yeah, go ahead.
The standard amp for regular, a family house will be 20 amps. Is that what?
No, let's talk our units. Okay, first of all, in theory, the whole house is 120 volts. Okay, and sometimes you can combine 120 and make 240, and that makes these 4-line ones more efficient. Now, the typical circuit in a house typically is 15 amps. This is a typical residential circuit. More specific ones for larger devices will use 20s, and really large devices like refrigerators will use a 30 amp circuit. Now, as I said a minute ago, we talked about this panel here. This panel has a big breaker on top, and that breaker is, according to the panel box, this is 100. Let's say it's 120 amp breaker. So while you have 20 15 amp circuits, the overall service for the house is, again, at least 100 amps, and in this case 120 amps. And all told, all these devices on this circuit can only use 120 amps at a time. So the general service for a house, as I said here, the main service for a house, minimum 120, minimum 100 amps. And the way you can tell in your inspection is on the primary panel, it's going to say that this panel, again, all you have to do is look for the largest breaker, because that breaker controls everything else. So if this breaker is 120 amps, that's all you're getting for the house. A typical house today, again, a new house, at least 150, 125 to 150 amps. But it's funny because, ironically, we're in this catch-22 that as the houses get more and more electricity wired, the devices are actually getting much more efficient. I mean, a house was designed for 100 amps because there was going to be 20 100-watt light bulbs. And now each one of those 100-watt light bulbs at 120 volts, that means they are, each one of those light bulbs is about 1 amp of service. Today, that same light bulb is LED and uses about 1/10 of an amp. You guys may remember the really big television sets. A tube television set would use 600 or 700 watts. Very often it would get its own 20 amp circuit. And today's television, a brand new flat screen today, instead of using 700 watts, is only using 50 watts. So again, as much as we're making higher and higher voltage for the houses, the good news, particularly for the fire departments, is the devices that are in the houses need less and less power. I'm sorry, did I fully explain that? 15 amps is an individual breaker, okay? 20 15 amp breakers are all connected to the house service, which is 120 amps. Does that make sense? Again, because not all of those 15 amp breakers are going to be used at the same time. Now, the numbers 14 to 10, the number goes down, the wire gets bigger. And on the right side, you're getting wires so big that actually copper's a pretty flexible metal, but it's not that flexible. And your biggest fear is if the copper breaks inside the line, because then you're actually going to have arcing inside the line, which is going to start a fire. So with larger cables, you'll actually find this, which is braided copper. And the braiding inside of the copper line lets that copper line be more flexible. And that's why you see the braiding versus solid copper in smaller lines. Okay, let's get back to that service entrance. So you come off the pole. The utility, remember, what is a utility? A utility is a company that has been given permission to sell electricity to you by your government. So down in Texas, the state of Texas gave permission to the electricity companies to sell electricity. They unfortunately, their cost to make the electricity went, I don't know if you've heard about this, but the cost jumped from last Friday, the cost jumped from $3 per unit of natural gas to power the power plants to 5,000. So they literally just turned off the power plants. They couldn't, the electricity went crazy. Big point is that's a utility. A government has told them what they can charge, and a government says, look, we'll let you have access to all the roads and you can put your things in and you can charge money, but you can't charge too much. So that's the nature of a utility. Now, of course, one of the things a utility has to do is make sure its stuff is out of the way. Pretty simple. The United States Department of Transportation has basic requirements how high and tall you have to be so a typical truck can drive through. Semi trucks are a very specific size for a reason, because that's what the law says. They can be 53 feet long and I think 13'6" high. So in this case, because that truck is going to be 13'6", your wire cannot be less than 18 feet above the road. Again, you want to build in a little clearance. So that's a typical clearance. If you see a line that's sagging really far, that's a problem. And why is it a problem? Anybody know? What happens in the summertime? What happens to this line? Well, in the summertime, copper, of course, people use a lot more air conditioning, and the copper line will actually sag. So this main power line coming into a house has to be at least 10 feet up and 12 feet up and 18 feet up, because when it's hot and it's running full 100 amps of service into this house, that copper line is actually not going to be 18 feet up. It's going to be 15 feet up. So that is one of the challenges. You may remember, if anybody's driven on the New Jersey Turnpike recently, they have these big red balls on the transmission lines alongside the highway. And what those are there for is kind of odd. Believe it or not, those copper wires could get so hot that they'll sag so much that they'll actually touch the ground. It sounds impossible, but sadly, this is one of the reasons for a lot of the fires recently in California, where the copper wires, so much electricity was going through it, the wires sagged and ignited fires on the ground. It's actually the reason, for you historians in New York City, it's the reason for the 1977 New York City blackout, because some electrical poles upstate, the wires expanded, going really hot, fell down towards the ground, touched the ground, and started fires. Now, again, so we've got that primary line, usually number 2 wired, rated for 150 amps, coming into the house, dropping down into the meter. Now, this is pretty serious voltage, right? So the utility is required to deliver to your house and attach it to your mast. And then your electrician is going to grab use some very heavy service entrance cable, which is very thick wire, in this case rated for 200 amps, and the cable is going to drop down into your house. Now, the utility is responsible to take it to the pole, but after that pole, it's owned by you. Okay, so your electrician then comes in, jumps off of the wires, it does the SE down into the thing. And why is this protected? Because rain and snow and wind, you don't want any water. Water plus electricity is not fun. In this case, if the water got in, it would drip down the pipe and it would drip into the meter. And we'll see some examples of what happens with the wet meter in a bit. Again, service drop clearance, just like the road, 10 feet from people, at least 3 feet from the roof. On a sloping roof, you don't want to be within 8 feet of the side. And again, kind of simple diagrams here. The idea very simply is, if the wires are down, I was in a place, I was renting a house once, I was going to buy it, and the guys had built it totally illegally. And these wires were only about 6 inches from the roof. Not smart. Again, and even worse, if the main wire was about 6 inches from the roof, and then we got 18 inches of snow. So all of a sudden, you're talking about electrical service that's coated with water. Not good. Now, luckily, the snow melted pretty fast because of the heat on this wire, But again, you can see the safety issues here. So those clearances or service drop clearances are there to protect from you getting shocked, as well as snow, as well as any other crazy thing happening. As an example of the wiring, literally, this isn't my house, but it's very similar to what my house was, where the wiring is running to the mast and they changed locations. So now all of a sudden they're running to the back of the house and the wiring is only a couple inches above the asphalt. Again, you get that wire heated up, it's going to shrink, and that very hot wire is going to touch the asphalt, melt it, start a fire. Another thing to this service drop, interesting problem here, the mast itself is kind of pulled away from the building. There's a lot of tension stress on this wire. So it's, first of all, it's the main lines attached into the building and then jumping up into the service drop. And in this case, the service, the mast is actually ready to break off, and that would not be good. Service entrance cables, again, this one is going right into the side of the house. Older houses, you'll see this. Again, it was legal back then. The downside is what makes this really bad is that the insulation is broken away right at the intersection to the house. So it's, paint has been put on top of this and it's touching wood and the wire's going to get hot and it's not good. This one is even worse perhaps because, again, the service drop's coming in structurally and then it's tapping off and the wires are touching the gutter. Now that gutter is made of aluminum. Hello. Aluminum is conductive. So you basically have a very expensive charged heating device on your house. Probably good for getting rid of snow, but it's very, very dangerous. So again, as you're inspecting the service entrance, we've seen the power come off the pole. We look at how it comes down to the house. Is it attaching safely? Is it properly insulated? If you have an older house like this, we understand sometimes it's going to go right through the wood. That's the way it was done. Again, remember, this is a 2-wire system, so it's old, hot and neutral, which means it's only 120 volts. And with that 120 volts, you still have a potential fire hazard, and that's a risk. Now, underground service, of course, the service lateral is when the line comes underground. And in this case, it came in a chase underground and then stubs up into a primary service area. In this case, 1, 2, 3, 4 meters. So, and in the center is the wiring that goes into it. So this is, again, an example of a 3-family meter base, and very thick, heavy wire slowly bends into each one of the meters, and then from each meter, the primary service goes up to the panel in each one of the apartments. Now, Greenfield, or this isn't a service lateral, but this is a line for like a 60 amp circuit out on the outside of the building to a sub panel that is powering an AC unit. And in this case, this is one of the rare cases when you can use flexible wiring. But as you can see, this ain't your normal flexible wiring. This is very heavy gauge protected steel line that is providing service on into on the outside of the building. Again, we talk about that service lateral just as it might go overhead into a house. So most people think it looks nicer if there aren't wires going into the house and they run it underground. And this is actually, of course, the magic of New York City. Much of the power in New York City runs underground, which luckily means during windstorms and rainstorms, very often the reliability is there. The power is delivered much more efficiently, but what's the downside? Well, that's a lot of digging and cutting and wiring. So New York City is some of the most expensive electricity in the United States. Again, the line comes down off the pole, goes in. There might be a transformer on the ground, and then it accesses into the house. Again, there's a typical raceway being installed. PVC pipe to keep it waterproof. Now, it's electricity, so you don't have to be 4 feet down like plumbing, so it's a little easier to install. But you do have to make sure it's marked so nobody makes a mistake. Again, a typical raceway. This is another multifamily arrangement you might see on a house. Let's see what's going on here. This looks like the initial power switch for the whole building. It's being stubbed up from the ground into this switch. And then this switch goes to the house meter. And then as it goes along, it's passing through several other meters. And this meter then goes out to the, let's say, the lower part of the building. And this meter is then going out into maybe the upper part of the building for perhaps 2 different apartments. But the raceway, when you're dealing with high voltage lines, you want it at all times, it has to be protected. And one way is to put it inside a wall, but that actually can be a little risky. Some people like having it on the outside because it's because when electricity is exposed, it's easier to repair. And it's also, other than water damage from the outside, it potentially is safer because if again the electricity is buried in a wall and something goes wrong, nobody will ever know until the fire starts. Today, the meters themselves, a lot of older types, you may not be able to see it here fully. Let's maybe zoom in a little bit. I said it wouldn't zoom today, but well, it won't actually. The meter on the left is an old style rotating meter. The meters on the right, the digital meters of today, are becoming more common. You know, I just remembered, I think what this is here is, this is meter number 1, meter number 2 in, this meter was actually, I believe, a solar panel. So it was actually feeding power into the primary transformer. We'll look at that more later. Again, we talk about power. We are dealing with service coming in, and at any given time, lines can go wrong, lines can break, and you got to be able to have a ground to neutralize the lost electricity. One potential type of ground, again, with houses, there are many ways to do it. 1 to 4 family houses, you'll usually have either an iron bar embedded in the ground, or you might be attaching to steel or copper pipe that is leaving the house going into the ground. Obviously, you can't exactly use plastic pipe as a grounding line, right? That wouldn't be too bright. Inside the panels, the ground, you know, again, part of the panel box is managing the hot, neutral, and ground, consolidating the ground and getting it out to a grounding device is important. The idea, again, in a typical panel, you may be able to be comfortable enough to take the panel off and you see this inside. You'll see the normal 15 amp circuits, the larger 30 and 40 amp circuits, but also you'll see the hot line coming in. That's 2, in this case, it has 2 blacks, which is hot and hot, and then the silver is a neutral line. So hot connects on the left side of the breaker to neutral on the right side of the breaker, and bam, you got a 15 amp circuit that then goes out to the house. Although I say that we see a red and a black line here, so that's probably not a 15 amp circuit, but you get the idea. And each one of these then is bonded to the ground, and then the panel's grounded, and from there the panel is connected again to either a copper line or a grounding rod out in the yard. Very, very important. Again, a typical, you got the service coming in and you got a line. This isn't the ground rod is not a wire running on the surface. This is just a diagram somebody drew showing the locations of the 2 copper spikes driven into the ground as grounding. Does it matter? Yeah, it saved my life. House I grew up in, we got hit by lightning once, and loudest sound ever heard, but the grounding rod absorbed the lightning, and I'm not dead. Yay. Proper grounding ensures that overcurrent protectives as well as lightning will operate fast when responding to ground faults. And fast means safety. Particularly GFCI, if it activates in 100th of a second, you're safe and you might get a little pinch. If it activates in a second, you might be dead already. So making sure that grounding is there to help the GFCI and AFCI circuits, very important. Here's another view of the underground service, pretty basic. In this case, a plastic sheet. Again, it's only 18 inches below ground. And one of the things it does do, very often buildings move, they'll settle, and they'll also have earthquakes. Again, as a reminder from the previous class, yes, earthquakes. Upstate New York had a 4.7 earthquake a couple of weeks ago. So in the state of New York, you are actually dealing with a seismic zone. Upstate New York is actually, in theory, by code design, it is as volatile as the San Andreas Fault in California. So again, every time, whether it be plumbing or electrical, you got to think about the movement of the building, both from freeze thaw as well as seismic and wind loads. And in this case, a simple slip joint is all you need to to get the electrical service or the grounding into or out of the building. And that's called a USE, or underground service entrance, or also known as a service lateral. Again, grounding in the panel again, what it might look like. We'll go to this more later. This is an ideal goal. The grounding is screwed in properly. I once opened a panel and this wasn't properly sealed. It wasn't connected, and which meant there was effectively no grounding for the service. This is, again, a great image, a correct image of in this case, not a copper line, but a copper sheet. And the reason why it's a sheet is it's 4 inches wide, and you basically only need about 1/4 of an inch to make sure that the lightning strike is okay. And more importantly, this is going to melt in a lightning strike. So this copper sheet is a preferred design for me. And then it goes to this copper spike, driven, or a steel spike driven down into the ground. If there were a copper spike, it costs some money. Again, in this case, the grounding system added to the house. Interestingly, they're picking up not only the grounding system. Actually, this grounding system is for the house, but it's also for a low voltage system. This is the telephone fiber, the coax fiber for your cable line coming into the house. And yes, it can get struck by lightning too. So this system, actually, in this case, it's a low voltage system, but it has its own grounding. Good design. House meters, again, we've gone from the analog meters of the past to the digital meters going forward. You do want to watch out for damaged meters. Meters are usually sealed by the utility. No touchy. You do not open these. You do not try to open these. And in fact, there's a tamper-proof lock on them, a plastic seal on them. And if that tamper-proof seal is done, the electrical utility will cut your service. And one of the reasons, of course, in this case, one of the things you might find in an older house, you see a junk here. What's this? Wow, man, I'm looking right in the electricity. Well, that's the old panel. That's the old meter mount. A newer meter was added. So good news is they rewired everything. So this is all safe. It was just really stupid that they didn't take it out. I guess they got lazy in their demolition. Again, the entrance is probably inside the building. It's stubbed up. Actually, excuse me, it's probably coming in from overhead. The overhead comes down, goes to the meter, and then goes down into the house. Well, the old one used to too, but you can see they cut the line. It doesn't go to the meter. It doesn't go up to the masthead anymore. And then the copper is still there going into the house, but they haven't cleaned it up. This is actually a maintenance issue. I mean, open panels still visible. Repair or replace should be removed completely to prevent from electrical hazards. On the right side, again, this is a meter that somebody's tried to rip the face off of, and that's a real big problem. Not only is it a problem because water and animals can get in there, but it's a problem because the utility is going to cut you off. So this needs to be fixed by a certified electrician or the utility as quickly as possible in your inspection. And why would this happen, by the way? Well, when houses are left vacant, people go and try to steal stuff. As I mentioned earlier something very important that may have sounded like an economics lecture. And I said copper prices are going up. Well, that's a really big deal. Do you know why, guys? Because when copper prices go up, vandals will go in, cut the supply at the meter of the house, cut the master switch, and then steal all the copper wire in the house. And next thing you know, $50,000 in damage gives them $100 in scrappable copper line. So that's actually something you really need to, we haven't worried about in the last couple of years. I'm going to put that back on your radar. As you're doing home inspections, look for vandalism in both the plumbing as well as electrical as people go in and try to steal the copper. Again, another quick look at house meters. The one on the left is particularly important. It says bi-directional. Well, that's the future. In fact, what this is a meter. Obviously, they're billing you for power going in, but bi-directional because you are adding through a transformer that's a separate system that you don't have to inspect. That solar panel is actually pumping electrical back into the system. So in this case, I particularly put note that this is a bidirectional meter. And then as I'm walking around, I'm going to look for, when I go down the cellar, I'm going to be looking for where that site provided electrical power comes from. Again, on the right side, typical meters, there's lots of different types out there you'll see around the state. Of course, today, most of them are wireless because they're sending a Wi-Fi signal out to the street. And as the meter guy walks by, he's just, or meter lady, whatever, and they're being able to just use their tablet or laptop and get the signal to read your meter. Because in the end, you got to pay your bills. Again, another thing you might want to come across is that you have a removed meter. Now, this is open. To show you something pretty scary, which is now this meter. I mean, they pulled the meter out, but in this case also they went a little further. They unscrewed one of the lines. As you can see, the very, very thick lines, those are like number 4s, and it's braided copper cable about a 1/4 inch thick. This stuff becomes so hard to work with that it actually, you can't just bend it very easily. You literally have, these boxes are large because, as you can see, you have to have a little room to bend these wires. And that's actually the purpose of it. So this is behind another meter. Again, the line comes in, the power crosses over the line, gets metered, and then continues, and then goes out into the house. More multifamily meters. Again, what are we looking at here? Again, why is this raceway here? Because that heavy wire doesn't bend easily. In this case, a large service drop coming in to a chase with very rigid, hard to bend wire. So the wire has lots of protection in a box in the raceway, and it also then turns slowly into each meter and then goes out into each house. As we said, inspecting the mast, we look for, is it sagging? Is it has water damage at any point? And are the splices working? Obviously, if the splices aren't working, you're not going to have power inside, but this is a good image. One more time on the service drop to the lateral. The company pays for the wires coming in, usually a steel line for reinforcement, and then copper lines to bring the power in. And then it gets spliced and it's up into your house. Sometimes this will anchor into the side of the house and then go up into the mast, and sometimes it'll just go straight into the mast.
Okay, excuse me.
Yeah.
Question, Brian, thank you. The electrical system, everything we're looking at now, are we simply inspecting that the systems were installed properly and proper amperage, proper distribution, junction boxes and such? Or are we just checking the components and their condition?
You're looking for, you're doing a visual inspection, okay, to make sure everything's in order. Today, as I said, you might see that some of the copper lines are stolen. But also things that to report are, for instance, if you see 4 lines coming in, you might know, or in this case, a 3-line one, you got a neutral and 2 hots. A 3-line here means you've got a 240 volt service, and 240 volt service is good because you can run more efficient devices. Are you designing the wiring? No. Are you certifying the wiring? No. Are you testing the heavy wiring? No. But you do want to be able to say that this wiring is coming into the house, it's anchored properly, it's not a potential fire threat, and it looks like there's no water damage, so there's no maintenance cost to the potential future owner. I'm going into a little detail, obviously. In your inspection, you need to have 10. I can do this the 10-minute version or the 20-hour version. Well, the 10-hour version is what they require for the class, but an electrician goes into much more detail. As I said, with the wire sizes, the larger the amount of circuit, larger amount of power you're bringing in, the larger the wire. And as the wire gets larger, the number goes down. So as we said, a 14 gauge, number 14 or 14 gauge copper line is good for 15 amps. And then 12 is 20 amps. Number 10 is 30 amps, et cetera, down to double aughts, 2/0, that's often referred to as double aught, that is pretty big wire, and that's good enough for the wiring ampage. Why do you care? Because when you're looking at the panels, you want to make sure the wires appear to be roughly the right size. Obviously, location's important, like these. Clearly, this is pretty stupid, right? Less than 10 feet. That's just a shock. This lady's not very tall, but it still could be quite risky. Now, as we've looked at the wires, we're starting to ask ourselves, and this is what we do inspect. I'm not going to certify this meter. However, I am going to really be worried and put notes in the report that this meter has a lot of corrosion around it in the meter box. Why would this meter box be corroding on these bottom corners? Because water's getting in. Whether it be vapor or water dripping down the masthead, there's a lot of water in this meter box. Water plus high voltage is not good. Okay. Now, the underside of the meter box, you can see some shoddy wiring and some visible lines. That's not good either. These are kinds of things that you want to look for as you're inspecting the incoming service. Why? Again, rust generally is a pain. I'm sorry. Did I answer your question fully? I kept going through that, but did I cover all the points you were wanting to discuss?
Yes, please, thank you.
Okay, yeah. See, the idea is again, let's go back to the original. You're looking for visual clues as to potential problems with a building. Okay. I don't need to know that this meter works. I do need to report that there's a lot of rust in the meter box, because that's telling me something's wrong and that they need to then call another person, a professional electrician, to find out what's wrong here and fix it. Because I've just identified, I buy the house, suddenly I got to replace the meter and I'm going to get a $3,000 bill. You as the home inspector are trying to identify those problems for me before I buy the house. In this case, this is a good website online, Inspectopedia. You should take a look at their stuff. I thought this picture was good. Again, there's a school of thought for inspectors that your only tool you use is a ballpoint pen. And the reason why is that it's, of course, plastic. But in this case, the ballpoint pen was literally, just by pushing that in, you could see that this meter box was loose, and that's not good. Loose equipment, no good. Here's another example of meters. Again, if you could look at this, can you understand what's going on here? Let's look kind of down the list. You got some sub panel boxes here. You've got some very old sub panel boxes. You can see by both the corrosion and the design. Here we got a dead meter that got removed and replaced by the utility. Now there's the master cutoff switch. That's good. And here's a newer meter over here, better shape. And then the raceway going out, probably bringing the electrical service up from the ground, and then into the. I don't know, a couple different ways this could be, but clearly my point here is, look at all this low voltage crap wiring hanging around. Now, usually that's cable and stuff. Again, you don't have to worry about that too much, but if it's loose and you see exposed copper, those are parts of your problem, and that should be inspected. What you really don't want is, people splicing the wires without proper protection. Tree branches are another big deal. I love these pictures. People, over time, the power line doesn't move, but the tree decides to grow. And of course, the power lines are on the street, particularly in New York City. This can get quite humorous. The sidewalk's usually 10 feet wide, and there's usually a street tree, and there's often power lines. This was in Forest Hills, I believe. And in this case, a 50-year-old pine tree, they had trimmed it many times, and the pine tree, it's still alive because it went to the right, because all its left sides got cut off. And of course, they have to maintain clearance to make sure that tree never damages the power line. What's going to happen? Of course, a windstorm's going to come along, and bam, the power lines go down. Now, there are some basic rules the electric utilities require for clearance around primary and secondary lines. Roughly 3 feet clear, and again, trees should be trimmed back. I think we looked about this in another one. Again, a classic example of really stupid trimming, but the idea is the same, that you have to keep a clearance around the electric lines. There's our masks yet again. We looked at this picture already. This one, again, the line coming in and then looping up into the service drop and down. My problem here is this is a very wood surface, wood siding, and the electricity is only about a foot off the top. So that's kind of a fire hazard to me. You put 2 feet of snow on this, you can see the damage. Solar. Now, solar is definitely a whole different game these days. Technically, solar is separate from your inspection. This is very important. It's going to be everywhere very soon, okay? So you may want to get a certification to add solar to your inspection, at least certain parts of it. Now, you're not going to certify the solar panel. That's, you know, that's for the installer, and particularly because a lot of these are leased. But this is a good image, by the way, of what a thermal camera can do for a solar panel. I don't know if you noticed this, but look at these deficiencies on the left side. Anybody want to guess why? These solar panels have been hit by hail. If anybody was walking around last night, I was at the office yesterday, and in the office today too. Sometimes the solar panels can get smacked pretty badly. I also saw one at a city park down on the East River, and the kids had reached up and ripped all the solar panels down. And unfortunately, when they ripped the solar panels down, not only did they break the solar panels, but, and this is why you care, the mounting of the solar panels. They're not just sitting on the roof, they are attached through the skin of the roof into the structure below. And the biggest threat is not the weight of the solar panel, but it's the lifting of the solar panel during wind. So it actually can put quite a bit of stress. And that stress point, those stress points, the mounting points, are what you do want to try to inspect both inside and outside of the house, because that's where water can penetrate. And that's really the important part of your inspection. Again, this one on the left is quite interesting because when you can't see it, but upon scanning, you can see the damage to the panels. Again, not part of your inspection. If you say solar panels noted on roof, and you're going to say mounting penetrations in place. But what's actually very important with the solar panels is, and you don't see it in these pictures, but there's wiring that runs up on the roof that the solar panels feed. And in fact, Walmart is actually suing Tesla right now for several $billion because Tesla put a whole bunch of solar panels on Walmart stores around the country, and the wiring between panels and then into the buildings, the connections went bad over time, and Walmart has had about 50 fires on the roof from solar panels. So that's actually one of the things I really carefully check. Although not officially inspecting the solar panels, I am going to look at the wiring of the solar panels as a potential fire risk. Not only here, but also from here, it's going to go down into the house through a transformer and then back into the primary system of the house. Again, solar panels, you deal with from a structural perspective as well as an electrical perspective, but the electrical part technically is part of the solar panel. But I don't care if I see fire damage and burning and singeing. Okay, look at this panel. It's 8 inches above the roof, right? Now, it sounds rather tacky, but Germany loves to say that they are completely green and their wind farms, and this just happened in Texas, exactly the same. Their wind farms and their solar panels can, at times, on a good day, power most of the country. However, I always ask this question, I say it again. Imagine this roof with 2 feet of snow on top. You got the skylights are covered up. That's a potential ventilation problem. But the solar panels are worse because you've got the snow, and the melting ice is going to be right next to exposed electricity. So if the electrical wiring is not in conduit up here, you definitely want to raise an issue. More solar arrays, again, not part of your inspection. You guys, there's just, I mean, again, this is going to be everywhere, literally. It is legally required on all new buildings in New York City. And pretty soon they're going to do it for all of New York State. And honestly, it's a fire trap, and it's going to cause a lot of people to die. But it's green, so it'll give us cheap electricity. I'm being kind of brutal, but this is the way you got to think as a home inspector. You got to ask yourself, is this safe? What can go wrong? You know, these panels are 3 inches above the uh, surface of the roof, and that roof, for the most part, that roof is probably very cold. So the snow's going to stick, the snow's going to pile up, the snow's going to blow underneath, and either the wind will try to pull the panels up, or it's going to cover the panels. A, they won't work, and B, the electricity can be a risk. But C, it's good to have. Again, quick reminder on solar arrays, not part of your thing, but it's really the same as the overhead line. You've got think of this, the PV system as your electrical pole. Hot neutral ground comes in. You've got an emergency disconnect. You have an inverter, which is the inverter is very important because it's taking the 24-volt DC current, converting it to 240 volt, in this case, 120 or 240 volt AC, in which case you can use it in the house. And we like that. Again, on a good sunny day, your electricity bill goes to zero. That's nice. But this stuff ain't cheap. It's got to be maintained. And your inspection is, again, where do you start? You're actually kind of stopping right here at the electrician when it connects to the main primary house electricity. But in the future, I'm betting that New York State is going to change the home inspector's law that we're going to have to inspect solar panels. So again, think of it as really simple: source, protection, conversion, use. Okay. And of course, grounding. We like grounding. Because solar panels can get hit by lightning too. Okay, solar inverters. As I said, the solar primarily is 24 volt. Uh-oh, hold on. I just lost my signal. Whoa, that was scary. So one downside of Zoom is it has a wonderful bad habit of kind of just shutting off. So if my screen goes dark from my laptop dying, whether it be from overheating or Zoom having a bad day, I may lose signal on supply, in which case everybody just, although I do have my second line, I'll talk to you through my other phone. Make sure we can, you might have to reboot and join back in. I'm sure everybody's done enough Zoom over the last year that we all know that this stuff is a little erratic. Anyway, back to the lecture. This is a great exterior image on a house. And the reason why is it shows the primary service. The service is coming up from a service lateral, going to, again, the meter, the primary switch, and then, but surprise, surprise, we also see a smaller set of lines that is powering the solar from the roof. It is also metered, a different meter, not within your purview. And then it is putting electricity back into the building. So just kind of start thinking about seeing solar more and more, guys. It's going to be everywhere. Okay. Again, and upstate, you may also just as easily find wind turbines. I mean, don't believe me? Look at the seal of the city of New York. The seal of the city of New York actually has a windmill on it. Humans have been using wind for as long as, time immemorial. And we're definitely going to be using a lot more of it in the future. Okay, so again, we look at this here. What do we care? We only care about the high voltage stuff or the full voltage stuff, which is the 120 and 240 volt. But think about, if I see a singed wire on this line, that's a problem. And, at that point, you're going to say, singed wire, you're not going to open it up and fix it. You're going to say, have a licensed electrician come take a look at it. There's our outside wiring again. As a reminder, today, the house can be the power station. And like I said, a lot of people in Texas would wish that were the case this week. Another type of power station you might have in your house, much more common, and I imagine it's going to be very common in Texas next year, is electrical generators. And now this, again, a very specialized system. We talked about this in the site class. This is outside of the scope, but it does the same thing. It has an outdoor source, a generator. The generator comes into the house, has a special connection on the outside of the house. And then it has a transfer switch. Now that transfer switch is changing the conversion, but also it is it gets a signal that if the primary power from the building fails, that usually within 15 seconds, one of the ways you can do it is within 15 seconds, it'll send a signal, turn on the generator, start producing 24-volt voltage, and then ship that voltage back into your primary circuit. And that's the idea of an emergency generator. But again, this is why you're going to see the extra panels. But this, you'll simply say in your report, exterior generator attached, to be serviced by others, unable to verify, because this is a specialty item. You're not certifying that it works. You do certify that the furnace works. You don't certify the generator works. As I said, batteries are going to be the future as well. Get ready for them. Both car chargers out in the driveway. Tesla has a power wall, Generac, LG. Everybody's jumping into the power market. Its downside is it's 1,000 times more expensive to have backup power, but hey, it's worth it, right? If you don't know, I don't know if you guys saw the numbers. A great number came out yesterday. Tesla, because of the huge spike in electricity prices, because of no natural gas on last week, if you needed to fill up your Tesla car with electricity on Wednesday, the electricity was so expensive that it cost $900 worth of electricity to charge your electric car. I thought that was quite interesting. Your house, there's many arguments that the car and the house are going to be interactive devices in the future. I know a lot of people have been screaming, for instance, that your car, let's say you've got a hybrid car, that in an emergency, that the electrical power and electrical generation of a hybrid car could actually power your house in an emergency. As we talked about cutoffs, what's going on here, the outside of the house? We got the primary cutoff and the secondary cutoff for, let's say, an air conditioning unit. This is an example of, on the right side, a sub panel. Primary service is inside the house. The service comes out into a junction box on the outside of the house, and then goes to a flex line down into a sub panel, and that sub panel then powers your heat pump. Now, a heat pump like this may use 50 amps of service, 50 or 60 amps for these. Now, hey, there's no combustion, there's no heat, but those compressors are very, very powerful. A 50 or 60 amp compressor may use half of the electricity of your house. So you obviously are checking for singe marks. One of the things I don't like about this, and I thought this guy took this picture, is quite smart. Again, a lot of things going on in this picture. One is a very big user, but it's right next to the gas meters. Dumb. And also, again, you get almost like stray voltage. You've got the low voltage cable box nearby as well. So in this case, you're doing the meter on the end, or the main power on the inside, coming to a junction box, dropping into this unit. And again, I don't like electricity near gas. It's just my thing. I've been to too many gas explosions. But these are things to look at. But why is it gas? Because actually, sometimes these air conditioners are now powered by gas as well. They'll have electrical and gas, but reasonable, safe distance is what you want to think about. Okay, back to the main panel board. And main panel board is so exciting that we are going to take about a 5-minute break, because I just realized I've been talking for almost 3 hours. Hopefully you guys, and I also noticed that you guys can't see me, but I don't think you care about that. Again, I'm going to take roughly 5-minute break to stretch my voice, and you guys can stretch out a bit. And 11:42, I'll start back at 11:50. Okay, so go stretch. And I'm going to take care of some stuff. Back in 8 minutes. I'm still here. Hope everybody's doing okay. I'm going to restart in a minute. Everybody check your email in the next couple of minutes. I am attaching today's lecture. Hopefully it'll get to you well. I'm worried it might be too large. If the file is too large, I'm going to set it up as a Dropbox. And anyway, you can follow the rest of the day with the lecture and might help you out a bit. Oh, darn. Anybody have any questions so far, by the way, as I get ready to send this email?
Hey, Brian, I didn't receive the previous emails. Maybe my email is not in the list.
Now, what's your name again?
That's Jamshid Sawab.
Jamshid, you let me make sure. I'll tell you in a second.
Sure.
Let me type into my spreadsheet while we're there. I've got you as, you're not on the list. Well, glad you mentioned that. Jamshid Sawab. Tell me your email, buddy. I think I sent you something the other day, but tell me it again.
Yeah, let me type it in the chat.
Okay, do that. That's great. I haven't been paying much attention to the chat today, but I'll take a look. jamsawab@gmail. Got it. Control C. Let me just do a little Excel splicing and make sure you're on the list.
Brian, this is Ron. I didn't get the email.
Ron, what's your address?
Ron.GeanDennis, JeanDenis.
Hold on. Are you registered for the real estate class or the home inspection class?
I registered for both. So.
Okay, let me just set you up here.
Yeah, I've gotten emails from you before though.
You did? Okay.
Yeah.
Yeah, it depends on which. When I send them raw, I go from a spreadsheet. So let me just get both of you guys.
I would type it in chat for you if you want.
Hold on for a second. Yeah, if you could put it in chat, that'd be good.
All right, I can do that. Yeah.
And Brian, can we get the previous PPTs of the last class as well?
Yes, they are, again, early versions are already on the Dropbox, so you should have that. And if you don't have the Dropbox listing, we'll solve that as well.
No, I don't have the Dropbox listing.
Okay, so we're 0 for 2 here. We'll try to take this out.
Thank you.
Hold on. Excel is misbehaving for me. Guys, anybody know the limit? Is it 25 megabytes for Gmail? Anybody know what the file limit size is?
I believe it's 25.
Yeah. Okay, so that's good. I'm at
Open or in attachments?
I'm trying to send it as an attachment.
25 megabytes. It used to be. I don't know what it is now.
Yeah. We'll find out in a minute. I'm sending, see if I can send both last time as well. Let me get the 4 per page.
You could use Google Drive. I think Google Drive is like 10. Up to 10.
I can, but that'll take me time to set up. So
yeah.
Again, that's why I have the Dropbox, but I'm trying to do this on the fly in the middle of the lecture, which I shouldn't be doing, but hey. So there's one is interior. Okay, 1, 2. Open. Oh, I see why. There we go. I'm sorry, who was the last person to say I needed an email?
Yeah, it's me, Ron.
Ron?
I put it in the chat box.
Okay, there it is. Ron.John Dennis. Denis. Couple more seconds and everybody should be able to have this. There it is. Okay, I'm running right up against the 25 megabyte limit. So hopefully you guys will get this. Just make sure I have all the addresses. Oh, I see, Ron. You're in the last class. That's why I didn't see it. I've got you further down the list. There we go. Okay, so hopefully you guys will all get this and the file size isn't too large. If as soon as somebody gets it, please confirm to me that you've gotten two large PowerPoint files in my email. It'd probably take a minute or two to work its way through the internet. If not, I'll send the lecture separately. Okay, so let me know when you get it. Let's see where we are. Okay, back to the fun. We got a lot of ground to cover. My goal is to push on till about 1:30. So we do have about an hour and a half to go till the next break. So let's tough it up and make it happen. I'm going to try to pick up the pace a little bit. I've been repetitive so far, and I hopefully that repetition has kind of pounded this stuff into you a little bit in terms of what you want to be looking at, as well as what you've got to study more of in the future. Again, not in a classroom environment. My pictures are only as good as I can make them, but I want you to be really the best home inspector is a person that is walking around everywhere they're going and they're looking at things like, I'm looking out at my office right now and see a couple water leaks in the back, see the sprinkler heads one of them are not attached properly, but generally safe. The lighting is all working fine. The ventilation is clean and not dirty. And you should be doing that kind of every space you look at. You always do floor, ceiling, wall. Think about whether it's a store or a house, and that'll get you into the mindset of that home inspector. And you're looking, why is there a singe mark on that outlet? Well, some kid shocked themselves or who knows. So again, back to the main panel board. Inspecting the main panel board, again, if it receives a large amount of power from the public utility, as we discussed, and distribute it in smaller amounts into the service panels and through a number of circuits. Kind of covered that already. Of course, there's our quick reminder of the utilities. By the way, if you've never done this, you'd not believe it, but it really does work. Take a fluorescent pipe. There's so much power going through these electrical lines. They have lines of force around them. And those lines of force, you can actually, this was some of the magic that Tesla could not explain fully with his theories, and why early electricity was, to use Steve Jobs' famous line, we don't sell products, we sell magic. Well, in the early 20th century, electricity was really magic. Like the iPhone, we've taken for granted that it's all the same. But when it first came out, electricity was amazing and also deadly. So we always remind that. Again, utilities can have a big place. The easements, the living under power lines is kind of spooky, but real. And once that power has come in, it's gone through the service drop, it's gone down to the meter, it's gone through the master service cutoff, and voila, here we go, coming through the conduit. It is punching up into the meter, hot, hot. The two outside ones are hot. Those are 120 volts apiece. And then, of course, in the middle is a neutral. And then, hey, that little copper ground line running over there. So what do we got? This is a typical panel. Do you feel comfortable? Almost every panel is 6 screws, 6 flathead screws, and they're flat, and also the flat on the bottom. So the screw here cannot be sharp on the inside. If you ever see one that's sharp on the inside, a self-tapping screw, that's bad because it might cut the cables. One of the problems with electricity generally in houses is, of course, that somebody drilled a hole, or, oh yeah, I hung a picture there. Yeah, that's great, but you drilled right into an electrical box inside the wall. You can see how that might get a little dangerous and cause shorts and cause deaths if not careful. But in this case, let's not worry about the worst case. Let's look at how a typical panel works. In this case, a typical panel, it is a 240 volt panel, right? You've got hot, hot, neutral. There's 2 bars. Okay, line the bar again. Electricity is going to come down this side, and then in the panel behind, it's going to connect. It's going to jump through the breaker into the neutral panel in the middle, and which is going to create a 120 volt circuit, which is going to go out through the tapped wire on the side. Which, if you notice, it's 15 or 20 amps. So the wire is the appropriate size. What you're worried about, see how these are much, look at this. This is a 40 amp circuit. There's a lot more electricity. So wham, these wires are a lot thicker. And that is exactly what you want to see when you're opening a panel box. A lot of things can go wrong, and I'll show you some pretty funky things. But the big picture is, for each breaker, you need lines going out that's about the same size. So 40 amp breaker, black and red, big honking circuit, and that's this 40 amp is probably going out to your electric dryer or something like that. But also, as the wires, as you know, they got to exit this box. They're going to go to their different points. And as you can see here, all this wiring is very neatly tacked on to the plywood panel behind. And also, when it passes, each wire passes through, you want to not have too many wires pass through each hole. Usually, ideally, one per wire. And some of these holes, they got a bunch coming through the wire, but that's not bad. Mikey, I got a yes, sir. A received email. Great. So everybody is getting the email. Do you have 2 attachments on the email? You should have 2 large PowerPoint slide decks. Did you guys get it with both slide decks? I need somebody to confirm that 2 PowerPoints are attached. Not just the email, the PowerPoints.
Yes, I got 2
Good.
PowerPoints.
Good. They will again, we're on the HI2-2 PowerPoint, and just jump on in. Now these PowerPoints are done with 4 slides per page. And the reason why I did that is file size. But also I don't want this to like get scanned and put up on the internet. But I hope it helps you, and try to follow along. I have 2 screens running. By the way, one of the great things you can do is one neat little feature is a 2-screen, an external screen for your laptop. I have a portable second screen that's actually quite useful. Folds up. Anyway, big picture is back to the main panels. If you are looking, I'm on slide 105 on the second presentation. So there we see a lot going on in this panel. Let's keep moving on and look. Now, there's 2 primary types of panels, and over time, of course, the technology has changed. Literally every 3 to 5 years, new stuff comes out. On the left side is a messy, sloppy panel of fuses. I don't like when wire's this sloppy. Now, in fairness, the wall is open here, so sometimes you'll find it open like this in the back of a closet. In this case, it was a little bit under renovation, so I'm going to cut on some slack. But the concept is the same. Again, sloppy wiring tends to indicate sloppy connections, which tends to indicate potential fire problems. On the right side, a very old panel. You can tell anytime you look at a panel, you can't see it in this picture, but there's a little black plaque on the back of the panel here. It probably says, I don't know. Again, you've got the 100 amp main here, and that 100 amp main is then going out to a bunch of panels, a bunch of breakers around the house. Good news is it's old, but it looks like the wiring is pretty conscientiously done. No shorts. Again, in this case, what you've got is this is a kind of a right side one where the master power is coming in here. Hot and neutral, so it's only a 120 volt system, and then hot and neutral come into that breaker, and then they go over to here to the main that connection. They go to the main breaker, and then they're distributed through the house. And as you can also see, many of these switches are doubles, and those doubles are 30 amp breakers. This older houses, there are much fewer circuits for regular house circuits. Okay, so in this one, as you can see, most of the breakers are doubles, and not very few. Half of them, less than half of them are single 15 amp switches. So they back in 50 years ago, you'd have like I said, 2 or 3 outlets per room. Today, you would very easily have at least 1 outlet per one breaker, 1 full circuit per room. So 15 amps just for the outlets and maybe the lights, and then another 15 amps might be for an air conditioner at the window, or sometimes 20 or 30 amps. So these are, again, older types of panels you might come across. In this one, again, same thing, 6 screws. You hear that? 6 screws, you're going to hear a lot. Do you feel comfortable taking the panel off here? Use your discretion. Now this is the service entry where it's coming into the panel. Again, 3 black lines, one with the white tape on it. That's hot 120, white is the neutral in the center, and then the other one is 120 over here. Again, this is inside the panel. Otherwise, I'd be a little nervous about some of the copper being exposed here. This older panel has a big honking kind of a manual switch breaker right here. It's actually not a breaker. There's a fuse inside of this box because very often, let's say 100 amp, 200 amp circuits, even if I wish I could show you this at the Ivy school, even in an area where even if you have a circuit breaker box, it's often backed up by a fuse. Why? Because a fuse is more reliable. A fuse is absolutely reliable, guaranteed to work. Breakers, not so much. And in fact, for instance, in a large building, they may require you to be on a fuse because they don't want your circuit failure to knock out power in the rest of the building. So again, the hot, the neutral, the ground lines coming over to here. And let's go through a little bit more. There's another view of the top here. This is a, a simpler one, just 120 volt system, hot and neutral. And again, what are you looking for? You're looking for the white line. That's a thin one. And okay, here it is, white and black. These are relatively small circuits. It's a 30 amp circuit. I guess that white line is good for 30 amps. But on the right side here, you got a 50 amp double breaker here. This one's a 30 amp double breaker. This lines aren't as thick. This 50 amps over here, and you get the honking red and black, lines on the inside. And again, those are the individual lines of a number 50 amps. I think a number 6 or a number 8 circuit, number 6. So again, line, I can't stress this enough. As you're inspecting, one of the things you're looking for is double tapping, where 2 lines go into the same breaker. The other thing you look for is appropriate and equivalent size. Now, as you can see, each circuit on the panel board is numbered. And ideally, there is a key to show you what each circuit board goes in the house. You're going to take a few pictures here. You're going to take a picture of the, if you open it up, you're going to take a picture of the serial number and the description. In this case, probably American Standard. Again, different companies have changed over time. You're going to note the panel board. Is it a General Electric panel board? Is it a Square D panel board? Is it rated for 125 amps? Does it have a key listing what each one of the circuits is? These are things you're going to take pictures of when you get the system off. Again, here, what I want you to emphasize here is rust. You see that dirt here and the rust here? Copper and metals get old over time. And no matter how well they're done, they still, water damage or any crap can cause potential corrosion. In this case, the wires are fine. There's some dust buildup. There wasn't much of a problem, but I was actually worried about the main being damaged. And in this case, I think they switched out the main breaker for the building to give it a more updated one because it was so important. While the rest of the stuff looked good, that main breaker could have been a problem. Again, hot, neutral, ground, same picture. Oh, by the way, you're going to find lots of problems with my PowerPoints because they're an evolution over time, and keeping them consistent is not my strong point. So these are not the most perfect deck in the world, which is one of the reasons why I don't usually give them out. But I want you guys to have them. Just give me a little mercy when you look at them and see various spelling errors, etc. Of course, a typical disconnect is inside the house. What's wrong with this? Well, I got a problem here because this disconnect, okay, that's nicely placed. But when the electrician came in to do the wiring, the drywall guy wasn't done yet. And so they left it as an exposed material. You can leave it like this, but I am not comfortable at all with high voltage electricity being next to paper. So ideally, anytime you have a panel box, you should have a piece of plywood behind it as both a nailing surface for the wires going out, as well as a little bit of a buffer. It's not a fire rating, but it helps. In this case, this is a one trick pony. This is just the master cutoff. Again, it's a pull switch on the right side. You pull it down, the fuses on the inside are pulled away, and you shut off the power. Ironically, houses today are using really, really big circuits. So you guys have got to start getting used to looking at much larger systems. Now, we talked about a typical system with like a multifamily house. Here's the secret. Who cares about again, the electricity in a disaster? The fire department. So one of the key rules is you've got to be able to shut down all the power coming into the building pretty fast. Okay. And the goal is to have ideally a no more than 6 connections, disconnects to switch to turn off the entire building. So maybe this is the first 10 floors, that's the second 10 floors, or maybe that's just an individual apartment. But no more than 6 should be switches on a circuit. In this case, you're going to whack one switch. It's going to take, you're going to basically, the fire department guy's going to go bang, 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 bam, and all 6 switches are out. Now, there's another rule. It sounds, again, all electric disconnect equipment should be out with 6 hand movements. I forgot where the rule of 6 comes from. The fire department guy might be able to tell me. I know it's a FDNY thing in New York, but it is part of the electric codes as well. And the idea is, in an emergency, you've got to be able to shut the whole system down and not have to think about it. Now, one of the problems today is with a lot of the new technologies, one of the problems is while you shut down all the service coming into the house with 6 switches, what's going to shut off the solar panel, right? The solar panel is going to keep on cranking and potentially cause a fire while you're putting out the fire. The old joke there is, what's the best way to, burn a house down? Park a Tesla in it. Teslas have a wonderful habit of spontaneously combusting and catching on fire. I'm not they're here to bust on Tesla, although it's very fun. The point being that when you have battery powered systems in a house, when you turn off the power is still on. And so that has to be accounted for by the electrical designer. And for you as a home inspector, when you have solar panel systems and battery power systems, you should be on notice that, that there may additions over time may have made it so it takes more than 6 functions to turn off the power. Okay, fuses. Quick fuse thing we already looked at a bit earlier. A fuse, a typical device, internal metal link. That metal link melts when it gets to a certain temperature. Kind of beautiful, actually. Again, I like elegant. I also like simple. I like non-mechanical. When you're dealing with buildings, you deal with 100, 200-year time frame, and you don't want mechanical parts. A fuse is not mechanical, it's physical. The metal melts. It's kind of a pain in the butt to change in the middle of the night, but it's really, really reliable, and that's why I love it. If I could legally, I'd refix a house with fuses. But again, that's the genius of fuses. They're designed very simply. Everybody knows the exact calculated size, and again, the fuse that little metal piece inside a fuse will melt. If you've never seen a fuse, again, do me a favor, go to Home Depot, go to the electrical area, look around, look at these different size fuses. These guys, you're not going to see the burnout on the inside because it's going to melt on the inside, but you'll know it because these things aren't cheap. Again, this is what it looks like on the inside of a little bit of a newer panel, probably about 50 years old. Again, you have the stove boxes. These are the big boxes on the outside. Now, these are also sometimes the main breaker. And this is actually just a pull out, you'll see in a minute. But here you've got a bunch of small fuses, 10 to 20 amp fuses, and you got a bunch of bigger fuses down at the bottom. So for instance, this may be the washer, dryer, kitchen stove, etc. And up here is the house circuits. Now, quite interestingly, if you've never studied the retrofuturism in the past, in the 1950s, they actually thought the whole world was going to be powered by nuclear power plants and electricity. And so in the 50s, a lot of houses used electricity. And then, ironically, by the 60s and 70s, they switched back in many places to gas. I actually love gas personally, but after this Texas thing with the gas freezing up, gas prices went. I don't know if I think I mentioned this earlier. Gas prices on Wednesday, I think it was, went from $3 per 1,000 cubic feet to $5,000 per 1,000 cubic feet of gas. Is that crazy? Yes, it's pretty crazy. And in fact, some people are going to have some really brutal electrical bills. But again, one of the things, the big snowstorms we've had lately, the blackouts we can have from any typical heavy storm in the New York area, a lot of people are saying, "Wow, I got to be a little resilient, a little ability, have the ability to have power for myself." Again, solar roofs. But again, back in the day, they thought electricity was going to save the world, and they thought it wouldn't save the world. And today, they think it's going to save the world again. And then Texas came along, so now it's not going to save the world anymore. It's going back and forth. So again, look at how these technologies have changed each time they decided it was going to change the world. And this 1940s, 50s technology, no moving parts, I like to say pretty reliable. And therefore, I kind of like them. But if you see them today, they're usually not to code and have to be replaced. Quick zoom in on them. Here's a good image here. These fuses are all intact. As you can see, 30 amps of fuse would be passing through this metal piece, and then it's only going through a tiny piece of metal here. And that metal is calibrated that when 30 amps are going through it, it's going to rise to 560 degrees. And at 560 degrees, it's going to melt. And once it melts, bam, game over. The circuit is broken. The circuit is closed until you put a brand new fuse in. Simple, effective. Again, I like fuses. As you can see, different sizes. One of the things you don't want to do, you got to make sure you use the right kind of fuse each time. These are, again, type S, type TL. Time delays are okay. And also that the right ones. For instance, yes, I'm lame. I have a 20 amp circuit in my house, and the fuse broke. Or the fuse burnt out. Now, I did not put a 20 amp back. Shame on me. What I did put is I put a 15 back in. So actually, it's going to trip more easily. That's a little safer. But your fear is if you put, I got to fix that at some point very soon. But that's safer. What's not safe is when you put let's say a 30 amp and a 20 amp slot, because then the wires in the wall, remember, you think about the circuit as two parts. One is the fuse and the breaker, and the other one is the wires in the wall. The reason why the breaker is set to be 30 amps is because the wires in the wall will get too hot, will get close, will be still safe with 30 amps running through them. But if you put more amps through, then it's going to cause a problem. Oh, looks like somebody wants to come in. Hold on. Sarah, admit. So there we go. Everybody understand fuses? Hopefully pretty basic stuff. Moving on. Different types of fuses. And again, making sure you have the right fuse in it. This is a good image. A typical base fuse with a glass cover. Little tiny break there. That fuse is dead. Replace and throw away. As I said, making sure that you don't put the wrong size in. These literally have different threads. So the threads won't go in for different sizes. Double taps. Okay, now this is again a typical fuse box where you have the main service disconnect for the panel is a stove thing. What this stove thing is, by the way, is there's two big long ferrule fuses inside, and they are controlling the fuse for the overall circuit. But here, the problem I want to show you is what's called double tap. And double tapping is where they've done the wiring, but somebody got lazy and, maybe this fuse was switching too much. So they actually kind of rewired it and did double into one circuit. Now that circuit's still going to flip at 15 amps, but when you do that double tapping, you risk again, the potential here is there may be other imbalances in the system, and that is a big no-no. And this is one of the major reasons why you want to open the panel box, is to look for double tapping, raw lines, uninsulated lines, and things like that. And now, best of all, we jump over to circuit breakers. We all know those. Of course, lots of different manufacturers out there. Again, I know I'm tacky, but walk Home Depot. And what you'll see is Home Depot may only sell General Electric and Square D, but they will, at least for the panels, but they will sell the breakers for a number of other different systems, because somebody might need a 20-year-old GE breaker, and it's out there. Even though they don't sell the panels anymore, you can still buy the breakers for it. Now, the breakers, when you look into a panel box, there's lots of different things. First of all, you got the main breaker up here, as I said. You got each one of the different circuits. This is the essence of the circuit inside the wall. Now, this one is actually an arc fault breaker, which is a kind of a special breaker. When you open the wall, it's going to have a little switch on, have the main switch, but also another little indicator on it. So what do we got? We got the hot and neutral are coming in the ends, right? And then if something trips inside this arc fault, there's another line. Again, we call the pigtail lines, and they are going to the neutral on the bus panel. And they are, excuse me, when they're doing that, they're also passing over another, the breaker is configured a little different. So it's going to trip if the line detects irregular voltage and arcing. Because arcing, of course, is another way of saying when electricity, goes from point A to point B through the air, that light, it's a little bit of lightning, and that lightning can cause a fire. Of course, with fuses and panels, you look at bad locations. People build a house and they add on and they add on, but this is stupid, right? The guy decided to add on at some point, and hey, why don't I put a bathroom in that closet? Hey, dope, that bathroom has your panel box in it. Oh, wait, I'll check the fuses while I'm on the toilet. This is a great picture. To the guy who took it, I give him credit. It's just a great example of, really dumb. He's being sarcastic, of course, by the time management tip, because being near water and being near electricity is a really good way to die. I would also add another thing, telling you the toilet was added later. You've got a regular outlet here with no GFCI here. So this is pretty much a death trap waiting to happen. But hey, it was in Tennessee, so I don't know. Again, other dumb panel board mistakes. This is panel board. Look at this. Well, we got to put a new water heater in. Oh, just put it in front of the panel board. The breakers never blow. What an idiot. You got to have 3 feet in front of the panel board. That's ridiculous. And the one on the right, I think, is even better, of course, which is, hey, I needed to expand. Why don't I put the electric panel box in the shower? Now, you look at this stuff and you think this is totally stupid and crazy. But the reason why this stuff happens is, houses expand over time, and people manipulate and modify houses. So you get stupid stuff. And that stupid stuff is what really you're there to be as a home inspector. You're there to find the really stupid stuff. By the way, so again, you've got a water heater right in front of a main electrical panel. Hello. A, you can't get to the electrical panel. B, think about the condensation from this flue. There's just so many things that can go wrong here. This is just really bad. On the right, of course, a nice steamy shower, and boom, you're electrocuted. Then, of course, there's the other reminder that a panel box, if one of the things you're checking with the panel box is, are all of the punch outs, the holes on the outside of the panel box, are they all either, is the tab still on, is the knockout still on, or does it have a proper cover? Because if one of the covers is missing, you actually could have a friend come into your house and build his house in the nice warm area that is your panel box. Kind of gross, huh? What do you do when you see this? Actually, you might want to put a note, have a pest control agency. Are you going to clean it out? No, you're not. You're not there to clean it out. In this case, my report would say unable to inspect rodent nest inside of the panel box, suggest an electrician come power down the panel box and clean it out properly, and then seal all of the openings of the panel box to prevent future infestation. That's kind of wordy, isn't it? But the idea is pretty simple. And again, just as we saw with the attics, animals, nature goes to where it's warm, and an electric box is nice and warm. Again, inspecting panel boards, you may have a big panel board like we saw, or a wall-mounted panel board like this in individual units of an apartment building. These are, again, excuse me. What's he doing? He's in this case, he's inspecting the master. He's going to take a picture of the guide chart. He's going to take a picture of the master size. Just take a broad shot of the whole panel, and he's going to, if there are GFCIs or AFCIs, he may test them. In this case, I'd put on notice that there's paint here, and the paint is probably, it might be difficult to open the panel box. And of course, to open it, you might have had to bring a knife to cut the paint. Now, that's one of the few times although it's very best with the owner's permission, it's one of the few times you can do a non-destructive basic cutting to get access to the panel. Because clearly the paint should never have gone up. And why does that happen? Very often you're inspecting a house. What's the first thing they do when they want to sell? They put a fresh coat of paint on. What happens next? The stupid painters are using either a spray gun or a roller, and they don't care about what they go over top of. So they very often spray the doors so they stick. They spray the panel boxes so they don't open anymore, or the access panels. They spray them so much you can't even see where they are anymore. Remember, after 10, 20, 30, 40 years, this living room might have 10 coats of paint on it. And that eventually gets thick. Back to panel boards. On the left side, again, in this case, the master switch is down to the bottom. Again, a master breaker here. Is it okay to be on the bottom instead of the top? Yeah. But what do you worry about? Again, I'm looking through the sizes. There's a big double here. So I'm going to see black, red. Okay, that's good. Nice thick wires, good size. Next one, hot neutral ground. I'm just looking up to see if I see any double taps. Kind of work our way. There's kind of a couple layers here. One is the neutral behind, the ground bar at the bottom. But again, there's nothing really wrong with this one, except other than being at the bottom, which is okay. This one here on the right, we saw a minute ago. Again, hot neutral, hot ground right here. Nice wiring. Although I don't tend to like to see the caps, but we'll get to that. Back to panel sizing. Again, what is the panel size? The answer is the panel size is whatever your large breaker is. Usually the master breaker, it's marked as main. If it's 100 amps, that's the service for the entire panel. If it, the panel might say 150 amps on the panel on the description, that's what it's rated at, but that doesn't mean that's the service coming in. What's the limitation on the service coming in? It's actually the wire. Remember that service drop I talked about. I don't care how many, I don't care how much wiring you have in the panel. The only thing that matters is how much wire came off of the pole. And if the pole supply was only 100 amps, you're only getting 100 amps. Okay. And with that, you again, that's one of the reasons why you're looking at the service drop. You want to get an idea of whether they've added service over the years. You might have a 100-year-old house and it's got two different power supplies coming into it, and might be reason the primary supply is let's say the basic 50 to 100 amps from 100 years ago, and then there's another big supply going to the back of the house that's supplying the brand new heat pump, the brand new dryer, washer, etc. So sometimes you'll have not only you'll have sub panels, but sometimes you'll have two services in a house. Now, this is a good diagram right here on the center. This is what one of these boxes looks like on the inside. You see a switch on the pull side. There's that switch right there. You pull the switch down and the two ferrules pop out and they're no longer connected and your service is cut. And we like that. Again, I like fuses because they're safer, and I like this manual override, but if something's shorted in here or there's a fire, I'm not sure I'm going to be able to get to this wire. And you can see the wire is kind of thin. And the reason is it could be really hot. And if it's hot, the thin will dissipate the heat better. So again, exterior panels, this one's in the outside of the house. This one has 2 strikes for it. One, now exterior panels are usually not in New York area. You will find them in other parts of the country. I think it's allowed upstate, but yeah, I don't think so. Take it back. But again, these orange red tabs, those are Federal Pacific or Federal Mogul. They're dangerous and that should be required. If you look closely, the reason why they're illegal or they're not good anymore, I'm going to use my terms lightly, and maybe I should get a better zoom on this, but look what's going on at the taps. Anybody see that? That's rust. So they saved 10 cents when they made these breakers by, instead of using a high quality galvanized or copper connection, they used kind of a cheap steel connection and it rusted. And rust is not real fun for connecting electricity. You look closely, by the way, you'll also see some double tapping and all kinds of crazy stuff going on here. So there's lots of things wrong in this particular picture, but the worst part is the rust. Interestingly, somebody in very, very tiny writing, well, that's the warning labels of them. Anyway, let's keep moving on. So Federal Mogul, outside, corrosion, rust, bad. Okay. Again, Federal Pacific, Federal Mogul, I got to double check. My brain is going dead. Again, the main connection the disconnect's outside, the panel's outside sometimes. The disconnect is outside. That's okay as long as it's in a waterproof box. Again, there's rules for that these days. Okay, inspecting panel boards. Is it hot? Well, hot has 2 meanings with electricity, literally physically hot. This is probably the single best reason to buy a thermal camera, is to quickly check hot lines. This is one of the reasons I use it. And as you can see here, do I have to tell you which one's the hot and the neutral on that box? It's pretty obvious, right? And again, that's where, as in part of your inspection, this is a pretty useful tool where you can literally, whether it be by just knowing the temperature being hotter, you can touch, you can feel it, but you don't really want to touch these things, right? In this case, it's 240 degrees. Chances are that's the hot line. But even more important is when you look at individual circuits, you can, what I love is, pointing it at a panel box and seeing what circuits are on. We'll get to that in a minute. That was the main connection, so a little different. Now, what are you looking for? You're looking for this. Not good. What do you got? You got an outlet on the inside of the house, nicely wired. On the outside, again, all of these are controlled by the NEC, the National Electrical Code. But again, a wall-mounted panel on the outside. Look at that flame mark. Actually, this is still burning in the picture. The point is that there's been some kind of arcing that has caused a fire in this panel box. I think that, I'm not sure if this was a stock image. I think somebody said this was hit by lightning. Okay, inspecting panel fuses. Again, do you have the right size? Just as we talked about the right wires going into a breaker, same thing with fuse boxes. Now, if you can't see behind the fuse, okay, then you're not going to be able to make the call. But oh, and by the way, I don't suggest doing this because you'll be knocking the power off for the whole house. This is what a stove box looks like when it's pulled out. Is, again, it presses in and pulls straight out, and inside of it there's 2 large ferrules, and when you pull it out, those ferrules are disconnected for the primary circuit, and then the whole primary circuit of the house is cut. Don't touch the fuses. Okay, don't pull them out. Inspect them. You can look at them to make sure they're all intact and they're bridging, so there's no, the fuses aren't dead. But don't do this. This is for an electrician to do, not you. But I show this because you may come across houses that the power's been cut. They haven't paid their electric bill or something. So you'll see a big hole in the panel box, and that's because this stove box has been pulled out. Again, wiring circuits, you kind of know this already. One more time: drop, meter, panel, circuit 1, 15 amps, circuit 2, 15 amps, circuit 3, 15 amps. Or specialty circuits and things like air conditioners, etc. Of course, wiring, as you're inspecting the wiring, you're going to get a laugh. There's some stupid stuff out there. One of the requirements of every wiring is when you're splicing wiring together, it has to be done in a junction box. You got to love this guy's junction box. Do you guys see this on the left? Everybody see what that is? The guy didn't want to spend $3 on a junction box, so he used a cigarette box, a cigar box. I love this. Now, the good news is it hasn't caught on fire. The bad news is I'm not sure when the fire is going to happen. But again, this is just, you're going to come across stuff that's just totally unacceptable. Then you just say, improper, snap a picture and say, improper lack of junction box, hazardous repair or replace, get a proper junction box. And the one here, I mean, that's actually passing through 2 fuses. On the right side, another one you don't ever want to see is exposed, the winder clips. This is not acceptable. You cannot have this type of wiring. Okay. If you can, it's got to be properly protected. That's not good. Ironically, they'll often do this because they'll cut a hole through a wall and just splice the line through. There's our circuit again. Again, we talk about lighting in the ceilings, wall mounts. Actually, this is just lighting. So there's lots of things going on here. No, there are some outlets as well. I'm sorry. In this case, the kitchen outlets on the wall are there. And this is just a quick reminder in red of types of outlets you might come across. Again, maximum distance from outlets 6 feet to prevent extension cord problems. Again, wiring materials. Wiring is supposed to be protected. One way of protecting it is putting it inside the drywall or inside of a chase and plaster. Another way of protecting it is of putting it on conduit on the outside of the surface of the wall. What is not good is this crap. This guy, hey, I got a junction box. Well, he brought some service in and then spliced this junction box out a million different ways. And he said, well, I want to be able to access it, so I'm going to leave it all open. Not acceptable. This is a disaster waiting to happen. What happens if a bunch of water drips down and gets onto this outlet? Boom. You just lost the house. So this is something like this. Again, exposed. The wires are fine. They're NM, plastic wiring. The problem here, is not the Romex. The problem is that the connections are not in a sealed junction box. And the obvious thing to say would be, well, it doesn't fit in the junction box. Fine. Get a bigger junction box. Get a bigger boat. Whatever works for you. Okay, wire mounts. Let's think about what they're mounted. Now, you're never going to see this because this is inside of the wall. But I just want to show you a nice little detail of types of problems you might have and how they should be solved by a proper contractor. In this case, excuse me. Ideally, the electrical wiring and typical wood framing, the wire is going to be connected and mounted safely. And notice it's mounted on the inside because what you don't want is, when this drywall comes along, when they install the drywall on top of this wood, they're going to be drilling, right? They're going to have screws or nails going in, mostly screws. And if those screws hit the wire, unstabilized wire, boom, you got some problems. So again, the outlet box is really just coming down. It's effectively a junction box. It's taking the wire, letting the wire be spliced into the outlet itself. You should not take the faceplates off to look in here, but this is an example. As I said, aluminum circuit wiring is a potential problem. Now, aluminum is actually used in very large buildings. A skyscraper, for instance, will have an aluminum bus bar, an inch wide or 2 inches wide. I saw a bus bar at my old office in a major skyscraper in Midtown, and the bar was actually 2 inches by 12 inches thick. And it was, carrying a lot of circuit. And you did not want to get near this thing if you didn't know what you were doing. but it was made of aluminum because aluminum is a great conductor. But again, it's a lot cheaper than copper, which is good, but it's not as efficient as copper. So it does dissipate heat. So anytime you're moving a large amount of electricity, you've got to make it the aluminum wire's got to be bigger than the same amount of copper. Now, what you're worried about here in this picture is, again, two things. Again, somebody opened a junction box, and normally you can't see any wiring. But in this case, he went a little further, which I do not recommend as a home inspector. And he took off the black cap. He unscrewed the black cap and found that not only is there aluminum wiring, but there's aluminum wiring being spliced and double tapped off the circuit. So he would be able to see the 3 wires coming out, and he'd know that's bad. In this case, he went further and took the cap off. Do me a favor, and if you're not sure about that, don't do that part. But the good news is he found 2 problems. One, aluminum branch circuit wire is a potential risk. The double tapping here, where they got a junction box to do the switch, and then he ran another wire to go perhaps to do a light as well. That can be a problem. This can't be a 4-way light, in which case this would be okay, but it may also be a double tap. BX, you got it. The Bronx. Well, I said New York 1920 to 1960, but of course it's still used today. What I meant was with the old BX is that it frequently, the old BX actually would have paper inside. Also, the wiring would perhaps be wrapped with horsehair. Sounds crazy, but it actually is a good insulator. And that would be inside of the 2-line wire. Today you'd have 3-line. This is hot and neutral, no ground. That was common in the 2-prong plugs of the past. I think they went to 3-prong plugs about 1960. Again, they went from knob and tube to Romex knob and tube to BX to today's plastic non-metallic that is pretty flexible. Okay, Romex wiring. Again, the plastic, the metal sheeting, the BX wiring, armor is used by code. It's used at a bunch of different locations, usually kind of near water, exterior conditions, places where there can be punishment, damage. Other aspects in 1 to 3 family homes, you're allowed to use the plastic NM non-metallic Romex wiring. Romex is just a brand. Excuse me, but you'll often refer to it as that. And as I showed you in the detail earlier, it's very important how you wire that Romex when framing a building. You're going to frame the building, you're going to put the electrical in, you're going to put the plumbing in, and then you're going to put the drywall on top. Once that drywall's on, you can't see it anymore, and all kinds of damage can happen. Again, making sure the plastic or the wiring is like down the center to minimize damage. And when you're going through joists, for instance, you got to drill a hole. And all these different methods are, again, pretty standard. The idea is stabilize it, put clips every 4 feet as it goes up the wall so it doesn't sag or fall. And basically, the electrician's got to make sure that wiring isn't just in the wall. It has to be kind of successfully attached to the structure, so screws won't do it damage, or earthquakes won't do it damage. Here's another image of wiring. Again, we talk about black and yellow, the different outlet types. I like to show this. This is in the middle of a renovation. How do I know it's a renovation? The floor planks. Those floor planks haven't been used for 100 years, right? So in this case, they're tearing up the floor. They've taken some of the old planks. They're putting a brand new stud wall in, brand new electricity. That's a basic remodel. So other types of conduits. Now, when you are running, especially in older houses, the electricity wasn't ever wired into the walls. So if you have to run wiring, it's got to be armored and protected. In this case, rigid metal conduit, EMT conduit, you'll see everywhere, of course, which is the pipes running to the power. That's a good surface mount way, proper protection for the cable. We like that. Um, again, greenfield, this is a flexible conduit. As we saw, this is when you're running for short lengths of distance, you can run greenfield into outlets in a flexible way that saves you a lot of hassle. And also the flexible ones are sometimes easier, obviously easier to install and easier to maintain, which can make them safe. Underground and really exposed conditions, you might have certain plastic encased things different from non-metallic to provide, in this case, a 240-volt 4-wire connection. What are the wires, guys? Hot, neutral, ground, right? And again, the conduit's goal is to get the electricity from point A to point B safely, but also to bend it. This sweep is not by accident. As I said earlier, when you bend copper wire, it can snap on the inside of the wire and you'll never know it. So that's one of the reasons why they have the stranded wire. But in this case, this is a very sharp turn for an elbow, and that has a good chance of breaking the wire here. More crazy things for conduit. This guy wanted an extra outlet, so he kind of took a can opener like an idiot to the conduit and added another line. Just stupid. In this case, this guy's outside. I think my argument here was that this was supposed to be in conduit, but I think later I found out that this is okay because it's far enough off the ground, and as long as it's waterproof, they're going to be okay. Different types of wiring. These are ones mentioned in the book, and they are some of the many types, which I think we've covered already. Again, NM non-metallic. Then service entry. This is the service entry is the wire that's running overhead. These are the overhead power lines. So these are very big copper sections, maybe number 6 or number 4, and they're coming in. And the limit of this size becomes the limit of how much circuit you can have in the house, unless you want to add another drop or replace the cable. In this case, let's say that's 100 amp service. I don't care if you have 300 amps in the panel. It doesn't matter. You're only getting 100 amps on that master service if the wire is too small. I mean, it'll still give you more, but the electrician is required to protect it so that your house doesn't burn down. Again, armored cable or BX. This is popular. In this case, a hot neutral ground inside of the metal casing. The metal casing serves 2 purposes. One is to protect it, and the other one is to provide electromagnetic shielding. So it serves both purposes. The underground feeder, again, hot, neutral. This is a large, a large wire, maybe number 6. But in terms of, excuse me, from the house perspective, again, this is the largest wire, just like the SE cable. This is a USE cable. And it's there, of course, in either in a trench or in this heavily armored, rubberized usually, feeder to keep it from getting damaged from the outside. Vermin, trees, any crazy thing that can do damage. Or worse, of course, than a stupid person excavating, not paying attention that in excavating, he hit the wall of the underground circuit for the house. Oh, and if he's really lucky, he hits the gas line too, and you know the rest of that story. Okay, rigid metal conduit again on the surface, 3 or 4 wire, greenfield, flexible conduit. Now, greenfield is limited, I think, to 8 feet, 8 feet or 10 feet for maximum distance. So if you got to go 200 feet, you're not going to run greenfield. You're going to have rigid. You're going to be forced to use the more expensive rigid connection to make it happen. Again, other EMT, plastic type. Okay, greenfield wiring. This is again that heavy flexible wiring that comes off for primary service. As you can see, these are punch outs. I said a minute ago, this is a good picture of what the punch outs look like on an outlet. In this case, he needed it, he punched it, and when he punched the holes, he now has to put a cover back on the holes to make sure it's done. Hey, John, how are you? Everybody say hello to John. John just checked in. And John, I hope you're doing well. And class is moving along today. I did send out PowerPoints. So if you need anything, John, you got the floor if you want to say anything. You okay? Guys, if you don't know John, John is the owner of the school, and he has to check for attendance. So I'm sure he's doubling my notes right now to check for attendance. Anyway, so as we move on, we've talked about greenfield wiring, and as you can see here, imagine that punch out being punched but not used. That is a mouse hole, and that's what you don't want to do. Here's the ground here. This guy's going through a relatively small line, but even that small hole should be sealed. Otherwise, a mouse or something will come in. What else? We got, there's more wire inspections, more stupid stuff. Um, I saw this recently in a place. It came in and the chandelier in the dining room was ripped down. Well, not ripped down, but it was taken down. In this case, three raw wires just sitting here. I'm like, guys, come on. At least you can put a cover on the wires. If you don't have one, this is a pen tester, and the pen tester, when he touched it, he found out not only was the wire open and unprotected, it was also hot. It had a charge running through it. So pen detectors are a very good thing as you start messing with circuits. In this case, two neutrals. I'm not sure why he's got two neutrals here, but oh, I think they were supposed to be connected together, but they're not. And you can see a cap on this one over here. That's good. So, dude, give me the cap on this one also, and then I'll be happy. On the right side, I mentioned earlier about New York City having some of the oldest electricity in the United States. This is probably about 1900 wiring. It has a rubberized material, a rubber. I think it might have been natural rubber, but it often would be wrapped with. I don't know if you see the knitting here. Sometimes it's string, sometimes it was horsehair, and that would be the material that would protect the copper. Now, they didn't have meters and gauges to find out how much power was being lost in efficiency, but they had something more important, which is they could feel by touch that the line was hot. Anyway, the big picture is this line has been in for 100 years. Now, ironically, the insulation's still working in terms of the horsehair, but the rubber, as you probably know, rubber for 100 years. Now, if it's in the sunlight, it's gone in 1 year. But in this case, it was inside a line, but still after 100 years, it still flakes and fall apart. So this wiring is suddenly exposed, and that's a fire hazard. That's a good image of loose wiring. As we look around the house or the building, we look at different types of systems. This is a 1920s apartment building in New York City. When it was originally done, it didn't have certain electricity. So they came back later and added the electricity in the baseboard. As you can see, they also added coax cable, and they added phone line even before that. But this 1920s power, as you can see by the T-shaped outlets, again, it's a two-prong. I don't want to see two-prong systems. So, again, as part of your report, you're going to say two-prong outlets, they test okay. You might use a two-point tester, a neon tester, but you probably would want to discuss the owner that says, two-prong electric system suggest upgrade. Again, legally okay, but this is a safety issue for me. And without a ground, it really becomes a risk. On the right side, what the heck is this? Now, this is up in an attic, and some idiot was pretty sloppy. And all the wiring just kind of jumbled in. And there's some big wiring in here. Those red are 50 amp circuits. So, basically you should fire this electrician. But honestly, he doesn't care because he probably did this work 50 years ago. One of the things, as I said before, you want to make sure that the property, the quality and the workmanship of the property you're inspecting works. In this case, this one's pretty much a mess. Hold on. Whoa. Okay, hold on for a second, guys. I just made a mess. Let's hope I can get my screen back. Come on. Whoa. Uh-oh. Quick technical snafu. Give me 10 seconds. Okay, back in business. Sorry, I have a standing desk, which if you ever work with them, they're pretty great. And especially if you're giving a 9-hour lecture, you can stand up and sit down at different times. Again, inspecting the wiring as you're walking around the house, you're going room to room. You're making note of a 2-wire system with the T's. Much older system, suspect that the wiring may be very old and should be inspected further by an electrician. Appear total mess, not acceptable. Consider this, require or suggest that you can't require anything, but you can suggest that an electrician come in to sort out the wiring, uh, uh, unsafe to hazardous condition in this current wiring. Other types of wiring that can be bad. This is a, I've done this before, so shame on me. The guy got lazy. He wanted to have some electricity on the outside during the summertime, so he puts it through the window. And that sounds cute. It might have been cute on day one, but a couple years later, it's still there. And he forgot about it. Well, the windows been going up and down and up and down and up and down. And of course, you're wearing out the plastic on the extension cord. And as you wear out the plastic, the extension cord becomes frayed, loose circuits, and you get a mess. And it's just wrong. So not acceptable. On the right side, again, there's our picture of the very badly done outlet. Not acceptable. Okay, what are you going to do to inspect the wiring? Okay, this device is great. It doesn't work on on an air conditioner circuit usually, for or at least the large ones, but this is a typical GFCI or a circuit tester as you're walking around. This is just a regular circuit tester. And what it's doing is making sure that the 3 prongs are hot, neutral, and ground. And in this case, you're plugging it in. It may say, look, hey, I don't have a neutral line. Or it's backwards. What should be the neutral line coming in is ground, is hot. And that hot means that or conversely, your neutral line might be a ground, and that means you might have a electrical problem. So as you go around and check the outlets, you're going to check ideally that, again, each plug hot and neutral. That's good. What's bad is the red ones, of course, are when the grounds are what you don't want is the electrical ground going to uh, a hotline where effectively you're just electrifying the ground outside your house through the grounding wire. That not only can be expensive, but it can be a potential fire. I had a young lady who was in this class a couple of years ago. She was a very smart, incredibly smart lady, but she wasn't getting a lot of respect from her company. But she did these, again, she was looking around the house and it was actually on fire underground outside the house. Combination of gas or electric, nobody was sure which, but it did eventually get fixed. Okay, moving on. What are you doing? You're going to be plugging as you're walking around the house. You should do some or most of the outlets where you are plugging in a tester. For regular outlets, a straight tester or a GFCI as well. That little box I showed you earlier with the voltage meter. I also want to know what the voltage is. Now, an air conditioning unit may be individual circuit, the 15 amp, a regular circuit, but just only one plug, or it might be a different voltage. And that is why we have different connectors for those amps. So this typical 3-prong plug, the air conditioner might not fit in it. We'll look at those types of plugs later. And again, older houses, you got to be that investigator, right? That sleuther. And as you're looking at older houses, you might come across this knob and tube wiring. Up until I think the 1920s, 1930s, this was common. I'm going to show you a lot of pictures of it because I actually think it's one of the biggest risks you're going to come into in the New York City area. Again, this was a world before plastic. So the copper wire moved around the house and it tied off on knobs. The knobs were actually they were actually ceramic. So these were, made in ceramics factories out in Queens. Queens was one of the largest producers in the world for this, Eagle Electric and some of the other places. And these knobs would be screwed into the wood, as you can see here on the right, or nailed into the wood. And then the wiring would wrap around and then go out into the house. Again, 3 lines here, hot, neutral, ground. And they would be going around the house. Now, what's the problem here? The wire, hey, it works. Problem is, over time, again, the insulation becomes the problem. The copper is probably okay, but the insulation, as I showed earlier, very, very prone to deterioration. So in your report, if you see knob and tube wiring, suggest getting an electrician to replace the knob and tube wiring. Okay. By the way, it's a tube is where they have a ceramic tube when you go through a piece of wood. You'll see that in a minute. Here's another good example. A couple pictures of knob and tube. Again, you'll see it down in the cellar, hot, neutral, going around. Over here, we got the knobs, and then as you can see, it goes through a drilled hole in the stud or in the header, and as it goes through the drilled hole, that's the tube. Which again, it's the tube's job is to prevent that wire from getting too hot and touching the wood. So again, knob, tube, knob, and that's the way you turn the corner in the old style. Because this relied on tension rather than bending, but it's exposed. There's no conduit, so it's a potential problem. And of course, your friend the mouse loves this stuff. There's again the problems you might see, the deterioration over time. This is literally horsehair. It sounds dumb, but up until 1916 in New York City, there were horses everywhere, right? And at the end of every day, I know this is gross, those horses got a visit. They got a visit to everybody's favorite place in New York City. Yes, it was called Dead Horse Bay. It's also known as Flatbush Avenue today. And Dead Horse Bay had a factory for taking literally a boatload of dead horses every day from New York City and turning them into glue, literally glue. And the horsehair was used for many, many products. Why? Because horsehair is a great material. It actually was required by law in the interior plastering of interior walls. The horsehair was required in building in New York City. It was written into the building code. You had to add a cup of horsehair to the plaster when you were putting it on. So Bessie had a bad day, but he's eternally living with you in the plaster of your walls. Again, why is it a problem with older wiring? Because it's a very it often was very hard to bend and kind of, again, it's oxidized over time. The insulation is falling off. And this one's even worse. You open it up and there's actually aluminum on the inside. So a couple of different types of things you might see. Moving forward, we see, again, crappy wiring, not acceptable, right? This is, now a lot of these may be the current owner's stuff, but again, the panel box is wide open. Open panels, over tapped, repair or replace. On the right side, this is probably one of the worst things. I'm not sure if you can fully see this. This is a circuit. They just kind of took, instead of using proper wiring and junction boxes, he took an extension cord. What a clown. He wired up an extension cord and just hung it to the roof. Again, believe it or not, extension cords technically are illegal. That I know it sounds crazy, but that's the way you want to think about it. For permanent wiring, definitely it's illegal. It's another image. Again, we talk about wire sizing. The wiring, I've already said this, the wiring should match the ampere rating of the circuit breaker or fuse. Okay. If you look at the main panel, if you're able to get it open, you can see that. You look for double taps. And again, you want to see large breaker, thick wire. Pretty simple. There we go again. One more time, a good image. The smaller wires, it's not braided. It's just like thick, solid copper. And then up to about 20 amps, you can go solid. After that, they want to see stranded. And the reason why is, again, this 15 and 20 amp circuits can bend relatively easily and they won't break. But at a certain point, you really want to rely on the stranded to prevent breaking on the inside of the wire. One more time, large voltage, 20 amps or 15 or 20 amps, 14 gauge. 14 goes down when the amperage goes up. Typical colors, of course, same problem, white. The yellow's not here, but it's a 20 different sizes. Again, solid versus stranded, and then you're all stranded on the larger sizes, simply because the copper doesn't bend very well. Junction of boxes, more problems. Again, I don't ever want to see a junction box that's open. I don't ever want to see junction boxes where multiple taps are going through the wires. This one in the middle, what a joke. The guy was actually using the boxes, the junction boxes, as a structural element. At least they're enclosed, but it's clearly a failure waiting to happen. And last but not least, the junction box, the outlet box for a light. You see fire damage. That's not good. That tells you something really went wrong. And for my report, if I just saw this in its condition, I would say, first of all, assuming this is the attic above, I'd try to look at the attic above to see where the damage is. If there's a regular floor above and I can't see what the problem is, I'm going to put a note saying, apparent fire damage at outlet, suggest turning the breaker off for this outlet and having an electrician review it prior to future stuff. Now, if you're walking around with the current owner, obviously let them do the breaker. But if you are walking around with a potential owner, you don't touch the breaker or without communication with the current buyer, because then they'll blame you for it. And that's where your camera is there to protect you. I've also talked numerous times in the class about the importance of camera recording and body camera. I was experimenting today on the subway, coming to work this morning. I jokingly said I could just hang my phone right here and record as I walk around. It actually worked. It's not a bad thing to record your conversations. It's probably stupid to use your smartphone, but it is generally a good idea to take as many pictures as you can. But again, video is even better today. I actually, last night, I was reviewing a bunch of videos that I had from a construction project. And what I did was I was doing screen captures of the video so that I could, take individual slide images. So if you're really good, again, you take pictures as you walk around, but don't be afraid to have a body camera. And the body camera, A, will record what's being said, which can be quite important. B, you can talk to yourself and help write your report as you walk around. That's what I do. I'm walking around and saying, well, this panel is bad and this, and this, and I later use that as the text for my report. But anyway, that's photographs. Clearly, junction boxes are way open. I don't ever want to see open junction boxes. I definitely don't want to see raw wires. I definitely don't want to see unsafe and unstable conditions like this. And fire damage is, of course, numero uno to me. Fire damage is always strict in the report. Again, we got the stacked junction box I talked about a minute ago. What does a junction box properly look like? Now, junction boxes have changed a lot over time. The octagonal quads or light switch boxes here are pretty common in metal. Today, a lot of them are made in plastic. For residential, again, in a commercial building, you can't use plastic for anything. Okay, you have to, it's called non-combustible materials. But in a house, it's perfectly fine today to use an outlet box or a junction box, use plastic. I don't like junction boxes out of plastic, but outlet boxes I can almost understand. And ironically, the upside here is the plastic actually works a little bit of an insulator. Not much, but a little bit. Again, more junction boxes. One of the worst places is a junction box is a fan. Now, we talked about this earlier in the interiors. The fans have what physicists call a gyrational moment. That's a fancy way of saying a fan, if improperly installed or improperly maintained, will literally rip itself out of a ceiling. And I cannot stress enough that very powerful fan motor, if it's not working to very powerfully tilt the fan blades in a nice, even fashion, that powerful motor will very powerfully rip that fan out of the ceiling. And sometimes you'll just see that where, there's a big hole and the owner will say, oh yeah, the fan fell off. Up in the attic, you do also want to keep an inspection for the fans. Are they mounted properly? Even if it's okay today, it might not be okay tomorrow. So is it properly bracketed? In this case, The only bracket is the electrical connections, which means this thing's going to vibrate pretty bad. Back to outlet types. As we're walking around each room, we're checking the ceiling and its outlet and its light fixtures. We're checking the walls and the outlets and the switches. We're checking the switches in every room, where the the 3-ways and 4-ways working properly. You come across weird architectural conditions. This guy was in kind of creative, right? He thinks he's cool. He's got a junction box at a weird corner. I don't know if you can see this, but this is like an attic corner. And so he bends the faceplate. I'm sorry, but that is not proper enclosure and a fire hazard. I know he's trying, but it ain't working. Again, remembering single outlet, double outlet. Usually, you'll have quads sometimes. Usually more than 4, you're not going to have. More than 4 outlets, you want to have separate junction boxes. Why? Because 4 outlets is potentially 60 amps of heat, or more importantly, the full 15 amps of a branch circuit. Again, the outlets are where the current is taken to supply the equipment. That's kind of obvious. The receptacle, the typical receptacle as we know of today, is fine, but they've evolved a lot over time. I'm sure a lot of you might have traveled the world a little bit. I was just in Italy, and they have this, like, is it 2 or 3 prong plug? I think it's 2 or 3, both. And then in England, they have a bunch of different types. So there's lots of different outlets around, and that comes in many ways from the history of power evolving over time. Like, for instance, the Japanese adopted the same strategy as the United States. Why? Because we bombed the crap out of their country during 1945, and they rebuilt. When they rebuilt, they said, we got to make money off those Americans, so we're going to copy everything they do, including their electrical system. And oh, by the way, most people don't know their phone system. Korea and Japan are basically the only 2 places in the world, other than the United States, that use what's called the CDMA phone system, which is, in New York, we call that Verizon. But very few places in the world use that. And national standards have adapted over time, just as we have our national electrical code that states the 2 and 3 prong plugs we have today. Other countries have different styles. Now, this outlet, of course, is, I got a problem here. Not because, now these 3 prong plugs, you might be smart enough to recognize that's I think a 30 amp plug and turn outlet. But more importantly, what I worry about is that it's corroded. I hate corrosion. Corrosion plus electricity equals non-transfer equals arcing equals fires. Okay. So that, again, if you see stuff like this where the outlets are wired bad. On the right side, this is an even funnier thing. This is and I joke only because I know a certain architecture office that has this, my old one, where they wanted an outlet on the other side of the wall. They drill a hole in the wall, stick the wire through, and then bring it back through and resplice the electrical outlet and plug it in. But I got the power. Yeah, not safe. This is absolutely a no-no. And again, the report would read, electrical repair, replace, outlet being tapped from another room through the wall with improper connection and improper wiring, suggest immediately disconnect and replace. And this one again, we'll take a look at these. I love this picture. Does this look like anybody's room? How many people are sitting in a office, your home office, that is the electrical room for it? Not good. The good thing, obviously, the upside here is that he's got pretty good cables, and those are pretty heavy cables. But downside is it looks like that's like a 50 amp circuit plugging in. Now, the good news is this thing's got its own breaker, so it's going to turn itself off before it gets too big. But this is a demo example of just what you don't want to see in power in a building. Permanent power. Again, if it's a construction site and they got their tools plugged in, I'll give them a little slack. But it's safe to say the breaker here is going to trip like every half hour. And as you can see, you got these splitters, the 3-to-1 splitters, the 6-to-1 splitters, the 3-to-1 surge suppressors, the Christmas tree switch over here. It just ain't good. And you'll see crazy stuff like that. Now, switches and outlets over time have definitely evolved. Actually, a friend of mine has in his apartment in Park Slope, probably about 1910 wiring. And instead of the rocker switch, which is what we call a typical switch today, he has buttons and on off buttons. Again, you'll see if you ever watch an old movie, you'll learn a lot about electrical systems. So let me try to give you a quick teaching. Again, 2-prong plugs, 3 in a row. You can imagine something going wrong here. Again, 2-prong does not have a ground, so you do have the potential for fire, or the ground would be on the inside and not on the plug itself. And the other problem here is polarization. So they would solve polarization, of course, by one being large, one small. Oh, I should probably spend a few seconds on this diagram. This is a typical 3-way wiring, right? And the idea is when one switch is on, it works, and then the other switch is off, and it's not working. But if you turn them both to off, then the system's on again. And we all know that as a 3-way wiring. This is just a neat little image. I hope you take a look at this later of a reminder of what it might look like. This is a nice wiring job. Nothing wrong with this. In fact, this is exactly a technically correct way to do it. And the idea basically is you're either in a 2x2 decision grid for you fancy scientific types, a 2x2 decision grid, all on or all off is the light is on. One off, one on, the light's off. Pretty basic. Okay, foreign outlets. Here we go. I thought I did want to mention this a little bit. We saw some of these pictures earlier. The North American typical triple. The Japan's non-grounded, but of course that's also really similar to American older two-strong plugs. Oh, there's the Italy. The Italy is 3-line. Again, each of these styles evolved in different periods. I think the Germans did their style like in the 1950s. Clearly, you can see there's a lot more safety involved. Britain has these really big plugs. And of course, the problem with this, if you don't know, is in other countries, they their power is run. I made a reference earlier that you can have 120 or 240 in your house. Well, in Britain and other places, they only run 240. And that's, hey, it's 30% more efficient. That's good, right? But sadly, they had to make a rational decision. If you run the 240, more people are going to die. And again, this is in the post-war period, they were in an era of great scarcity. Britain was bankrupt after World War II. So they made the decision, yeah, we're going to have some people die from electrocution, but we're going to save 30% on our electric bill. Sounds like a Geico commercial. Again, so some systems are 240, some are 220, lots of different plug types. You might have an international adapter as you go around the world that kind of makes all these different plugs. I was recently in China, and I just cheated. I just bought an adapter there. But why did Australia and China have the same thing? I don't know. I think generally maybe somebody got a contract and made it happen. But anyway, this is just a reminder of the different types of outlets. I have seen apartments in New York City that were actually wired for foreign outlets. It's quite interesting. Can you do that? Yes, you can. There's nothing wrong other than the cycle speed. I think Britain has 50 cycles. It's okay to take just the outlet and have a different plug. Rare, but you might come across it. I like the Swiss one. That's kind of cool. Again, outlet special. Now, those are foreign countries. Now we look at the American types. We have a lot of different plugs too. As I showed you a minute ago with a corroded one, American plugs have different purposes. Like I think Xerox actually came up with a bunch of its own plugs. These are the Office Pro ones for different. These were like for copy machines, but the typical outlet, sometimes there'd be the polarized one where one side is longer. Again, 18, as you can see from this chart, there's a lot of different things going on here. The classic 18 looks like the British one, right? But these, another aspect of these are the ones with the angles here. Those are push and turn, where they're locking in place. And that is a really good thing, I think, for very large amperage fixtures that aren't going to be plugged in and unplugged all the time. So large, in particular, these ones, which these ones were used for larger amperages. The main things you want to look at, actually, I don't really have 30s and 40s here. There's even bigger ones, but generally for an air conditioner, you might come across a the 20 amp circuit. This one I had in an air conditioner I bought once. It was a 15,000 watt, 15,000 BTU air conditioner. 15,000 BTU, that means 1.25 tons, right? 12,000, 15,000, 1.25 ton air conditioner required this 20 amp service, right? Was it this one? No, this was, it was the 15, anyway, it was a 15,000 horse, it was a 20 amp plug. It used this plug, and it was a pain because my owner didn't want to switch out the outlet, so I had to take it back, and I was renting at the time, so it worked out okay. Okay, junction boxes again, as we've inspected the outlets, when you're in the attic and when you're in the cellar or when you're in closets, you might come across these open junction boxes. There, again, carelessness. The attic is the worst place to look for electricity because you're going to see really crappy stuff, and nobody cared. Nobody went up there, and for 50 years, you got dust and building up. Here, you've got kind of good. It's halfway there. Somebody took it's a very old house, and this isn't dust. This is actually an insulation and the dust. Good combination. But here we've got see the knob here. So this is old knob and tube wiring. It's probably that's the original knob and tube wires. They spliced it into a junction box and then ran non-metallic cable out of that. The problem isn't that they did that. That can be okay. The problem is that they didn't put the lid on the junction box. The junction box is now full of dust or blown in insulation, whatever that is. And although it's capped, it's a potential risk. On the right side, same thing. Again, the wiring come through. It looks like it's powering some type of a little motor. I'm trying to remember what that motor might be. It might be for an alarm. It might be for anyway, a small DC stepping transformer, and it's, again, they didn't want to run a separate wire, so they spliced it off. Look, I don't mind you splicing it off as long as you keep that junction box closed. So again, here you're looking down in an attic. You see the guy's foot, and as you're looking down, these junction boxes, if water fell into this, these could be dangerous. There's our knob and tube again. This is knob and tube on the right side. We were talking about this in the attic stuff, where you've got the electricity up in the attic. Somebody wanted to add an extra line, so he just cut the knob and tube wiring and spliced it in. So he's just got a hot line going in. That's not the right way to do things. And again, no junction box, no safety, and really the knob and tube should just be replaced. But hey, the guy didn't want to spend 10,000 to replace the wiring. He had somebody splice it, put caps on. He really couldn't put a junction box in, but this is now an unsafe condition. Okay, fuses. Quick little reminder on fuses. Again, they were used roughly, about 50, 60 years ago. In the 1960s, the standard breakers started to appear and they started to fail. The first generation from the breakers, we start dealing with the AFCI breakers first the GFCI breakers in the 1980s, and then the AFCI breakers come in the 1990s when they started being required. Now this is the AFCI. This is an arc fault. This is to protect from broken wires. So what they did is they put the AFCI on the panel box. Okay. Now, for new construction, most circuits should have the AFCI protection, but again, that type of switch could be phased out. And of course, GFCI breakers started in the 60s, 1970s, and I said 80s earlier. That's not correct. And of course, its job is to, if you get a short, it's going to stop the, it'll shut down the circuit and save your life. So again, quick point, cost reminders. Old fuses cheap, breakers cheaper actually. At least this more or less per breaker. Prices vary, but again, I like the old fuse because when it breaks, period, done. You're safe. Fuses, the early breakers didn't break. The new ones are actually very reliable and you don't have to worry about it. Don't listen to my paranoia. And the GFCIs and the more modern ones, again, where are you going to use GFCI? We're talking about that. You're going to use GFCI anywhere there's near water or outside, etc. AFCI, you're required in bedrooms today because, again, whereas most circuits required, but in particular in bedrooms, in places where you may have, a little kid sticks their finger in the wall, or the line gets broken, or an extension cord gets cut. The AFCI is going to keep a fire from happening in the house. Quickly, again, this is what the GFCIs look like inside. The again, the hot neutral goes to the connector down here. When the breaker slips into the breaker box, same thing, the big one here, you got a, hot and neutral here, and then you got that pigtail going to the ground line in the panel. So the electrician extends this pigtail, attaches to the ground line. So a normal breaker wouldn't have this extra ground. Now, where do you have GFCIs? Again, GFCIs are there to shut it off. They're for bathrooms, outdoors, kitchens, within 6 feet of a sink, pretty much any water supply. It is required in garages. It's not required. This is an interesting thing. If it is in a place, I know it's a garage, okay, bad, but you don't have to put it in a garage. Let's say if it's powering the, let's say the garage door opener, and it's 10 feet off the ground, then you don't have to worry about shock as much. So, and that's a case where you don't have to use GFCI. Because remember, GFCI can be bad too. GFCI will accidentally trip a circuit, which didn't really want to be tripped. And you might have to, climb up on a wall to start your garage door opener again. So that's a case where you might not want a GFCI. Again, thinner 15 amp, wider 20, 30, 30, 40 amp. And again, older ones, as you can see, it's different manufacturers have different things. Sometimes it has a push button here. Again, go to Home Depot and take a look. You'll learn a lot by just handling and holding these things out of the bins, and you'll get a real good insight as to what you might come across. Now, GFCI, where's it located? Not near water, right? Okay, here we go. We're doing that interior walk around of the space. We're looking for water damage here everywhere. Well, electricity really doesn't like water damage. So I don't want to see any outlets, things like a fan or a GFCI outlet within 3 feet of the shower. That can be tricky because your razor or whatever location can be tough. If you are within, you got to be GFCI. Okay. Again, a fan or something like this doesn't have GFCI, so it just needs to be 3 feet away from the shower, and obviously 3 feet away from the sink, unless specially designed. Kitchen, same thing. Now you're looking at kitchen design. Kitchens today, older kitchens don't have all these outlets. Today, though, you might have 47 bread makers and blenders. I'm going to make a nice smoothie when I get home, and whatever else. So you want to space about between 2 and 6 feet away, at least 2 feet away from the water, and then about 4 foot different in interval. This is good placement of outlets in a kitchen. And no matter what, you do want to see GFCIs. If they're not GFCI, if they don't have this tripper switch, then that's a problem. Again, you might see them out on the islands, all different locations. The idea, of course, is it's supposed to be within 6 feet of every area. How does it work? Again, look at the diagram offline. Big picture is hot neutral coming in. You got the hotline coming in, and it detects a short, and it quickly flips the breaker, activates. It goes right to the ground here, the white ground, and switches the neutral off before. I said that wrong. The white neutral is again, getting you off without having to go to the ground, so it's much faster. Again, your GFCI tester is you're plugging it in to make sure it works. In this case, an open ground, that means the GFCI is not going to work because the ground is not connected. Therefore, it's not going to flip off when even though the light is on and the switch brakes works, it's not going to properly disconnect. Now, AFCI breakers, again, special circuit, same basic idea. It prevents arc fault. Arc meaning, again, when the wire doesn't bend properly or a nail is driven through the wire, you could have a fire. And again, GFCIs are not required everywhere. AFCIs, bedrooms is one main place. I got to check the code again as to whether they've added it to be required everywhere now. So I got to do a little research on that. AFCI again breaks the circuit when it detects an arc. An arc, that tiny arc right there, never forget when electricity is going through the air, that's called plasma. And plasma is hot. It's actually for all you techies, you would know that plasma is the fourth state of matter: solid, liquid, and gas, and plasma. And, just a little crack line in there, that crack line becomes a fire. It detects it, turns it off, and prevents the fire. And then you gotta figure out where the heck that arc is. And in some cases, you might have to rip the wall out. But ripping the wall out to find the bad arc line is a lot cheaper than having fire damage. Why does this happen? Oh, somebody drilled a hole in the wall to hang a painting, and hey, drilled it right through the electrical line. Quick reminders: outlets, as you might see in this case, it's half and half. These outlets may be downstream for many reasons. I'm not sure why they would want this double here. I don't know. I'll come back to that. And I think it's a 1:30, guys. So I'm shooting you along on lunch. So let's knock off. It's 1:35 now. I'm going to shut down till 2:10. I will start back at 2:10. So I'm going to leave the thing broadcasting, and hope you guys have a nice break. I hope 35 minutes is enough, and then we're back to the coal mines. Okay. So I'm signing off at this point. I'm going to put some images up to scroll while it's running, and I hope you guys have a nice lunch. Bye-bye. 2:10, we're starting again. Okay, looks like I'm late. Let's get cranking again. How's everybody doing? So we've covered a lot of ground this morning, and kind of somewhat repetitive, and I go things over twice. I hope hope it's been sinking in. I hope you're also reading the book, looking at the PowerPoints, and trying to think about all the different things you might see in a house. We also want to think about, what is, to some extent, we're talking about something we can't see. But when we do see it, it's probably a bad thing. And I think that's kind of a easy way to summarize electrical work. Let me get the screen cleaned up a little bit. So as you saw during the break, I left the slide present, just a random set of images attached to the slides to go through to give you something to think about. And I hope there was some value in that. And I don't know. Let's get back to work. Everybody doing okay? Anybody there? Once, twice? Okay. Well, I assume somebody's there. Let me get cranking again.
I'm here.
Hello. I see some great spelling on this slide. Junction Boaks. There's an old saying that the work of the night is the laughter of the day. So in that case, our junction folks are all ready to go. Let's see where we are. So again, back to that question of GFCI versus AFCI. AFCI is pretty much required on everything now, and the goal, of course, is that the breakers are going to stop a fire. The GFCI is required by water. Older houses prior to like the 2002, roughly before 2000, they're not going to have AFCI. And if their mark is not FCI, you may want to recommend that they upgrade, especially in kids' rooms. If you've got a couple little kids, you might want to make sure the bedroom circuits, which were originally the bedroom circuits only, needed it. Now pretty much everything does. So continuing, we talk about junction boxes again. Again, totally sloppy work. On the right side, what typical junction boxes would look like. Again, metal is on older houses. They didn't have plastic yet. A lot of jurisdictions didn't allow plastic at all. In high-rise buildings, of course, you still can't use it, but it's becoming more and more common to have plastic boxes. So again, ideally, you never see this, right? Ideally, you're never going to take the cover plate off, but I just want to make sure you understand what's underneath. Surge protection. As we've already talked about that, the lightning rod, the ground, very similar. The grounds can have a lot of surge protection, a lot of different devices, the antennas, the main unit, of course, the building ground can have a lot of different things tap into it. Of course, individual devices these days will have a surge protector, a little circuit breaker, which is a good start. But anytime the wires are outside, I like to say if lightning can hit it, then you want to have it on the ground. The antennas are probably the worst. We talked last week about chimneys, or a couple weeks ago about chimneys, and chimneys in particular just get the crap beaten out of them by lightning. We may not notice it, but an antenna on a chimney is a lightning rod. So it's not uncommon that a chimney gets blown away or destroyed. I've seen quite a few because of a lightning strike. Circuit inspection is, again, as we're going through, here's our junction boxes again, some more pictures. We've looked at these already. And testing of circuits. As we walk around, you have a lot of different devices. I showed you a plug-in one that works pretty good. This one on the left is a very nice one, and good if you have bad knees, if you don't want to bend down all the time. This particular device, with that leader, the 12-inch leader, lets you very easily plug in, check a lot of devices. Again, if you're doing 100 outlets per day, and maybe that extra $20 is a good thing. On the right side, this guy's not checking detector. He's got a fire damage, so that's not good. Clearly, the fire damage has happened, but he's using this pen detector to detect voltage. So what he's really doing here is he's putting the pin in, not the screwdriver, and he's stupid to even be getting the screwdriver near it, because he wants to make sure there's no voltage. He wants to know that this line is dead. This could actually be burned, but it could still be an active circuit, and that's kind of scary. But so he's checking to see. You probably want to leave this. If you see fire damage, I'm not even going to touch it. I'm going to say, fire damage at outlet, have an electrician inspect it. Little reminder of animals and cats, hey, what can you say? On the right side, again, this guy's going around and checking the GFCI outlets. That's a good thing, right? He's trying to make sure the outlets are all not only GFCI, not GFCI actually, just that they're properly aligned. The hot, neutral, and ground are all where they should be. There's no hot in the ground plug, etc. And this might be something. This is a type of circuit non-GFCI regular circuit protection that you want to look at. Again, you plug it in, and the orange again. Hot is the hot, ground is the ground, but the ground is cold because the ground shouldn't have any circuit in it, right? The worst thing in the world, of course, is if the circuit's on it's yellow versus orange. Again, I don't ever want to see this. The reverse bootleg, as we saw here, this is where the hot is actually going into the neutral or in the ground, and therefore he's actually detecting voltage in the ground. This is a very quick test. Generally, bang, bang, bang. You don't ever want to have a hot ground wire. Now, from a voltage perspective, this is probably the best way to look at it. Reverse bootleg. Excuse me. Again, here he's testing neutral to ground. He's got a circuit. That's not good, right? And then this one, he's doing neutral to ground. And again, he's got nothing. Where that actually should be, excuse me, that's the hot to ground. The hot to ground should be a circuit, right? That's a neutral to ground. He's got it because the circuit's reversed. And in this one, it's hot to neutral. And of course, that is normal. You're supposed to have a circuit there. And as you see on the meter, it's 120.68, 121.05. So it's more than 120 volts. Is that okay? Yes. Again, the American system is designed to operate roughly, you want to say 125 on the high end. And because of voltage drop, you ideal target is no more than 100, 105 on the low end. And in that range of voltage, your materials and your devices will act properly. Circuit switches, again, there's many types of switches out there. I was talking earlier, this is up in an attic. Somebody had a 100-year-old plate, copper, look at that, copper plating. You can see the corrosion. 100-year-old plate, still worked. The rocker switch, pressed open, press close. Now, the downside of this is it's obviously this type isn't used anymore, and for good reason. Lots of different types of switches you have these days where they're combining on off with rheostat and lots of different devices. Most architects I know prefer simple. I know there's a lot of fancy controls, but if it's doing light, I take it back. Dimmers have become quite popular, but today also a lot of these devices, like the dimmer rheostat here, of course they've been there for 30 years. But the risk of this is the certain light bulbs don't dim well and burn out faster. And today, of course, you can actually have a Bluetooth device that'll do the dimming, or today color changing. I mean, you guys I'm sure you see the light bulbs that will, do 50 colors. Not sure why anybody wants it, but I guess it's good for a party. By the way, give me an audio check. How's everybody doing? Everybody okay? Everybody out there? Anybody out there?
I'm here.
I'm here.
Thank you.
We're good.
Thank
We're
you.
good.
Thank you. How's everybody doing? Let's, I take a 5-minute break. How's everybody? First of all, did you have a nice lunch? Second of all, what did you learn in the first half of the day? And what can I do better?
Plasma is the fourth state of matter. Off topic.
Ooh, yay.
Plus a lot of other.
Hey, so I hope, I know it's kind of repetitive because I need to hammer ideas through, but I hope you're all getting it. And I hope you're thinking about it as you maybe look around the house you're in or wherever you are. I'm in my office right now, so that'd be a little difficult, but you get the idea. Although, I guess my backdrop doesn't imply that, but hey, who cares? Let's change backdrops.
I wanted to mention something about the voltage that we spoke about internationally.
Sure.
So in Italy, the voltage that they use is 230.
230. Okay.
Yeah,
I'm
and
sorry. I vaguely didn't remember that. But
yeah, and I guess just a word of advice for anyone who's traveling: if you're bringing any of your appliances with you on vacation, not only do you get the outlet chain adapter, but the voltage adapter, because you'll plug in something that's American and now you're giving it double the power and it'll burn out on you. Like it'll go twice the speed, and if you're lucky, you actually see smoke coming out of it. So just
yeah, that's
yeah.
definitely a problem. Well, given what the airlines charge per kilogram of stuff, I'm probably not taking my blender with me on my next vacation.
No,
But
definitely not.
I did drag a very huge desktop in 1987 when I went to England, and again, their 240 volts drove me crazy. It took me about 3 weeks to get a proper adapter to make it work. And as you probably all know that with laptops, they are pretty good at range of voltage and amperage and cycles. But regular devices don't have that luxury, and you pretty much can't use it. Which is why, as I said, in New York City, I have dealt with people that have actually gone the opposite and wired their house for the foreign electrical. I saw that for an English guy. He had done that. Anyway, let me get back to the business. But yeah, it's a great point. Again, many things change. The number of cycles, the AC and DC, as well as the actual voltage. And like you said, plugging a 110 into a 230, you're going to have a bad day. So again, one last chance. Anybody thoughts on where we've gone so far today and what we can do better? Anybody got comments, thoughts, etc.? If not, I'm going to push on.
I had a question.
I'm listening.
How much is it to purchase insurance as a home inspector?
Great question. Approximately, what they require, what, $500,000 or $250,000, and many houses won't let you even on the house unless you have $1 million. So I definitely would price $1 million. That's what I need as an architect. My architect is 8,000, but I have more liability. Home inspection, I think somebody told me they'd recently gotten it for a year for 2,000. So it is a line item, but
question.
Yeah.
Now, if buy an insurance policy covering up to $1 million, you wouldn't be able to inspect anything over?
Well, the reason, the law says you have to have $500,000. I think we went that in one of the other slides, or one of the other presentations, but the
home inspection class.
The law doesn't care. The client doesn't care what the law is. I've had literally the owner will say, unless you have $1 million policy, you can't step in my house. And that is very common. It sounds crazy, but it's common in super high end because people will intentionally get hurt. I had to negotiate with as a trustee of the Carpenters Union. And, in the last recession, when things started going down, all of a sudden about 300 carpenters mysteriously got injured on construction sites. And that cost a lot of people a lot of money. And
guys work here?
What's that? What was that again? Whoever's talking is. Somebody just said something and it didn't come out.
I apologize. Mute my mic.
And you're still not coming
I
out.
apologize. I'll mute my mic. Sorry.
Okay. Anyway, long story. Again, definitely ask questions at any time during a lecture. We got 4 more hours, and help me keep this interesting. So throw stuff out as I try to visually bombard you and let you think about things you might see. Again, in the reference section of the online, there are actually entire textbooks of home inspection to complement the book, hopefully, that you have, and now you have my PowerPoints as well. But there, again, the key thing is there's a lot to see out there. In fact, there's so much to see that why don't we take a quick detour, and I'm going to take you through a typical report again. I think this is perhaps one of the most useful things we can do, because it actually forces us to hold on for a second. It forces us to look at what an inspector might have put. So on the again, on the reference directory, and I believe I mailed this to you as well recently, there is there's a directory I believe called samples. So with that, let's take a look at a sample report. In the InterNACHI website in particular has about a dozen good reports, which I've put online. I've put on the reference directory. Let's see, we got. I'm actually scrolling through this is the reference directory right now, and as you can see, there's a lot going on here. A lot of sample inspections. Here's let's look at this one. This one's a good one. Friend of mine's house in up in Westchester. And let me see if I can get it up on screen. Okay, it's on the wrong screen. Let's get it to the right screen. Put it over here. Okay, let's zoom in a little bit. This is, let's spend a few minutes looking at a sample inspection. Why? Because hold on for a second. Again, I assume you're watching this on a laptop, so you get this in pretty high resolution, which is good. Oops, let's get rid of that. Sorry, as my screen goes blank. There we go. So let's move this out of the way. Okay, so taking a little browse through a typical report. It's a nice report for a house. The owner was, or the buyer was actually an architect, but he was smart enough to say, I'm an architect, but I'm not really good at houses. So he paid a home inspector to take a look. So this is a typical report done by this home inspector. This is literally, raw material. There's the house down below. He's doing a report online. He's doing it from a tablet as he walks around the site. Now, obviously, we start with the introduction. The company here, their extra stuff. They're saying, look, we're InterNACHI, but we're also radon and infrared certified if you're interested in that service. This house probably could have used some infrared because it's got some serious leakage problems, but one day at a time. Of course, the owner is moving from California. He doesn't, even though he's an architect, he doesn't have time to negotiate and deal with it. So he hires that person. So the inspector has started with, first of all, the long shots, the site. I'm going to try to go as fast as I can through this. Again, there's the client, the address. We don't need to know that. And this is, first of all, the report starts, again, whatever software package you're using. In this case, the report starts with, this is what I think you should do. Is it a big deal, small deal? Is it just a maintenance issue? Evaluate, monitor, FYI, damage, conducive conditions. So these guys are pretty detailed in their report, and I respect this. And again, practice makes perfect in doing this level of work, and you'll get good at it, especially as every house is different. It's like a 1950s ranch house. So the report starts off. First of all, he's talking about the New York State SOP, which really he's using the InterNACHI SOP, but it's he's just working his way through. So again, who's there? The realtor is there. Now I'm not sure whether that's the buyer or seller because the guy probably didn't know, and he just put realtor. Well, if necessary, you can figure out. The key point is he's not alone, and the owner and the buyer are not there. Client address. What an unfortunate email name these days, huh? Continuing again, hot and dry day. The temperature matters, right? No rain that day. That might show different things as you walk through the house. In fact, it would have been nice if it were raining because this house had some water issues in the basement. Um, Again, the guy's estimating age of the building, which tells you a lot about the type of construction, right? If I say 1950s, I say asbestos. If I say 1950s, I say tile roof, 60-year-old mechanical systems, things could be failing. Is it occupied? Yeah. The current owner's stuff are there. Pictures, again, general quote on pictures. He starts going through. Rodent droppings. Oh, charming. Now, not only he doesn't just say I saw roaches, he says he said I didn't see rodents. He puts a link nicely to the CDC, the Center for Disease Control, on why rodents are bad. Now, most people know, but it's an interesting way he cross links in his material, and it's impressive reporting. Again, he's looking through the living room. He's 1950s tiles. So 1950s, that's not good, right? That means the 9-inch tiles on the living room floor or in the basement floor, probable asbestos tiles. Pipe insulation in the basement, a little bit's ripped off. That's even worse. Now, the inspector will never say that it's asbestos. That is up to an asbestos investigator. And that's a state license, asbestos investigator. And by the way, a nice thing you might be interested in getting. It's a good certification. And no, I don't teach it. Again, the asbestos investigators, the insulation is broken open, so the asbestos could be in the air. So he's raised that issue. He says may have asbestos. Doesn't say may. Doesn't say must. Again, absolutes, as in any profession, they'll tell you absolutes are a dangerous thing to say. Okay, so in this case, he's inspecting a house that's still occupied. So he's going to be limited. I can't see everything. Oh, look at this. There's some new drywall here. Wonder what happened here. Maybe there's some old water damage. Clearly, the garage, you can see the garage is stacked with stuff. That's the nature of inspecting a house that's in the process of being sold, right? Somebody might move all their stuff to the living room or to the garage, and you might not be able to see the water damage behind the garage. Here he's taking some basic photos. He keeps going through. He's up in the attic taking some photos, basic bedroom shots, down to that little office in the basement. Just taking some shots. Now, remember, the buyer's already walked through, so he's not teaching them the house. New guys, actually today, I've got guys that are, I have a special LiDAR camera, which actually about 4 years ago, Google put out, I was prototyping it for Google, but they didn't continue it. But rather interestingly, 4 years later, the LiDAR cameras are back in the new iPhone 12. So 3D modeling, you're going to be able to walk through a house and build an accurate 3D model of the house, similar to what Matterport does. For all you stock surfers, that's why Matterport stock is going up. And that model actually will be similar to photographs in the future in the way you have clients look at properties. In fact, if you can create a 3D model, a 3D walkthrough of a property for a client that's, a long distance client, that's a pretty sexy tool. Hi, I don't merely do a home inspection. I'll give you a 3D model, a 3D rendering of the entire house that you can walk through to take a look at what I've said about the house. These are, again, thinking a little about the technology as it's evolving. So again, one of the railings are unsafe. So he's got a safety. He's got a thing. He's got to fix it and investigate it. So he's got these little symbols here, which I think are interesting, kind of tacky, but it's one way to do it. Here, what else? Again, he makes a general quote. He doesn't do the repairs, obviously. He says a qualified contractor should evaluate and repair. This is all about you are observing, not repairing. Oops, what did I do? Zoom out a bit. Okay, let's continue. So here we got the classic 4-inch railing problem. He's saying the railing should be, again, 4 inches, 30-inch clear. We talked about this in the exterior. He's saying here that it's, I think he says it's okay here. But this guy's got older kids, so he doesn't care. Again, the handrails, he's looking at the 4-inch rule, saying the handrails are a problem. The open risers, that can be a problem in some areas. Again, more than 4-inch gap, potential tripping hazard, and a potential get your head caught in it hazard. Again, a lot of this is nanny state stuff, but it's the law, so you got to just try to deal with it. Handrails, this is interesting. The handrail's too wide. Sounds dumb, but if you've ever fallen down a stair or something, you got to grab. And about the 4 inches is the maximum you want to be, not even 4, because that's the typical grip. Because 6 inches, you're not gonna grip this. It looks nice, it's very elegant in design, but it's not necessarily the most safe. Let's see if I can get to the electrical part. There's the garage. He's found some missing flashing. Attaches a quick little detail from the Internachi guys for flashing about how water needs to be thinking about at a deck, how you got to make sure the water is moving away from that ledger board. See, ledger board wasn't a part of the house. And when it gets attached, you got to make sure it's going to be good waterproofing. Again, little structural issues out in the site. He's raising issues. Trees too close to the house, plantings too close to the house. We talked about these. Drainage, draining back into the garage. This garage is particularly bad because it's negative slope driveway. So it probably, if that drain is not kept clean, you got some problems. Moving on, backyard, tripping hazards. So what I really want you to look at the big picture of how this report is delivering a good product. Here's the roof inspection quickly. I'm going to try to go faster. Again, pointing out some damage, some quick photos. Did he go up on the roof? Nope. He inspected it from the ground, and that's okay. He also sees that looks like there's 2 layers of roof there. More roof damage. Well, it looks like he got up a little bit where he could. I think there's a second floor window, and he could see some cracking in the relatively flat slab and what looks like some penetrations. So he circled them in his report. I mean, remember, to make money, you need to be able to write one of these reports in 3-4 hours. That includes the inspection. So if you can write most of it out in the field, you're going to win. Big fans. Again, I love these fans, but again, they if you have fans and you don't have venting to keep it out, it's going to have a negative pressure problem. Flashing issues, more roof flashing. So again, most of the roof flashing's done. He didn't go up on the roof. He just looked out windows and he he went from the ground, and that's enough for a 2-story house or 1.5-story here. Leader line, something simple as this: a leader line not right. A lot of problems can come here. This one not far enough away. Again, if those of you who weren't here last week, a lot of this was covered last week. So this is just a little quick review of last week's stuff. And here again, in his report, he attaches some standard details, in this case of the Internachi, and the Internachi will help to quickly explain the concept, and quite honestly, it'll make it look like a professional report. And again, I'm not shilling for those guys, but they do a good job, so I want to give them credit. More leader lines, more the outside of the building, up on the roof, a little bit of problems in the attic, fireplaces, that's a section. Okay, so he's got some issues with a chimney. Exterior and the outside of the house, again, different parts. Problem we talk about in every house, that detail of the bottom of the window, always a rot problem. Okay. So the caulk will deteriorate and it'll start rotting the wood, etc. 1950s, this may also be lead paint. So these are also things to think about. Relatively small parging. This guy's pretty tough. He's an impressive inspector. Again, water damage. This house is really not bad. This is an interesting thing. I like the way he said this. The guy saw a dehumidifier down in the basement, and he said it very sarcastically, but it's a useful lesson. People buy humidifiers because they need humidifiers. The house is running a humidifier. That tells me there's a moisture problem in the basement, and that's a. I like the way he said that. Okay, garage. Again, the importance of that garage door being separated from the house. In this case, not so much. No closer, and not rated, which is again ironic for the guy who bought it. Rated protections again, some failures in the roof. So that little crack, if there's a fire in this garage, that fire is going to go right up into the bedroom above. Again, garage door opener equipment, little inspection issues. He's gone through these electrical connections. Again, I hope you spend more time. So here, let's get to the electric section. Here we go. So for given today's concerns, we think it electric required repair or evaluation. So we found some problems. Okay. Service conductors 3, which means hot, neutral, which means 240. So he was able to spot that. Service amperage, it's only 60 amps. It's 240 volts, but only 60 amps. That sucks. So that might be a upgrade issue. Again, the thing that saves my friend is that he ended up buying this house, but the house itself, being with three teenagers and 2 adults, that's 5 computers running at any given time. So I guess they benefit from LED lights and laptops because they use a lot less power than they would have years ago. 5 people permanently on desktop computers, that's a lot of power, not counting you Bitcoin miners. So I have some weird stuff going on outside. One thing about working in Manhattan is I'm at 34th Street. So some people are doing some kind of protesting. Hold on. Okay, again, the garage, we're looking at some of the electrical issues, wiring that's routed poorly and a little too close to the garage, by the way, which I don't like. There's a non-conduited wire running outside. Again, that's pretty good eye, by the way. They painted over it, but you can still see the wire running outside, literally through the garage gap. And clearly, at some point, that garage door is going to cut that wire or damage the wire and cause a problem. More outlets. 2-prong plugs in the basement. That's a bad thing. Again, 1950s. Suggest that those circuits probably should be rewired. He's going through the circuits again, and some of the 3-prong. There were some 3-prong plugs out there, but they actually weren't grounded. So he definitely suggested doing some electrical work in the kitchen. He's saying, as you notice, the bottle of booze from the previous owner, of course. You can see without a GFCI that there's some problems with the outlets. Again, it's right in the countertop of the kitchen. Make it GFCI. I think, and sometimes, by the way, it'll look like a GFCI switch, but it won't actually be a GFCI switch. They'll just put it on top to make it look good, but it's actually a regular 2-prong. No outlets. I guess I actually think in a bathroom it's better to have no outlets than non-GFCI outlets. So he's gone through the electrical in terms of access. He's looking at loose materials, things like the lights that aren't in place. It looks like the owner took down all the chandeliers when he was moving out. Who cares? I guess he left the ugly ones. Actually, these were probably fans, so he probably took down all the fans. Again, he's going around testing the lights. Outlets without plates, that's a baddie, right? The outlet without plate is actually your advantage, because if somebody left the plate off, you can actually look for things like aluminum wiring. Now, for instance, if you have aluminum branch circuit wiring to a small circuit like this, that's something you must have in your report. It's a very serious problem. again, this is an opportunity to see it. Normally, you might not be able to see it. Again, extension cords, lamp cords, all kinds of crazy stuff in the circuitry. More extension cords being used as circuits, not acceptable. This is something you'll see in a 1950s house, because again, this whole house only has 60 amps of service. So at least it's 240 volts and 60 amps of service, but really it's seriously underpowered. And in fact, if my friend didn't have 3 college tuitions to pay, one of the first things he wanted to do was upgrade the electricity. Luckily, his appliances are all gas, so he doesn't have to worry about the voltage drop when you turn on a 40 amp or stove or something like that. Again, outlets that don't work, replace. So he's taking a picture. He goes through as he's testing outlets. He sees he sees a switch. It's broken. Take a picture. Put his finger on it to show what it is, and say, "Hey, replace the outlet. Some wiring's loose, etc." So, and he's looking at the panel box. Is he going to go in the panel box? I don't remember. Let's take a look. I don't think he does, actually. Here's the overhead lines. They're too close. They got some trees in the way. That's an important thing to see. Here's the service drop coming into the house, kind of sloppy and really low. That's scary. This is scary because this service drop connection is almost raw, and it's only 4 feet above ground. That ain't good. But also inside the building, you get a low voltage system. Anybody recognize what that is? That, I believe, is a Verizon fiber router. Whatever the service, I'll leave that for another day. But this is the example of low voltage systems, which you don't have to inspect. But that said, I am going to be on alert for loose wires. But loose wires really don't matter. I mean, the best example here is this splitter. In reality, this splitter is exposed electrical circuit. But in the scheme of things, it's not that dangerous. Again, more outlets as they go through. This is probably the original. This is probably the original circuit for the house. It's got a knife blade junction box, and the owner's just saying, "Look, get rid of this thing." What it looks like they had, this was probably the original breaker panel. They upgraded the box, but they never upgraded the wire service itself. Remember, you can have 100, and it looks like we have that here. You can have a 150 amp panel, but the 150 amp panel doesn't matter if you only have 60 amp service coming in. That's a nice modern panel, but doesn't matter because the 60 times 240 is the service coming in. So yeah, I mean, this example, classic example of a dead junction box, right? This was a panel box, but they said, okay, we're just going to keep it because it does function. I can run some wires in here, but not the main circuits. So we'll just leave it open. And no, this really should be removed because, again, there's mechanical equipment in here. Somebody can pull down that handle, break a line, and shock the hell out of themselves. So at the very least, he says, remove the knife switch. And more importantly, just do it right and have a proper junction box. And then we go through plumbing, et cetera, et cetera. Anyway, I wanted to quickly explore this to show you what a typical report might look like. Here's some plumbing issues. That's, I guess, last week. We think about the, as with every major device, he's taken a picture of the serial number and the model number and the year, if possible, because that'll tell him what's doing. That's a hot water heater, right? Well, today in the future, electric hot water heaters may not even have tanks. Kind of stupid, I don't know. But this is a typical a gas hot water heater, and as you can see, it's got the gas line, it's got the overflow, it's got some problems, but he did take the plaque and analyze other problems of it. In the heating system, he turned the thermostat on. It didn't have a security thing or anything, and although it has a couple buttons missing, but you can still make it happen. So again, a $50 fix. But also, actually, the most important thing for him is if he looks at it and tests it and says you can operate it, he better make sure he turns it off when he leaves or sets it back to the minimum if the house is vacant. In this case, he's looking into the ducts. We'll look at this next week or 2 weeks from now when we do the interiors. But again, what I hope you saw with that is this guy was nitpicking a little bit on the electrical parts, and that's what I want you to do, because again, the electrical stuff can be quite a bit of a problem. So let's move on. Now we're going back to the lecture. Again, the key thing there is take a look at the reports that are online. B, if you don't get reference to them, let me know and I'll make sure you get the Dropbox. C, I mailed most of these around to you a couple weeks ago. And D, think about your product. Your product is that report. And this is your competition. This guy's a pretty good competitor. He did a very impressive report. And how did he do it? The answer is probably on the last page. It's going to say something like home gauge or whatever package he did. Could you guys do this in Word in 2 hours? I'd be impressed. But again, you can see how there's a classic template. Each section, you're making comments in each section, you're consolidating, and that report is the product for client. It's an 85-page report total. 62 plus 23, 85 pages of photographs and stuff. Can you make money writing 85-page reports? I hope so. That's a lot of work. So think about how you very quickly turn these products out consistently and profitably. Back to the fun. Okay, back to circuit switches. Now that we've done that house really fast, I can pick up the pace, and I know you guys are ready to rock and roll. So again, different types of switches. Very simply, do they work? Are they damaged? Are they, you're flipping them around, you feel like they're broken inside. The newer, the fancier the product, the more probable that it's broken. The old school ones, again, they have their place too. These, when you see old school switches like this is a 1920s English one. But you'll find them on the walls. A typical General Electric switch like this. This is, at least it was a switch, right? This is one of the early new switches. And these would be surface mounted. Anytime you deal with surface mount, you want to make sure that they're anchored properly to the wall. That's one of the biggest problems you'll have. Of course, broken switches. This is, you're trying to flip the switch in the middle of the night. You stick your hand in and you shock yourself. I mean, there's a purpose for a cover plate, so get it on. So again, is that a 50-cent fix? Yeah, cover plates are, I don't know, $1 maybe, but it's got to get done. And I always say this is a symptom, right? If somebody's left this cover plate broken, there's probably going to be lots of stuff in areas that I can't see that I'm going to worry about. But of course, I'm going to take advantage of it because I'm going to look inside and I'm going to look for, again, looking for aluminum wiring, looking for corrosion, looking for real nasty dirt. And if it's an exterior wall, I'm also feeling for a breeze and things like that. Rheostat, I didn't put an image, but rheostat, of course, switches. Those are the sliding or rotating, adjusting light or adjusting fan or whatever. Does it work? Can you move up and down? Sometimes they break a lot. So I always check them. We talked about multi-circuit switches already. Quick reminder, one switch on, one switch off, it's off. And conversely, on, the lights are on. And if you're real tricky, I don't know, a couple different ways to do this. The big picture is hot neutral plus hot neutral creates an open circuit or a closed circuit. The concept is pretty simple. Four-way, same thing. There might be 3 different entrances to a room. As you're walking around every room, flip the switches. From each of the 3 light switches, on or off, should turn the light on. One of the things I always have problems with is in a bedroom, usually the first outlet or the outlets on the bed wall will turn on and off with the light switch. So my daughter learned the hard way that you have to have your computer plugged into the switch that doesn't turn off at the light socket, because she lost a lot of work one day as she flipped the light switch and her laptop also turned off. Of course, that's for the reason, of course, for that is they want to have the, oh, hold on. My screen seems to be a little big. Let me fix that. Well, I don't know what's going on. It seems like, oh, I know what it is, the toolbar. Better. There we go. Toolbar was in the way. Let's let Mike back in. So again, we talked about knob and tube, old type circuits. We discussed these already. Tubes going through the joists, knobs passing through.
He just said, Mikey's taking your phone.
Hi, Mikey. Hi, Mikey's little one. Mike, you're blessed, but I got to keep you on mute, buddy. Okay. Again, we're all doing this for the little ones, so all the best. Continuing, knobs and tubes. Typical in older houses, you just won't have any insulation. You won't have any interior drywall. It may just be raw exposure, particularly in the attics. But sometimes you'll have parts of walls that are like this. Again, the knob and tube is spaced out, I'd say 1920s. Little reminder, I know that's kind of gross, but a couple things going on here. One, on the left side, you can see that this outlet has been put on by the framing of, there was another outlet behind it. And I'd be really suspicious that that's put on properly. Second, on the right, I know that's gross, but this is a reminder to you, and this is very important as you inspect. Mice love to eat insulation. Is it gross? Yeah. Is it real? Yes. Is it a potential fire hazard? You better believe it. At some point, he's going to be gnawing away. Hopefully, he's gnawing on the ground. But once he goes for the hotline and touches something else, he's going to have a very bad day. And that type of damage is quite significant. Now, of course, safety we care about as we look at these things, but we do want to, get access. Now, you are not going to unscrew an outlet like this. Do not do this. I'm showing you this for illustration purposes, and I want to show you this to see what's in a wall. Again, somebody's in this picture, they're changing a typical outlet. It's pretty easy to do, but again, if you screw it up, you're going to be in pain. First of all, you obviously got to take down the circuit before you do it. And second of all, what I want to show you here is, of course, the neutrals, the grounds that are all that are part of an outlet. On the right side, older outlets. Again, if you look really closely, that's the double angle. I think this was, I don't want to say Chinese. I think this was from Australia. I didn't take this picture, but I thought it was useful because, again, these round outlets for things, are, as I said, electricity was a luxury in the 1920s and 1930s. So having electricity was all about style. So the utilitarianism we have of today at that time was all about, I want to show you that I'm cool and I have electric service. So the electricity was mounted on the surface. It was really artistic elements, as you see here. And again, 90-year-old unit, lots of dust and dirt and mess, and not real good. This one, another example of a more important thing you might come across, which is an outlet that has had a fire. Again, an opportunity to investigate the wires. You want to make sure that it's grounded properly. I am not going to touch, I'm not going to insert a three-prong tester in this, but I might run my pen tester on the inside to make sure to see whether it has a circuit or not. Again, if this is a hot circuit, that's a big concern. Am I going to fix it? No, it's not my house. But I am going to, if we're walking around with the owner, this is where a Post-it note comes in handy. But, quite honestly, they probably know it's already damaged. So you're not telling them anything they don't know. Again, think about who your audience is at all times. Your audience is a potential buyer, but you may be walking with a broker, or you may be walking with the current owner or the potential buyer. And what you say can have impacts. If you say, well, that's not a big deal as you're walking around with a new buyer, then they're going to say, oh, but that wasn't a big problem. but your report said it was a big problem. Well, I decided later it was important. Well, but you didn't tell me that when we were walking around, so I'm going to sue you for $500,000. Is that crazy? Yeah, there's a lot of crazy people out there. By the way, and that no more time than now for crazy people, because a lot of people panic bought houses without any home inspections, and prices went really crazy. And in other parts of the country, the prices are very quickly corrected. So a lot of people that rushed out and bought a house 30% more than they should have paid for it are now going to go back and say, hey, home inspector, what's your problem? But actually, the good news is most of those people bought with waiving a home inspection, so you're off the hook. You can actually make money marketing to the people who bought the house sight unseen in maybe June or July, and reach out to them and say, you bought the house, but you probably ought to have a home inspection. So maybe you can schedule a good week upstate and do a bunch of home inspections on houses that are already bought, but you can do them as a precautionary or an advisory home inspection for the new owners. As a reminder, you can do advisory home inspections anytime, anywhere. But in particular, as people rush to buy houses this year, there's a real estate opportunity in finding out who bought houses and offering, for a fee, of course, to inspect the houses when they originally bought them and didn't inspect them, because you might actually find something that's dangerous. And they probably won't mind paying you $500 if you find out there's a carbon monoxide leak in the heat exchanger unit of the furnace. Anyway, these are things to think about in terms of business strategy. Light fixtures, of course. The switches we've talked about already. The fixtures, as we look up, we'll see lots of different things. In this case, it's just a garage light fixture, and the guy doesn't care. He's got an open junction box, not good. He's got the leftover plate from what used to be a dome light, but like so many lights, the dome's broken, so he just put a floodlight in it as a replacement, or he may have just taken it down because the floodlight was a better fix. Nonetheless, he has a light fixture that is not acceptable and needs repair. First of all, looks like very bad and sloppy wiring connections. Second of all, it's got an open junction box, and third, the protective dome is removed. So, given all three of those things, I'd raise an issue. Can anybody see what's wrong with this picture? You got to double take it. I saw it and I loved it. I had to grab it. You guys all see that, right? Anybody see this? Come on, what's wrong here? Somebody tell me. Hint, turn on the fan. Okay, I guess you guys are all asleep.
It's being supported by the fan rather by itself, and is the power like series?
No, but if you turn on the fan, what's going to happen?
The lamp is going to turn on.
No, the lamp is. If you turn on the fan, the lamp is going to hit the fan.
Oh yeah. Oh well, yeah. Wow. That was the obvious. Yeah. Sorry about that.
No problem. Anyway, you're absolutely right though. In this case, what came first, the chicken or the egg? My guess is the lamp probably came first, because that's like a 1970s style lamp. I know because my mom had one in her house. And chances are they added the fan later, but they didn't have electrical supply for it. So they kind of rewired a little bit so they could run the electrical supply for the fan without having to put a brand new junction box in the roof. Again, dumb. I just do this thing as a good little mind, for fun. Again, as you're going around, you're inspecting them, look for the circuitry, look for double taps, bad wiring, etc. Actually, a whole bunch more in that slide that I can't get to right now. A bunch of images, but that's okay. I dumped a bunch of images into the slide, but I didn't sort them out. Okay, other aspects. This is probably one of the most good news is this is obsolete. Again, this is a typical floodlight coming down from the attic. Now, these things used to be very popular. They were incandescent and they were very hot. So they created an immense amount of heat. So you had to have an area around them. As you can see, in the 2-foot spacing of the attic joists, or attic trusses. And they did something good here, which is they built a nice styrofoam box. And reason why? The answer is because the cold air of the uninsulated attic would usually come right through the light socket and down into the room. Now, the good news here is this device, this big, huge device, is now replaced by a very small, low voltage, flat LED light, which is just as powerful. So a lot of this detail you'll come across in older houses, and very often it's screwed up, as we'll see in a few minutes. The big picture, though, is we talk about the lights and the outlets as penetrations in the conditioned space. Conditioned space meaning, hey, where I'm doing the air conditioning. And anytime you're poking through the wall at that, whether it is an outlet on the exterior wall, or in this case, a light on the roof, you got to think about how it goes all the way through from the light to proper insulation, then blown insulation on top of that, and a little space for airflow, and then, of course, the unconditioned attic. So this is something particularly important when you're inspecting the attic. Here's another a box example of what that box might look from the rooftop view. Of course, the downside is that in putting it in, all the loose insulation got knocked away, so you're still losing in terms of insulation. Hopefully, they raked all the insulation back into place afterwards. Probably did, because if you look at these, the polystyrene attic insulation things, somebody's probably doing this thing the right way. That's a sign of a pro here. Okay, again, another example. This is where things go wrong. This is a can light that they put the can light in, but they never had insulation. And this area right here, this 2x2 area, is basically letting, it might as well be a chimney in terms of the amount of energy it's losing from the space below. Now, this is becoming more and more important in the coming years as energy codes become so critical. You're going to spend a lot of time, and architects now are spending a lot of time thinking about where can air leak out of a house. And he did a good job sealing this up. The area around needs to be sealed. Here, he just kind of pushed the insulation back, did his cut, and now he's got a terrible energy loss. Again, light fixtures, things you'll see out there. Can anybody see? I don't know if you can see. This one's kind of tough. The top left corner. I've got to put more contrast on this image. What you don't see is this guy's got a kitchen outlet. He's got the razor outlet. I'm not a kitchen, in the bathroom. He's got the razor outlet in the bathroom. So what does he do? He plugs in an extension cord. I'm not sure if you can see this, but he's actually taking the extension cord up, drilling it through the floor up into another area of the house. Lame. Fire risk, but all too common. On the right side, this is for about 10 years, compact fluorescents were pretty popular. They're not really popular anymore. Why? Because they still have a lot of mercury in them, even though they say they got rid of a lot. And they're also pretty fragile. In fact, compact fluorescents, particularly here, this one's being used outside, and they don't like being outside. And again, even worse, it doesn't have the architectural covering on it. So there's a good chance that the outlet's going to break. This one, again, isn't broken yet, but it will be broken soon. Clearly, as you can see the outline, this is a replacement fixture from probably an even older fixture behind. And while he's saving money with the compact fluorescent, A, it looks bad, and B, it's very vulnerable to breaking. Again, this one on the right side, on the left side, again, if you can't see it, the extension cord running up through the ceiling. Really keep an eye out for that. People in, I don't want to say, but I don't want to be mean, but the less money you make, the more shortcuts you take. Although that can be flipped both ways. Inspecting houses can be a challenge. And if people beat up a house, a lot of people sell because they sell their house because they want to move. They sell their house because they die. And they sell their house because they're getting thrown out because they couldn't take care of it. And you always got to watch out for number 3. Again, as we're inspecting areas like the cellar, this is a light, one of those can lights I was describing earlier. And It's really old. This has like almost horsehair wire coming through the casing from the attic. This is looking straight up into this. And that horsehair wire, actually, the insulation is broken away. So this is raw circuit touching the metal panel. This thing is electrified. And it may actually be why there's so much rust, because it's very quickly not electroplating, whatever the name, but there may be loose electricity getting onto this metal and turning this into a heating element. A, wasting a lot of electricity, and B, causing a potential fire hazard. So again, here you put a report, loose insulation. This is a pretty serious one because it is raw wire on metal. You're not going to fix it, but you're going to put that as a safety issue. This is more stupid than actually, some would say it's quite ingenious. The guy couldn't put an outlet in his cellar, or he couldn't put a fixture in his cellar, so he decided to kind of tape the fixture on to a plumbing pipe to his waistline. I guess again, not properly mounted, but also I remind that when this gets hot, the tape will melt. The tape melts. The outlet falls. The outlet falls on the ground and starts a fire. Okay, so these are things you want to catch. I got a kick out of this one. This is another couple funny ones. The left side, this is a typical 1x4 shop light, and I guess the guy didn't like the color of the shop light, so he somehow wired it inside to do incandescent lights instead. So again, non-standard electrical fixtures, repair or replace. On the right side, in a pantry, this is a light that's fallen down. Again, a light bulb isn't just light, of course, it's a heat source. And that heat source is right on top of paper, potential fire hazard, not acceptable. And I'd turn it off, and I'd actually put a push-to note on the switch saying, leave off light fixture dangerous. Here's our discussion about light switches, light fixtures and fan fixtures regarding near GFCI outlets and water. Again, the 3-foot rule, no light. Why? Because you want to keep somebody from getting killed. A, and B, if you have lights, again, they've got to be properly rated to be in a water environment. Can you have a switch? Yes. Switch also, it has to be protected, but it's very important to have a switch near the bathroom. The worst thing in the world, somebody comes in, turns off the light, and you're in the shower with no light. Funny things happen. Again, chain, pendants, cords, etc., they cannot be permitted in this zone. Why? Because again, when you're wet, you can be shocked, as well as other challenges. Okay, when can you use it? Recessed and surface mounted luminaires are okay, because you're not going to hit them in the shower. Surface, particularly these are designed for showers, so they've got probably a gasket for waterproofing, and again, there's no chance for accidentally whacking it. The switch and receptacles here, while they can be there, they have to, of course, be GFCI, and the switch has to be waterproof. Okay, heaters, electric heaters. I hate to say this, but electric heaters are going to be more popular. Electric heat is incredibly inefficient in New York City because, other than Texas this week, the New York City area has the most expensive electricity in the entire United States except Honolulu. But electricity is going to be more common in the future because of the energy codes. We are being forced to move away from gas heating and oil heating. Again, it's not politics, it's just literally the force of law and the force of building code. And with that, new types of electric heating are coming about. Good stuff too. In Europe, this is very popular, particularly with electrical. They will have wall-mounted heating units. These are okay. I just, people are concerned with them being so close to the wall. But again, these are very sophisticated. They have the air motion that keeps the back panel from ever getting very hot. And there's about a 1/2-inch gap, so it doesn't burn the walls. On the right side, this is from the basement looking up. And of course, those lines attached to the subfloor, those are the beginnings of a radiant heating system. In fairness, I think this is a PEX system but there are plenty of systems that they have electrical methods as well for heating. There's exterior outlets. We talk about the importance of electricity safety. I don't want to see the GFCI outlets near water. And I also want to know that everything outside is properly protected. Again, imagine this is under the porch. Hey, you got 2 feet of snow. Okay, the snow piles up in front of the outlet. That's a recipe for disaster. And in that case, the disaster, the water gets in, arcs through, circuit goes through the water and starts a fire with the whole house. Or at very least trips the breaker. In this case, it's going to trip right at the outlet, much safer and done. This is an interesting project for electricity out on the site. Electrical devices on the site are kind of in a gray area. If you see devices, this is an example of a post with electrical fixtures on it in the middle of a yard by the barbecue. And the challenge here is, of course, it's going to be conduit out to it, and there's an outlet, a GFCI, and a switch. And but you want to make sure that if something goes wrong here, if something goes wrong at this device, it's not going to damage inside the house as well at the main panel. So that's why it's so important with outside devices to have a GFCI. I like to show you this one because, in fact, what we're looking at here is the very often from an architectural design perspective, things are kind of made to be hidden, which in itself is fine, but you've got to make sure that the junction box is really, while it may look camouflaged, looks like the wall, it really has to be completely independent of it, because I don't want to rely on, I have to protect the electrical, and I'm not going to have mortar from this exterior material damage the electrical system or settlement or breaking or water or etc. So the electrical system really has priority. It is going to go in front of, it may look like it, but it's still in front of the thing. What's the problem here on the right? The problem is they actually painted the GFCI rockers here. That's not acceptable. I can deal with you painting the face covers or buying face covers to match. You cannot paint the red GFCI switch though. Smoke detectors. We're pushing along quickly. Smoke detectors are a pretty important thing today, and as we kind of implied earlier, they are being supplanted. No, they are being complemented by carbon monoxide detectors. Yes.
Brian, thank you. I heard about a year ago briefly that New York State was going to implement all smoke detectors to have a 10-year battery life span.
Yes, I just bought one. Yeah,
Yes.
actually.
Okay,
Yeah,
so that is,
good idea. Yeah, they're this whole change every 6 months is crazy, unreliable, and most importantly, typically frequently tampered with. I have been through, walked through the New York City Fire Department, many burnt buildings. And the most beautiful sound in the world is what I call the chirp of death, which is a building a day after it's burned, and we're walking through it, and all the smoke detectors are still going off and chirping. I actually think that's good. It's wonderful, because that means everybody got out. The worst thing in the world, and it happens so frequently, is you read the report, 2 people died in a fire and somebody had taken the battery out of the smoke detector. So yeah, that did become legal. It also, actually I think last month, they passed another law in commercial buildings. You now are required to have a carbon monoxide detector as well. And again, that law came about because a guy at a restaurant in Mineola was down in the basement of his restaurant doing his books. And next thing you know, he's being buried. And unfortunately, carbon monoxide had leaked into the basement. He died at his office in a commercial building. Carbon monoxide had previously mostly only been for residential. And because he died, now every commercial building has to do it. Rule 1, you don't want a law named after you in New York State.
Hey Brian, we're getting a little static from your mic.
You are? Okay.
Yeah.
Testing 1, 2, 3. Better?
Yeah, nah.
Sorry, I was drinking a bottle of water. I'm sorry if I
Oh no, no,
I
no.
think it was on top of the mic, so sorry about
Oh, okay. No problem. No problem. Just making sure.
that. Talk for 9 hours, it does wonders for your throat.
Right.
I remember I was doing this in January when I still had the COVID, so it was really fun to be doing that talking. To all of you guys, when we started H1, I think I delayed it for a week because I had to get a little bit. I was pretty good, but my voice was shot. By the way, if you guys haven't had it yet, I don't want to say don't worry, but be precautious. But although they don't tell you, well, I don't want to sound like a doctor. All I can say is azithromycin makes people very, very happy. I think I probably saved my life. So good stuff. Actually, I never got that bad, but I do think that probably made it much easier, much better. But anyway, I'm not a doctor, so let's move on. Smoke detectors, two major types: photoelectric and ionization. What do they do? The photoelectric is again, what are you going to do? You're going to go around as you're walking around the house. You're going to be testing the smoke detectors. Now, be careful though, because you're going to love this one, guys. 1 to 4 families, they may have the smoke detector attached to the alarm system, the house alarm system. So unless, and very often, and these can be wireless these days as well, where it looks like just a standalone smoke detector, but it's actually going to be sending a signal. Actually, the new requirement is that with smoke detectors, if they go off, they're supposed to, in three-story and above houses, they're supposed to connect to the other ones in the house and go off all at once. FDNY was actually giving them away for free for a while. Again, one that a three detector kit that if there was a fire in the basement, it would alert by Bluetooth the alarm on the second or third floor. Now, that's an example of an inexpensive system, but again, remind that you might do the test button and you might have a fire truck showing up because that test button alerted the security system, which alerted the fire department. Sounds crazy, but that stuff can happen. I forget who's the firefighter here. Is that Thomas Jordan? I think, as you guys know, firefighter, they respond first and then ask questions second. So please be alert regarding security systems in the building. Ideally, you're walking through with the homeowner, and if you're doing that, say, look, I need to test the circuit. And if you're not absolutely sure that if you see a hard wire on this circuit, like there's a wire running out of the smoke detector, it's okay to not press it as long as the red light is on and they got some kind of circuit. But ideally, you should test the smoke detectors and carbon monoxide unless you're concerned there's, again, a security issue. And again, today, you press the test button on the first floor and you might suddenly hear the alarms going off on the second in the basement. And so let's hopefully that doesn't freak you out. But again, good news, the 10-year batteries. And again, B, if those batteries are missing, people can be a world of pain. A smoke detector types: primary, ionization versus photoelectric. Photoelectric is interesting because actually in larger buildings, I think I showed you a picture of St. Patrick's Cathedral a couple weeks ago. And in that building, for the optical detectors, for the photoelectric detector, instead of a little closed cell like you see here inside of a chamber, which is very good for photoelectric, in this case, we had lasers running 300 feet through the attic of the church. And actually, it's important. The French just had another church burned by a Rwandan immigrant or Ugandan immigrant yesterday. Nantes Cathedral, which I've been to, was burnt down. But sadly, those old buildings really have challenges when it comes to fire protection. So fire protection, you can't necessarily put sprinklers in, but these types of photo detection using when you have light going through a certain distance, let's say 6 inches, and if it detects, if the light gets deflected by smoke into the other detector, then that is just a simple physics example of saying, wow, I've got smoke in this chamber. And why would you want to smoke versus an ionization. Where do you think the difference is? Again, there's a question of which is more sensitive. Usually the photoelectric one is a little more sensitive and can be much larger. But the ionization ones are typically what I have in a house, 2 metal plates, a little piece of americium, which is a nuclear material, but very, very mildly nuclear. It's letting a very small amount of gamma rays, or I don't remember what particles, alpha particles out. And if those alpha particles are interrupted, then again, you get the current. If the smoke is there, they get charged by the particles, and you connect the dots, and the alarm goes off. Again, kind of sounds like physics stuff because it is, but it's not too hard to figure out. If smoke passes over these devices, they're going to activate. Now, sprinklers, for instance, these are detection devices, and they may then turn on sprinklers. But sprinklers, for instance, will act in a different way. They will only turn on essentially if you melt the sprinkler. If you look at a sprinkler and you look carefully, there's a tiny little vial of red liquid, and that, I believe, is mercury still. And again, if that red liquid gets to a certain temperature, the glass is going to break and the sprinkler is going to activate. Smoke detectors, again, these are inexpensive, simple, and honestly quite reliable processes. And again, the biggest problem really up until the last 2 years was that 6-month battery. You guys probably all heard the saying, change your spring forward, fall back at the stupid daylight savings time. You should change your batteries, but that is no more. In fact, as a broker, you'll know that carbon monoxide detectors and smoke detectors are an affidavit required at the closing of either a rental or a sale. Okay, what else do we have to cover? So smoke detectors, carbon monoxide detectors, as I said. Now, why do you care? Because carbon monoxide will kill you. What does it do? It sucks. Carbon monoxide is CO. CO is looking for another O to become CO2. So carbon monoxide is essentially energized carbon dioxide, and it works similar, and it tries to grasp another oxygen molecule. When it does, it is taking that oxygen molecule from your lungs, and it damages your lungs and prevents them from converting oxygen. And when that happens, you get a slab. There's some myth, again, carbon monoxide not being heavier than gas. There's a debate on that. Why do you care? This is a no, I didn't take this the other day, but sadly, in conditions where people have impromptu heat on the inside, like they leave their gas burners on, or they turn a kerosene heater on inside a house, that carbon monoxide buildup is deadly. In this case, is a dryer vent. If that dryer vent were covered up with snow, then the gas dryer on the inside could potentially be releasing carbon monoxide into the house. Smoke detectors, again, are there a number in the property? Usually the loosest rule is there's one within every 15 feet of the bedrooms. Then they've moved it along. There's one in every bedroom. And again, recently, for good practice, especially since they're so easy to maintain with a 10-year, you want to have them near the stairs. And even better is they're all interconnected. Again, the tragedy of somebody waking up too late is a very brutal thing. By the time a lot of these smoke detectors go off, you might have, a lot of smoke in the room, or you might have very little time to get out. But it's better than nothing. So, things to think about. Kind of gross. So, chapter 9, important points. We've covered a lot of basic things, and I want to go back and start looking at the inspection points again. But here's some thoughts in terms of some points we may want to think about in our review. First of all, we talked about the do's and don'ts list. The inspectors are not required to be electricians. Okay, they're not required to measure the amperage voltage, but they should test the GSCI again as a relative exterior thing. But if you do test the voltage and say, look, hey, I'm getting 115 volts upstairs, 127 downstairs. You might have a pretty significant current drop. There's something might be wrong. These are types of things that as a more experienced inspector, you might pick up on, and you might save the buyer a lot of money. So again, once you have gotten the basic class, you guys are going to be focusing on individual things. I'm going to be certified for pool inspector. I'm going to be certified for heavy equipment inspector. I don't know. Lots of different options. Lead paint. All these are up charges. And I want you to look at the websites of the people doing this and see what they're doing right and learn from it. I was just trying to redo my website the other day and something went wrong. And now for some god awful reason, I have a template for a home inspector on my Skyscraper Foundry website. I got to fix that. So other types of points. What is and is not part of the inspection? We talked about all the different electrical devices in an inspection. One of the things is not part of the inspection is the security alarm. But I put this for a reason. The reason is if you're inspecting a house and the owner is not there, one of the really important things to do is make sure you have both permission as well as information on how to get into that house. Now, if it's locked up without the owner there, you might have a lockbox and the broker can do that. But whatever the method, make sure your security alarm is A, not part of your inspection, and B, not part of your problem. Number 35, NEC, the National Electric Code. It's a national standard that helps users and builders. It evolves very seriously. I mean, I don't think the building code would, I mean, I have a picture in one of my lectures of the 1916 building code where it says you are required to add asbestos and you are required to add horsehair to your plaster when you're building fireproof plaster. Great. Of course, the asbestos makes the whole house a condemned zone when you want to renovate it. And given New York state laws, it actually is cheaper to let buildings fall down than to fix them. 36, electrical transformers are interesting because they can do voltage up or down. You may have seen the domes that have little lightning inside. I love them. They're great. It's often referred to as a Tesla coil or a Tesla dome. And now what that is, that's very high, super high voltage, but very low amperage. And it's only powered by 3 battery, in my case, three AAA batteries. So you are dealing with 4.5 volts. And yet by doing the windings of the little tiny transformer at very low amperage inside this toy, I'm able to get tens of thousands of volts of lightning inside of that lightning ball. 24 volt is considered low voltage for signals. And again, 12 and 24 volt circuits are going to go everywhere because of solar panels essentially providing 24 volt direct current. If you can tap into that 24 volt direct current with an LED lighting system and a lot of other devices, you can A, save a lot of energy and money, and B, you'll have much simpler and less costly wire. I mean, you can wire your house instead of number 14 copper, which gets expensive. Go to the electrical aisle at Home Depot and see how much a roll of copper is. It ain't cheap. Excuse me. Again, normal transformers, of course, from a pole, you're going from 7,200 volts up in a typical overhead pole, and then you're transforming it down at the pole. You're transforming it to 120 volts, and then sending it into your house. Now, once it's in the house, you may actually combine 120 plus 120 and go back to 240 volts, because the higher the voltage, the more efficient the transport. And that's why the big power lines are like 150,000 volts, because they're losing at 150,000 volts, you're losing maybe 2% of the electricity per mile. Whereas at 110 volts, you're losing 2% of the efficiency per 100 yards. I've got to get the exact numbers, but you get the idea. Higher the voltage, more efficient the transport. In fact, by the way, New York State has a competition right now on how you can design the world's largest energy transfer from the very, very expensive, or excuse me, from the very, very cheap electricity of upstate New York, which is some of the most cheapest electricity in the United States, down to New York City. I was quite surprised they were actually running a competition on that the other day. Interesting. If anybody comes up with superconductors, let me know. 38 or 37 amperage. Let's talk about the different materials. Voltage is the pressure, again, called the electromotive force, or the pressure of current. The amperage is the actual amount of current, actual amount of electrons moving. Voltage times amperage, 24 volts times 10 amps, 240 watts, and that's what is the work being put out. Except there's some resistance and heat loss along the way. So instead of 240, you may only get 238 watts, and that resistance is ohms. Of course, electrical service can run either through, it can come into a house over from a pole, and that service entry goes to a service entry dropping into the house. The other way, of course, is the electrical service. Like most of New York City, the electrical service is running underground in service laterals. In New York City, it's pretty extensive. We take for granted, but all over the city, there are electrical transformers underneath the sidewalks. I had the pleasure of watching one explode once on 23rd Street. Just kind of walking by, and all of a sudden we look ahead a couple hundred yards, and there's a mushroom cloud going up on 23rd Street at about 8th Avenue. And what it was, of course, was the water was pouring in from the street, like a snow day today. But the problem, of course, is what do they put on the roads? They put on salt. So the water plus the salt from the road salt means salt water. Salt water conducts electricity. The salt water pours down into the vaults, which are open to electricity. And yes, of course, every year we have a couple of vaults blow up. And like I said, the power of electricity is unbelievable. So it literally is quite an explosion. So underground service is great as long as it's protected from waterproofing, and again, overhead can be very risky as well. I just want to put a couple nuclear reactors under the street. That works for me. I know it sounds crazy, but believe me, in a couple of years they'll be doing it. 39 overcurrent protection devices. Okay, these are devices that are trying to prevent a surge, like a lightning strike. That's overcurrent. Those protection devices do not protect the meters. In fact, I guess we didn't talk about it enough, but the lightning rod, the grounding rod, is overcurrent protection, and it actually happens before the meter. And where it does happen, it'll actually jump over the meter. The reason, very simply, is if a million volts comes down a line, it's going to just come down the line and keep going, and the line's going to get hot. But a meter is effectively a resistor. It's going to resist the heat. And if you have heat and it gets resisted, that meter becomes plasma. I know, there's your plasma technology there. So again, meters, because they effectively act as a resistor, they act as a heating element. And you put, like I said, a lightning strike through, and it's going to melt. So it's very important that the meters, because they're mechanical, similar to water as well, you don't want the electrical device to go through a water meter, or again, an electric meter or a gas meter. I don't want any electricity to go through a gas meter. That's not good. And which is a reminder that make sure that your grounding line never touches a gas line. 40, the masthead. That masthead is that the electrical mast that's usually is picking up the electrical current coming off of the pole. Sometimes it goes into the house and then up into the masthead and down. But why is that masthead 3 feet up? I think we learned this week, didn't we? Right? What if I got 3 feet of snow? Again, if that masthead gets wet, all hell breaks loose. I have had the pleasure once of shoveling 8 feet of snow off of the roof of a house. It is quite interesting. And in New York State, that is not uncommon. I've been told that Syracuse is actually the snowiest city in the entire United States. Although they just got like 10 feet of snow in Tahoe, my friend in Syracuse is always buried with snow every year, all the time. And the challenge is, again, if you have a lot of snow on your roof, that snow is going to block your vents. Problem. That's why you don't want to have a ridge vent in a cold area. Ridge vent's not going to work in a cold area because it's going to get covered with snow. That's why they have gable vents instead of ridge vents on attics. So that masthead has to be 3 feet above the roof for two reasons. One, the snow, and two, as that wall, as the wire, the supplying overhead service drop comes in, as you use, if you have 100 amp service and you're using 100 amps, that line is going to sag. And as it sags, it's going to get lower and lower, and that's where you could have potential fires. Again, nothing's random here. The 3 feet has a purpose. And usually, again, if you look at the fires, you'll find out what the purpose was. Okay, 41. If there's no main disconnect, again, you might have that one pull that just shuts the whole building down. We showed quite a few of those today. If not, then you've got to go through all the different panels, no more than 6 hand movements to shut down the entire building. So what else? Other types of points we want to think about. Oh, gosh, hold on. A couple of quick random points. Circuitry. The white line for the typical 15 amp circuit is what's in a NM, non-metallic or Romex wire. What's inside? You got a plastic wrap, and then you have 3 lines: hot, ground, neutral. Right? If it's a 15 amp 3 wire, and each one of those wires, of course, has to be a minimum size of number 14. And number 14 is like, a 1/16 of an inch, plus or minus. Again, where does this number 14 size come from? It comes from AWG, American Wire Guide. Look, many of the standards we use today were actually developed by industry in the early 20th century. And so they have some kind of weird logic to them, but just take it for what it is. So as we talk about that wire guide size, I say again, a 15 amp circuit is a small circuit, but it needs a number 14. A 30 amp circuit is a pretty powerful medium sized circuit, and it needs probably, I think, number 8 circuit. The point is, the bigger the wire, the bigger the diameter of the wire, the smaller the number. So with double aught, 00 is 2, then 0, then double aught, and that might be for an overhead line. 43, aluminum wiring tends to overheat. Yes, aluminum was used in houses in the 60s and 70s, again, for cost function, and they know aluminum heats up more than copper. So what they did was, again, everything's about making sure the walls or the wires don't get too hot on the wall. So their solution was, well, if I use a number 14 in copper, I'm going to use a number 12 in aluminum. So by upsizing one size, they felt at the time that was enough. It's not acceptable today. It was acceptable. It's not illegal. You don't have to tear it out because you can't, but it is an issue. Okay, 44, knob and tube used in buildings prior to 1940. I think we saw a number of images today about knob and tube installations. You'll come across it a lot in the New York City area. In New York State generally. I mean, people haven't really been building a whole lot of houses here for about 40 years, relatively. Much of upstate New York used to be a big industrial plant, and it's died. The island has done pretty well over the last 50 years, and parts of Westchester, but further upstate, you can't believe it. I mean, you can buy houses for $1,000. You can buy hundreds of houses for $1,000 upstate. I'm being generalizing, but just go to Zillow and do property searches for under 10,000. You'll be shocked by how many properties you see in Syracuse or Utica that they'll sell to you for under 10,000 bucks. Again, 46, back to electricity. Single pole, single throw. That's a switch on, off. A basic residential switch. 2 contacts, hot and neutral, right? 47, the 3 wires coming into a 3 slot outlet. We talked about those outlets again: hot, neutral, and ground. Um, Smoke detectors. Now, why do I say this? Oh, smoke detectors do not detect flame or heat. Smoke detectors don't give a damn whether it's 200 degrees in a room. What smoke detectors care about is that smoke is passing through the detector and blocking the light and causing, or blocking the electrical circuit, causing the smoke detector to loop to close and the alarm to go off. So this one more time. There are heat detectors uh, or flame detectors. I have dealt with some very, very high-end museums where they put very sophisticated heat detectors and flame detectors in the building. Why? Because they want to catch a fire before it's too late. Uh, the most sophisticated system I saw, like I said, was above a cathedral, but the problem is, while it has the heat detector, it doesn't have sprinklers. 49. GFCI, as we talked about, ground fault circuit interrupt switches. They are needed. Basements, bathrooms, pools, garages, but not in out of the way areas. So again, if you have an outlet that's powering the garage door, it's on the ceiling. You're probably not going to need a GFCI because chances are you're not worried about you getting shocked too much. Okay, 50. Metal underground gas. Oh, the metal in an underground gas line cannot be used as a grounding electrode. Why? Duh. If you're using a grounding electrode, you might get hit by lightning, and all that voltage is going to come down and try to find its way to the ground. In normal circumstances, you can attach a lightning rod, or you can attach or lightning ground, or you can attach it to a metal pole, which will dissipate the heat as if it just like a pole, just like a grounding rod, and it'll set it in the environment. However, if that pipe is filled with gas, again, when lightning plasma hits, the lightning, is releasing an immense amount of energy. And of course, it could heat the metal and explode the gas. Just Google gas explosion in YouTube and you'll see what I mean. There's plenty of examples. Quick images on thermal imaging. Oh, there's the one I wanted to show you. This alone should be the reason why you want to buy one of these. A couple things going on here. One, you can see where there's a clog in the plumbing. Again, somewhat beyond the scope of the home inspection, but it's a good value for you to add to say, look, you're not going to say, hey, you got a problem. It's terrible to deduct $5,000. You're going to say, hi, my thermal camera indicated there might be a clog on this plumbing line. You may want to look at it. Over here in moisture intrusion, same thing. This is stuff you might not be able to see because it's underneath the carpet. Wow, that's a great image. That's going to save people a lot of money. They're going to find out why the floor is fixed and fix it. Otherwise, they're in pain. And third is, I think, the most important for our safety, which is using a thermal camera to spot hot circuits. These other circuits are not being used. This one, that's hot, baby. So that's going to be the one that not only physically you'll be able to touch it as hot. It's 133 degrees Fahrenheit, or Celsius, excuse me, in this case. So that's 280 degrees Fahrenheit. So again, thermal imaging is a great tool. I just love these quick images, and it lets you start thinking about some of the problems. Now, most of these problems you cannot normally see in an inspection, but any value you can add without risk is not a bad thing. Of course, thermal imaging on older houses, you can see the windows are just shedding an immense amount of energy, but the walls are doing pretty good. But vertically, you see some other elements like this. That's a heat pipe coming up from the cellar. Or that's an open window at the bathroom in the back. Or this yellow area here, that is the floor. That's where the floor rim joists are up against the exterior wall and they're not insulated. So this is wood with no insulation. So a lot of energy is coming through. On the right side, this is a passive house. This is a house, I believe, in Park Slope. And these guys, excuse me, these guys did a ton of, like 18 inches of insulation. Now, good news is, with all that insulation and great windows, this thing has a very limited thermal signature. That's another way of saying I'm not wasting a lot of energy, and that's a good thing. Hey, this is a good timing on slides. I forget this was here. External resiliency. Again, back to the do's and don'ts. The there are many different types of materials, especially after Sandy. A lot of people, actually, ironically, after Sandy, a lot of people switched to gas as their backup system. But today and going forward, energy codes and a design and desire for protection, people are spending a lot of money to certify what's out on the site. Micro turbines, which is actually a little kind of a jet engine inside your furnace on the inside of your house. It's kind of cool. Geothermal, this is where you dig down to the ground and get some heat from that. Solar panels, of course, and all these factors are at play when you're dealing with survivability of a place. Hey, I just noticed it's 3:52. Let's take a break till 4:02, and I'm going to kind of rest my throat for a second. And then after 4:02, we've already gone through most of this. I'm going to do a quick pass, and then we're going to go through the interior section from last week, because I'd like to spend about an hour going through that, so you guys are all prepped for that, to see what you've forgotten or maybe I missed, and so you're all ready for your test. Okay, so I am toast for 8 minutes. Bye-bye. Okay, I guess we got to get started again, right? So let's get cranking. I'm actually adding a few slides as we go along. Always kind of, this is just a work in progress as I try to better explain. And one of the things I do in all the different things as I'm working for clients and advising on properties, I just kind of grab stupid images and throw them in my library and then go through them. So I was going to go back to interiors, but first I decided let's take a little browse to the library. This is, of course, what is this? This you come across this in your inspection. That's a meter, and well, the meter, somebody tapped off the meter. What the hell is this? Somebody actually went behind the backside of the meter, attached a wire, so we could get free electricity. Now that's it's a very good way to die, and B, it's a very good way. Obviously the utility company's not going to be real happy about it, but until the company's there, we got some free electricity. What's the good news here? The good news is he's got a bit mining rig on the inside, and he's not paying any electricity costs. No, just kidding. Oops, let's let Ryan in, one more person in. So as we get going again, we think about the images, the challenge of crazy things that we're going to come across. The meters as an example. This one, bad stuff in the attic. These pictures are kind of random, but they're actually a great browsing directory for you to get a feel for things you might come across in an inspection. And I do them randomly because for that very fact, you're going to be, in your inspection, you're just going to be seeing stuff you don't expect right out of the blue. And so you just want to keep your eyes open. So, different types of systems. Power walls usually are in the garage, but that's going to be, again, battery power is going to be a norm for houses in the future. I have had some very rich clients over the years that have spent an immense amount of money on backup systems. Batteries are about 20 times more expensive than generators, but these clients really didn't care. And of course, with the current movements to be off the grid, et cetera, both for environmental or political reasons, people are actually doing this more and more. And you obviously want to be off the grid in much of upstate New York simply because the grid is it costs too much money to get power to you. I was in a case where a guy was going to spend, he would have had to spend $45,000 for poles to attach his house about 1.5 miles to the primary power lines. And of course he'd have to pay bills as well later. So he spent about $10,000 and put a pretty sophisticated solar panel system up. And then he spent another $10,000 and put a pretty good wall of batteries that are designed for solar panels. And then another $5,000 to buy a backup generator and 500 gallons of fuel. And so now he lives completely off the grid. All he needs to attach himself is the downside of not paying for those poles to get to his house is it's kind of hard to put internet fiber to his house. So he's now solved that as well. If you don't know, there's a thing called Starlink by Tesla. And that Starlink system is a pretty good off-the-grid internet. So there you go. Your problem solved. Electricity done. Phone service, that might be a little bit of a problem. And then internet done. Of course, if you have internet, you've got phone service. Okay, why does it matter? Again, the whole paradigm of what electronics is needed in a house, whether they be copper wire for phones, 10 years later, done. You don't need them anymore. Today, obviously outlets are the 120 volt standard like we see here, but these are some of the examples of all the different types of switches and stuff. But I am seeing, in stores, and I'm seeing people that are now looking at, because devices are using so much less electricity, they are looking at USB standards. USB 3, as an example, is 5 volts, not very much, but something like 3 amps and as much as 9 amps, which means you're transmitting 15 to 25 to 45 watts. And suddenly you could actually, in theory, wire your house with USB and power your house entirely on USB, or devices in your house on USB. Again, sounds crazy, but these are the types of things coming up. The new, I think the new Apples, if anybody has one, new Apple laptops, I believe, are powered by USB-C. And again, we are looking at the next 10 years, we're going to see a lot of change in electrical service as the law requires us to be much more energy efficient. So new houses are going to be much more energy efficient. And um, again, older houses, they're gonna be forced in some cases to upgrade, not by law as much as by economics. If I can run my house um, on the solar panel on my roof 90% of the time, then I might want to spend 10,000 rewiring my house. And again, these are some of the things you're going to be seeing more and more of as you do building inspections around. Reminder, of course, of the armored cable, the BX cable, used in house wiring, also used in commercial. The challenge is it's got to be done right. Something as simple as cutting. There's a tool that you got to use to cut it properly. Again, some more images of it. How do you cut it where you don't, where you don't cut the wires inside? And the answer is there's a tool for that. Again, attic wiring coming into a building, but also there's a hole there. Ooh, that's a water issue, and that's an animal issue. You just need an animal up there to start chewing away. More wires. Again, the armored BX cable, SE cable for service entrance, NM non-metallic Romex cable, or a service lateral or an underground feeder. Carbon monoxide detectors, a lot of technology coming out there, as I mentioned today. And as I also mentioned in a previous class, a former New York City building commissioner recently passed away at his home because of carbon monoxide poisoning. Too small. Again, we think about carbon monoxide in terms of the vent being blocked and the risk of that. I've seen pictures of 5 and 6 foot tall snow drifts in upstate New York in the last week. I've got pictures from my mom's, where she grew up in northern Maine, where they actually had to shovel a tunnel from the front door to the road about 100 yards away, because in fact they had 15 feet of snow on the ground. And I know that sounds crazy, but in fact, snow loads like that are, they can have an effect on all the ductwork. And you've got to think about what would happen if the ducts on this building were broken. I use that ridge vent again as an example. You see snow-covered roofs all the time, but a ridge vent design, while it may work in Arizona really well, it may not work here. Junction boxes, again, this is the vibration caused by a fan, literally kind of rips it out of the ceiling. Not only that, but it's it's damaged in so many times that the threads are stripped, and you're toast. Just replace you got to replace the whole junction. Fire, up in the attic, a fan damage. I didn't show you this picture. This is a an image of, again, that used to be a fan, but in your report, I mean, look, the box is just hanging there. What happened? Well, the guy probably said, it's going to cost me about $2,000 to bring some guys in, set up some scaffolding, reinstall this, tear up the plaster, redo the plaster or drywall, and I got to do all that just to put a new ceiling fan. Maybe I'm not going to bother. If you look really closely, you see what looks like char marks. So this happened, and he took it down and took it offline because chances are the previous fan caught on fire. Again, this is a reminder of how, as you're inspecting a house, people don't really care. They're like, okay, yeah, I haven't used that fan in 10 years. Yeah, but the new buyer does care, and that new buyer does not want to have to pay $2,000 or $3,000 to get this thing fixed. Now, the good news is the ceiling looks pretty good from a drainage perspective. I'm not seeing any water damage coming through. That's good. But in fact, it may be water damage that caused this thing to break in the first place. So again, that's the sleuthing that you have to do when you're doing building inspection. Again, what's wrong with here? Well, it doesn't seem like much, but 2 lights are there. One's broken. You don't just, go to the store and pick one of these up. So relatively minor, but you may have to replace the whole fixture here. More fancy chandeliers. wires just kind of draping off of it. It's like, come on, guys, clean up your mess. Too small, too small. Hold on, let me see if I can do this better. Oh, no. Okay, moving on. Typical devices. Okay, let's take another tour of our friend, the panel box. What do we see? We see, well, we don't see them here, but 1, 2, 3, 4, 5, 6 screws. They're always flatheads. They're always on the inside. They're flat tips because we want to make sure the screw, if it hits a wire on the inside, it's not going to do any damage. So typical panel. What is this? Is this a GE? I don't remember the manufacturer here, but the key thing is the power is probably coming in the top because the main breaker is up here. And that main breaker, if it says, let's say 100 amps, which is probably what this is, that 100 amps is going to be then divided among this hundreds of amps of service. But all of them combined can't use more than 100 amps at a time. Now, things you want to look at here. You want to take a picture of, one thing nice here is they have a nice chart. This chart right here is of what each circuit does. And that's nicely done. Usually it's chicken scratch written on the side of the metal panel. But you do want, wherever you can, you want to find that chart of what the circuits are going to. And you look at a double circuit here, that's probably like a dryer. And then lots of individual circuits, those are probably branch circuits. And of course, we don't like aluminum in our branch circuits. There's a tester. Again, buy a good tester. You're going to use it thousands of times. One upside of this one, again, is that it pushes.
Question.
Yeah.
Excuse me, Brian.
Yeah.
Back to the circuit breaker. We're not popping the breakers, right? We're not popping the switches.
Absolutely not.
Each load.
Yeah.
Okay, just clear.
If you're there and you see some that are tripped, again, this ain't your house. Okay. I want to use this gently. The GSCIs and FCIs you want to touch as you go around the perimeter of the house, unless you're concerned that it might cause a problem. The panels, if the owner is there, and I really don't see a reason to touch the panels unless they're half tripped. And then I would ask the owner to untrip it, not me. Because again, what's the motto? You break it, you bought it. So the answer is no, you're not going to be flipping the breakers. You are, one more time, you are observing. If you're lucky, you can take the panel off and look, as we've seen before, at the wiring. Again, quality of wiring is a good indicator, as well as, I just realized my video's on. Hold on. Not that that matters, but you guys can hear me okay. There we go. Hi again. Again, they say in some of the things that you should pull out the master and check the sizes for fuses, but you really don't have to do that. Whatever the label says on the outside of the fuse is what it's going to be, because you can't put a larger fuse in one of the fuse boxes. However, I have seen linear fuses that were much, much bigger than they should be. And as I said, I saw them when I saw a 2 and a 4 and a 5 alarm fire in the same building. And that was because they put a fuse that was like, I think it was a 400 amp fuse in 150 amp service. Imagine 150 amps for 77 families. You can imagine that breaker is going to go a lot. And unfortunately, the lines in the walls got so hot because there wasn't any proper breakers that the building caught fire multiple times. Okay, again, what it looks like. Behind the walls, we see the carbon monoxide detector. We all know those. This is a quick reminder of the service lateral. This is the line coming underground. I think it only has to be 18 inches underground. You don't worry about frost line for an electric line. But as you do come up, you do have to worry about the building and moving. So you do want to have a little flexibility and a kind of an adjustable slider here so that this whole building could, in theory, move up and down a couple inches. More drops, chandeliers. Again, a lot of these light fixtures weren't in the presentation. Anything wrong with this? No, nothing wrong with it. It's again, a perfectly fine, actually kind of a challenge for an inspection. The answer is you're not really going to inspect it. You're going to make sure the light switch works. The quality, whether the guy likes it or not, that's up to them. And I would take a picture of it because the owner may take this when they sell the house. And also, these things can be damaged a lot. Something like this might get vandalized in between. Unfortunately, I work on a mentality of a building, if left vacant, will be destroyed within a day. Kind of the unfortunate mentality of some construction areas. Again, bad wiring. I don't ever want to see extension cords. I definitely don't want to see extension cords that are going through windows because clearly that window is going to destroy the cord and possibly start a fire. Bad outlet or bad 230 volt, 20 amp, I believe, connector. And a connector like this might be for a refrigerator. I think that's 40 amps. But again, real problem here is there's corrosion. Bad lights. I like to start with beautiful wiring. I think this one's quite elegant. A reminder of how to do it right. You hope every house you inspect is this good. You won't be so lucky. But you do want to think about this big question one more time. This is what you inspect on the left. On the left is the high voltage wire. The right is the data, telecom, security wire. That is not in your home inspection. You might put a note and snap a picture saying, extensive data network observed, not part of the inspection. Unable to certify the fiber or whatever materials are here. Coax fiber, RJ45, Cat6, Cat7, etc. Different types of fuses again. The primary fuses for a house are the ferrule, the slot ones with metal on either end. You probably recognize the fuses from your car. Ironically, I've actually seen car fuses in houses before. Really surprised. I was quite shocked. And actually, the guy told me, he said it was really great because it was so reliable. Because he actually liked fuses. But again, it's not usually allowed for building purposes. Clients aren't leaving me alone on a Saturday, guys. Again, another type of fuse for much larger devices is called a knife blade. And the knife blade is because when you pull down on the knife blade controller, it pulls the blade out of the connection and opens the circuit opens the circuit and prevents and shuts the machine down or the house down. Again, we should have some more pictures of that on the way. More outlets. Didn't talk about this, but a reminder of things like the dishwasher connect. You want to think about a dishwasher being both a water and a electrical connection and the importance of making it safe. Very bad outlets. What's wrong here? Anybody see it? This guy took a good picture. I want to give them credit. What's wrong here is obviously the dust. We don't care about that. What we do care about is one, Federal Pacific, the red tab breakers, and two, there we go. We got a bunch of things wrong here, right? We got aluminum. No, I'm sorry. I thought it was aluminum wire, but it actually looks like copper on the inside. But worse, most importantly, is we have a double tap on this 15, and that double tap's a problem. So nice picture to that broker. A reminder of the different types of screws, often referred to as an Edison. Again, what happens is a little piece of metal on the inside gets to a certain heat. The heat's caused by a pretty specific voltage or amperage has come through, gets more than 15 amps. The metal gets to over 550 degrees. And metal alloys, you know exactly when they're going to melt. So, boom, gone. The breaker's toast, or the fuse is toast. One of the key elements to fuses is understanding that they have very specific screws that you can only fit the proper size in. And kind of a pain in the ass to get them out. Service entry, we talked about more electrical outlets. What do I want to see here? annoyed, guys, because my screen doesn't zoom in very well. Think about all the different things that have circuits. They might have positive circuits. Obviously, you got the bad circuits for the lights and the switches and the OLEDs, but you also have specific circuits for, let's say, the refrigerator or the hot water heater, which, if it's gas, it may not have very much circuit, but it still gets its own breaker just for safety. That might have a special construction area or a garage. It may have GFCI and other protections, but it also may have 20 and 30 amp circuits for heavy machinery. On the outside of the house, when you're dealing with electricity, again, GFCI and protection from snow and ice. There's our standard tester. What does it do? It makes sure that hot, neutral, and ground are where they should be. Again, we talk about in the kitchen, GFCI. I don't want to see any outlets on the GFCI on the countertop that are not GFCI. If it's an old house in the 60s and they don't have GFCI, put in your report that you suggest adding it. That's how important it is. Okay. Remember, water plus electricity equals toast. And that's what we're trying to avoid. Top part of a meter, of a panel, inside the panel. Hopefully you have the ability to unscrew the six. Oh, and by the way, remind you, while some states like Texas will require you to get into this panel, as far as I know, New York State does not. However, it is good practice. And as I said, your competition is doing it. So learn to take the panel covers off safely. Learn with proper protective equipment and gear on. Learn how to visually inspect the panel. You don't have to operate the breakers, but you do want to look for corrosion. You want to look for unnecessary dust. You want to look for that animal trap, gross as that is. Other types of things. You guys think electric cars are new? What if I told you the buses in New York City were using electric? The buses in New York City were electric. Ready for this? In 1904. This is actually an advertisement I love from a trade journal. This is the Edison Electric Company. They actually produced batteries for delivery trucks. This was a beer delivery truck in Brooklyn in 1913. The beer delivery truck in Brooklyn in 1913 used electric batteries. Just a little reminder, Tesla and all the super green stuff, you learn from the past. As you might come across some of this equipment along the way as you do your inspections. Again, I can't stress enough. The things that we consider new today, maybe they're not. And conversely, the things that were considered high tech years ago are, considered normal today. As I emphasize Steve Jobs one more time, the goal is to create magic. And magic is that which doesn't seem to be a problem. What's wrong with this picture? This is a great one. I don't have this in the presentation. The water is coming down off the roof and it's dropping right onto the meters. That just says mess. That ain't good. I don't like that one. Which is why I got to put it in the presentation. Again, tangled wires, more extension cords. If you see extension cords, bam, being effectively used as permanent wiring. Say extension cords being used as permanent wiring, not acceptable, repair or replace. Outdoor lights. This is a cheap tap. I call this the can opener tap. Again, yeah, it works, but yeah, should have a junction box, should have proper connections, and probably shouldn't exist at all, but should perhaps be a second circuit. Again, that's the kind of stuff you're up in the attic, you think nobody will ever notice. But the home inspector is going to see this stuff. Again, as I said, when a house is first built, it's perfect. But 50, 60 years later, not so much. This is a dryer reminder of both electrical dryers and gas dryers, the danger of lint. The lint, it seems so basic, but in fact, and obviously this is an appliance, so you're not too concerned about it, but it can really be a fire hazard. And the lint can not only be here, but it can be up in the attic. And I actually had to deal with a dryer fire in 2007 in Brooklyn. And we had to vacate 25 people from a house. They were living in what's called an SRO house, and somebody didn't clean the dryer lint. And when I went there, I ruined a really nice pair of shoes because I had to walk through 2 foot deep water with the fire department to find out where the fire had occurred. And as much as we thought it might be an arson because there was an arson wave in the area, in fact, it was just a dryer that had gone bad. This isn't it, but I can't show you my pictures. Again, reminder of circuitry. Look for, and why is this on fire? The heater. The heater, and sadly, this is a pretty common thing right now, right? It's January, February. The heater is using so much electricity, it's pushing the wire, the circuit, the 15 amp circuit, but it's so hot on the inside that maybe the breaker didn't work properly and the circuit caught on fire. And this image is very important to think about from electricity. The whole purpose of the breaker is to make sure the lines on the inside of the wall don't get too hot. And it's unfortunate and quite painful to people. And the National Electric Code tries to prevent that. Again, reminders, this is a guy who's gonna put a can light in. And in this case, it's not up to the roof, but it definitely will have some issues. Outside, this is just bad design, right? Oh, let's add some floodlights. But dude, at least don't use the orange cable. Look, I think it's an extension cord. Again, the Federal Pacific panels. The risk of these panels is, again, they're recalled, and you want to put that in your report if you see them. The problem is the rust. And that rust, eventually, not only the rust here, but the rust happened they saved a few pennies when they made each breaker, and the rust happened in the breakers. So if the breaker's rusted, the rust is going to keep the breaker from tripping. And that's where the fire happens. So don't save pennies. I think they lost $1 billion in lawsuits. Okay, dumb. More breakers or more fuses. Much older wiring. I don't think I showed you this one. This is a really old system. I don't remember. I mean, it was New York. It was a very custom system. As you can see, a double prong here. I think these are like 240 volts too, as you can see by the thickness of the wires. Again, use your architectural knowledge and say, wow, that's a really old 1940s looking case. So something very interesting going on here. And again, this connection is manufacturer specific, not standard. And I think it was a special GE attachment for industrial devices. And sometimes they want that. They want a device. They want an outlet that can't be used except for your own plugs. Again, reminder on fuses and breakers, problems, timeframes, and challenges. Yes, it costs money for the newer breakers, but yes, they're going to save your life. What's going on here? Look, this guy, the service coming in, and it's just somebody like ripped the top part out. It's just destroyed. So, I guess they made $10 on stealing the breaker. Again, 3 different types of fuses, kind of bad wiring. Breaker boxes typically, again, problem here outside. Very large device. The heat pump, 50, 60 amps, right next to a gas meter. I don't like that. Generators, again, an open box. What's wrong with this open box? Well, it's under construction fairly, so it's not, I don't want to get it in too much trouble. The panel's not on yet. But I'm not trying to show you quality or anything. What I'm trying to show you is that connection. This is a pretty big service. I think this is a 200 amp service. And you can see that by A, the number of breakers, and B, look how huge these lines are. And that's actually a sub panel, because up here, I mean, look at this monster. This huge cables going into this panel. This is that looks like an aught or a 0, which is about 150, 200 amps. And then even from that panel, you're going over the sub panel, which is probably number 2s or 4s, and that is again probably 100 amp service for the sub panel. GFCI, remember, might be an individual circuit for a branch circuits in a house, or it might GFCI might be for a larger breaker. Let's say a washing or dishwasher or a washing machine or dishwasher, either one. Again, large electric device near water. Would you want one for your refrigerator? No. Why? The reason why is the refrigerator, really, you don't want it to you don't want that breaker to trip and not know about it. Because then you go a day later and you find out that all your food is frozen. So the refrigerator, because that outlet is kind of the way to think about it. The refrigerator doesn't need a GFCI, even though it's near water. And the reason why most of the time is the outlet is behind the refrigerator and thus protected. It's also a pretty big, 30 or 40 amp circuit sometimes. Again, so that's an example where you only require GFCI in areas that are accessible. Hard to reach places you don't need a GFCI, even though you're near water. More GFCI testers. Buy a tester guy. Everybody, they're like $7 to $10. Again, one more time. What you want to see is the electricity traveling from the hot to the neutral. Okay, and the ground is dead. That's what makes you happy. Worst case is, and you see the red lights, this is where the ground has voltage going through it. That is a no-no. That's what you don't want. So again, spend some time buying one of these devices and playing with it a little bit. Again, you definitely want that in your tool bag. Very few things you must have. This is a must-have. And buy the kind that does GFCI as well. You'll be happy. Again, this is outlets on the floor. Why is that a problem? You see GFCI there? Nope. Kid comes in with muddy boots, bzzz, gets fried. That's not good. Conduit, more conduit. Grounding outside. Grounding, where is this? This is in a panel. Inside the panel, this is the heavy neutral connection to the grounding bar. The grounding bar is to make sure that the box itself doesn't become charged. In fact, anytime you touch one of these boxes, one of the things you should do is always, we talked about the hand movements a little while ago. Another thing you want to do is never touch a, like this. The reason is when you are being electrocuted, when electricity is going through your body, what is it doing? Running down to get your feet to get to the ground. But what's really bad is when you're electrocuted, your hand closes, clenches. And if your hand is holding something, it's going to clench really hard to hold it, which means you can't break yourself away. There's a great video on YouTube of a young Indian man who literally he's working with his being electrocuted. He's touched something, he's being electrocuted. The guy takes his sweater and pulls him as hard as he can and pulls him away from the electrocution. It saves his life. And it's very noble of the guy, but it's also very instructive of the fact that if you don't have proper grounding, you can really have risk. And inside this panel box with its knockouts, again, why don't you want open knockouts? Because the open knockouts can be like bugs and animals and stuff coming inside. And also, it's just good practice. Here's our antennas. Again, ground, and more grounding. Why is this not right? The ground line should be driven all the way into the ground. Again, that's a nice ground line here with a big copper stripe. Little reminder on the inside. There's an inside heater. Electric heaters, more popular today. I kind of don't like them too much. Roofs healing. We talked about the importance of overhead wires, not only for the heat of the overhead wires and getting tangled in trees, but also for electromagnetic field. Many types of electronic devices you're going to deal with in a house, wireless, all kinds of stuff these days. Again, you're only responsible for the heavy duty electric. Other than the carbon monoxide, you are not certifying all the other work unless you want to get charged more. Can you, analyze their circuits and make sure their electrical RJ45s are okay? Sure. I charge a couple $100 extra for that because that's a lot of manpower. Again, service grounds, more pictures. This is a good diagram of a typical house in a rather unique way. Again, circuit comes in, hits the meter, goes to the panel, and from the panel, it goes out to all the devices. A bunch of the devices in gray actually get their own circuits. Why? Because they're important. I would add the central air would also get its own circuit, and probably the oil burner. Again, the importance of having the ability to keep yourself from losing your equipment on the way. Stupid, but fun. Old panel, but okay. Again, what are you going to do? You're going to take a picture of the overall, if you're able to take this, sometimes this panel cover is off. Sometimes, you know, if it's sitting like this, hey, it's easy. You just snap some pictures. You look for aluminum wires. You look for double taps. You look for the plaque to say what the typical service size is. You identify there's 2 lines coming in, so that's 120 volt service. But this is interesting. It looks like a neutral's going out over to here. Maybe I'd look again. This might be a 240 volt service. Again, because of that hot line going over that. Although that may be, no, that's probably 240. Let's move on. Again, junction boxes cover them. Junction stupid. Kitchens. What do we care? We care about 3 things. Water, right? A lot of big high voltage items. Got to protect them. To do that, you also have to provide access that everybody wants in their fancy, expensive kitchen. This is what sells a house. So the brokers will tell you, man, the kitchen's got to be perfect. Well, again, something as simple as making sure there's outlets every 4 feet, not near the water, but also on the outsides as well. Lots of different places. Knob and tube, knob and tube, knob and tube. Knob and tube converting to Romex in a sloppy way that is in spray insulation. It's not good. Again, knob and tube illegally being converted to Romex. Sounds like a common theme. Again, at least it's got a cap on it, but it should have, at the very least, a full junction box. Knob and tube. I love my knob and tube because it's actually very common here. This is a pretty big device, and as you can see, you just kind of wrote the circuits on the house. Now, what I don't like about this is these are a lot of double circuits. He is giving 30 amps to almost all his devices, and I got to tell you, that scares the hell out of me. With that, I mean, I would hope these are split devices, but they're not. They're really single pulls. So he's got 30 amps going to his lights. I'm not happy about that. But he does, you know, he's smart. He's got, for instance, he's got a hardwired smoke detector. So added later, they punch it out, and you know, this is a punch out. So he punched out 1 box here, added a small 15 amp breaker just for that 0.001 amp smoke detector, because it's required to be what's called hardwired. Again, hardwiring is solved with smoke detectors because of those 10-year batteries. So a dryer, electric dryer, right? Double pull. And as you look closely, these are all 20s, you know, individual 20s. Again, I don't like using that much voltage on the wiring, but if you upgrade the wiring on the inside, you're good. What do I care about here? I'm going to take a picture of the Cutler hammer, which is the type of panel box. Lighting, more roof lighting we talked about recently. Bad wiring, hole and safety problem. Dumb wiring. This is a quick reminder of what's actually in a switch on the inside. This is the mechanical parts as they flip back and forth. That's the way a switch works. Again, they've been doing this for 100 years. They're pretty reliable, but they can break. If they do break, replace it. I think you can buy these for $5. Roof insulation. Bad wiring, really, really dumb and incredibly stupid fan location. Again, this is stuff you're going to see. I love the pie pan. You got to love that. Again, is that creative? Yeah. I mean, the guy's got an outlet. He had a light there, and he said, you know, the light on the side's no good. Why don't I drop it down? Hey, I need a reflector. Oh, great. I just had a pie. Okay. Is that acceptable? No. And even worse, not only that, but again.
Was that in the United States?
What's that? This was not in the slides. This
Was
is
that in the United States?
Yeah, this is just somebody stupid.
No, in the United
Yes.
That was just something in this country?
Yeah.
Oh,
Happens all the time. Hey, believe me, America does not have the monopoly on stupidity. Well, actually, we do have quite a. We are well justified in it. We're not immune to it. And in fact, most of these pictures are, America just stupidity. Again, what it is, it's actually perfectly safe. The wire's there. It's, the guy put electrical tape on the wires, and it, runs 100 watts, and it's safe. But it's not going to pass inspection. And actually, I got to give the guy credit. He's pretty smart. Actually, a pipe pan works pretty good. So more power to him. Then, of course, a little reminder on electricity. Again, the guy who took this home inspector took a picture of this. If I saw this, I'd just walk out of the house. I just I'm not going even in this house. It's a fire truck. That's just wires everywhere. Again, I like to show you good stuff. This is a really nice wiring diagram, but this isn't actually, you actually don't care about this. Why? Because this is actually a data center. This is not NOT. This is not something you care about because this is low voltage data cables. None of your concern. And believe me, there are houses that do this. You'll come across a house. I say this jokingly because I was going to rig about 4 years ago. I kind of wish I had. When Bitcoin was 7,000, I was going to build a Bitcoin farm with my son and hook up about 30 machines. I guess too bad I didn't. I'd be a millionaire now. Again, wiring again. What's this? This is the master switch for the whole house. Square D is a good electric company. You pull that arm down, and you have knocked out power to the entire house. Many places require this today. Sometimes it's actually required to be on the outside of the house. In New York City, I think it's 1 to 4 family can be indoor. After that, you got to be outdoor, or vice versa. I think I got to double check my codes. More electrical devices. Now, we kind of looked at this earlier, but this is again kind of a reminder of the history of electricity. When this house was built, they added a small 60 amp service. They put a small electric meter, manual meter in the 1920s when they retrofitted the building. And then, later on, it's a modern time. So all of a sudden, 60 amp, you need 200 amps. So he puts a brand new big meter in. And but he's kind of stupid and sloppy, and he doesn't think the old although I'm sure it's disconnected and powered down, it looks looks bad. Again, reminder, why do you care? Are you gonna, and this is true with all electric panels, everything, anything related to electric at all, at any place. If it's wet in front of this panel, don't go near it. I'm not inspecting outside electrical today. Snow is creating puddles. Puddles, if you're stepping in them, they're gonna, give you a hot foot. And again, this is the master supply for the whole house, so you'll be kind of dead. And I'd like to pass on that. Again, a box that's fallen off the wall. We didn't say this one, but this box is kind of dangerous because it's kind of a little too close to the window. Again, think about snow here. I'm not comfortable with this. In fact, as you can tell, it's already happening. This box is already rusted. So that shows you how much it is starting to have corrosion issues. Again, who takes out the meter box? The utility and nobody else. Because behind that meter is the full maximum house service, and you don't touch that because that's big stuff. Again, if you're a licensed electrician, you can talk to me about it. Other than that, don't touch the electricity. More meter shots, again, where the grounding are coming in. What is it doing? It's actually coming in for the house, but it's jumping and not touching the meter. You got the hot and cold, hot and neutral coming in, being metered, and then going past. But the neutral and the ground are actually bypassing because if they went through the meter, they would destroy the meter. Again, the meter on the outside, more meters on the outside. Little gross. Hold on for a second. Looking outside. Weekly Antifa protests. They don't realize that they're being paid for by the billionaires that created one of them. Anyway, we don't do politics. So continuing, the house meters again, or the panel box. This is the panel box with a nest in it, or a snake in it, or a very, very dead mouse in it. You never know what you'll find. Again, reminder of why you have to be careful. You never know what's on the other side of that wall. Again, you're not taking a panel off to look behind it, but you can sometimes see the damage. Again, home inspection is to observe and report. You are looking for clues from your experience of potential problems. And if you see the clues like chewed on wires, then you want to put that in your report. Quick reminder of the different types of plugs. This and many more. Little configuration issues. Again, straight in, twist, and why are the sizes different? To make sure you never, never, never plug it in the wrong way. Pretty simple, and it works. Another panel. This guy is in the process of installing a panel, which is quite nice. Just show you this for a second. Again, he is. How many families is this? It's 3 families. Why? Because you got the center box. All it does is gives you space to connect the 3 wires. In this case, hot. These aren't for families. These are the service, hot, and neutral. And they are attaching to a bus along the back side here. And then those buses then go down to the master switch, the cutoff switch for each one of the units. And then from there, the power is going to go inside the house to each apartment. So in this case, you've got probably the public area and then 3 apartments. And again, so keep an eye out. Obviously, you're not going to take this apart, but I just want to show you what it looks like on the inside. Then I got to zoom back out and go to the next one. Electric codes. Quick reminder, 4 units: voltage, pressure, amperage, current. That's the actual amount of electricity. Ohms, resistance. Resistance is bad. Resistance is futile. Actually, resistance, unless you come up with superconductors, resistance is inevitable, and that resistance becomes heat or light, and that heat or light makes your system less efficient. And as you lose power, as you lose more, if you have more resistance, you have less power, and therefore you got to pump more electricity in, etc. One more time. Voltage is volts, which is, again, the power. Technically, it's called electromotive force. Voltage. Amperage, when hit in a line, it gets resistance, which the goal, of course, is to create as much power as you want. Quick quiz. Anybody know where that is? If you have really sharp eyes, an architect, you can tell me where this is. But generally, I'm showing you because this is a once very fancy light fixture. Hint, it was actually designed by Tiffany and Company. And it is sitting down in New York City. And as you can see, there's one outlet broken. So, of course, it has to be repaired or replaced. The line here gives you hints. Anybody know? That is a very famous lighting for the City Hall train station. There's actually a train station under City Hall that's not used anymore. And it has windows and glass by Tiffany, and very fancy, but too small. Again, we talked about this in the attic. We talk about roof from electrical perspective. This is quite interesting because we have a fan, and that fan's it's huge, huge blades, very, very heavy wood blades. It's going to have a lot of rotational moment. That's a fancy way of saying it's going to shake. So in this case, massive steel back brackets to a big, big wooden platform that spreads the vibration around. And then, of course, a knob and tube electrical connection. So this might be a 100-year-old tube, a 100-year-old fan, but it's really cool. Again, what kind of material is this? This is, of course, fuses, and again, a property somewhat under repair. You can see the newer electricity here, the older stuff here. This is, the nature of what you're going to come across. 1920s base, 1990s new. The electrician never put it back in place. It looks like spaghetti. It's not safe. And so your report would say, suggest having an electrician come in and review. speaking of reports, as I said, on the Dropbox, lots of sample reports. On the Nachi website, lots of sample reports. Google, home inspection report, New York State, lots of reports. There's lots of sample reports out there. Look how other people are doing them. And then go to the software, go to HomeGauge, go to Home Inspector Pro, look at all the different software that's out there, play with it, and see how it is going to make your life easy by writing these reports for you in the field.
Question.
Yeah.
Okay, I've seen a lot of the reports. Thank you for them.
Good.
But which is the report? Which is the report that you do?
Good question. Mine, I can't show you. I don't do home inspection reports. I do building. The most recent report I gave was for the purpose of a federal bankruptcy court. So it was an analysis of a building to show the condition and show how clients had damaged the building. My other recent reports, again, because I have confidentiality agreements with my clients, I can't show you. A 500,000 square foot mall in Staten Island I reviewed, and it found a lot of problems. But I don't care about the caveats and restrictions. I as an architect, I'm expected to know a lot more, and I'm also expected to be held to a higher standard and a higher liability. So because of that, I usually start with a blank slate. I do have an outline I use, which is obviously similar to what we're doing here, but the outline depends on the project. Like this, home inspection probably isn't going to have a section on sprinklers, or emergency lighting coverage, or emergency generators. These are types of things you'll see in larger buildings. So the answer is no, you can't see my stuff. Sorry.
Got it.
Confidentiality agreements may not be very nice. I mean, this is one of the reasons why I've really never handed out these PowerPoints before. The PowerPoints, although they're more or less an outline of the book, they do have some other stuff in there that I won't tell you which ones, but there's some confidential stuff in there that I shouldn't release. And I don't think I have any building department stuff, but if I release the building stuff from when I was commissioner of the building department, I could be potentially in big trouble. So again, the liability isn't for teaching you how to do it. The liability is for releasing information that someday might be used in a court of law. And again, when I'm called in as an architect, chances are somebody's already getting sued. So I'm being an arbiter, and we're operating as a friend of the court or a contestant to the court, and therefore I have some pretty big restrictions. Okay, moving on. Old outlets. This one was funny. If you come across this, what do you think what it would be? This is actually in a house. Again, you're going to see all kinds of crazy electronic devices. You got to kind of sort them out. In this case, this was actually the start stop was actually a lift for a guy who had a 5-ton car lift in his garage. And this was the security system for it. But again, you're going to come across all kinds of crazy things in a house. There's that electricity, again, to make sure that the ceramic is adequately distant from the panel. Quick look on the inside. Global connections. My most recent trip to Italy, we bought one adapter. We brought one universal adapter. And again, because everything was USB for our laptops, we didn't need much power. And, you don't need a blow dryer. So, especially because when I was in Rome, it literally rained every day for like 8 days. The only day it didn't rain was when I went to Milan. Continuing, yes, this was before COVID. Again, reminder, this guy's lame wiring. The guy punched a hole through the wall. Come on, guys, that's stupid. Again, this is the kind of sloppy stuff that you may not notice. You got to keep a sharp eye out for. The funny part is, if you look carefully, he tried 3 times to get the hole right. And the 3rd time he finally got through. He probably hit a stud here as he was trying to drill through. So the guy wasn't even smart enough to use a stud sensor. Again, open panels, fire. Fire is a pretty good clue something's wrong, right? Now, the screwdriver's a little too close, but these plastic pin voltage detectors, definitely got to get one, guys. Again, $5 at Home Depot. Take a look at the electrical sensors slot in Home Depot, the devices. This pen detector you definitely should have. It's funny, if you guys, too bad you're not in the classroom, because I used to give these out to all my classes. So I think I got them for like $1 a piece. So I gave them out. But the again, a multimeter will cost you $100. Fire damage, more damage. Stupid outlets, more damage. And guys, we're going through this, and I just realized I got to spend some time reviewing the interiors. So I'm going to stop on this photo review. I hope you've learned a little about panel. Anybody feel like they can open a panel like this today? Hot, neutral, hot. You know, understanding how the breaker clips in, looking for the right wiring, not touching anything. Hopefully you should get a little confidence, but just this class, I hope nobody tries to do this unless they do some more heavy training. Again, there's a bunch of really good YouTube videos, 20, 30 minutes just on opening up a panel. Again, that's the safety issues. And generally it's not something you want to do. This is something where the classroom was much more valuable. But I do want you to start thinking about the fact that, hey, you actually don't have to go in here. But if you do, you can find some valuable information to the buyer. Okay, let's jump over to the, where's my presentation? Okay, as I said, most of you got this today. I'm going back to the HI2-1 presentation. And this is basically last week's lecture. It is last week's lecture, although I think I added a few things. So let's take a look. Oh, you can't see it yet. So we're going to do the speed clip until, and this will go to what, 9:45 tonight? Just kidding. Let's do this double screen. Click up. Okay, here we go. You can see it again. So again, this is last week's lecture. Here we go. Stupid text comments. Shall I not leave this text comments? Oh, wrong button. Here we go. Okay. Again, this last week, my insulation, interior systems, etc. Me, who cares? The module 2, again, it's going to be interiors, electrical, insulation, ventilation, chimneys, etc. Whatever's in chapter 7 and 9. Why a home inspector? Never forget, health, safety, and welfare. You got to protect people. You got to do the right thing. Again, pay it forward. You do the right thing, people will hire you in the future. Do the wrong thing, people can die. So I know it sounds tacky, but it's very real. So be good, or be good at it, or both. We did class intros, state population. Quick reminder, much of the state is very rural. Okay, we know we'll be inspecting townhouses and urban places. You can't inspect an apartment officially, but you can go in and make a report, but it's not going to count as a home inspection. But the lenders know that. They know that home inspector can't do an apartment in a 30-story building. Again, we talk about the discussion of software. Home Gauge, Home Inspector Pro are a couple of things out there. Xactimate you might hear about from an insurance perspective. Why are we doing this? Again, with the interior inspection, you're doing this quick look around the house. Water damage, material damage, wear and tear, things that are going to cost money to the potential buyer of the house. You're going to summarize it in your report, and hopefully you're looking at those reports, and you're going to give that report, you're going to get your check, and you're going to the next house. Why? Because if you drag a house on for weeks, you're going bankrupt. Okay, you got to be in and out in 2 hours, maximum time, maximum effort for writing your report, 4 hours. That's 3 things: software, software, software. Chapter 7 again was Interiors, doors, walls, locks. This is what you're walking around the house. You're checking doors, locks, ceilings, floors, electric, as we talked about. Plaster in the walls, deflection, ceiling deflection, popping nails, floors, different material damage, place where a dog went for 3 weeks. Yeah, that's gross, but it's real. Insulation, different types of insulations. Is it properly maintained? Is the insulation insulating so well that it's actually causing water damage and mold? Up in the attic, lots of stuff up there. We talked a lot about that today as well. The electrical in the attic, garages, exterior, either detached or attached garage in its implication. We go back, we already did this in structures. We're going to go back to the basement again as well. And then fireplaces and solid fuel burning materials can be pretty important. Again, fireplaces, again, this is an area where technology, like really all of these things, technology is making quantum leaps every year, and you got to be in the game. You know, thermal cameras, for instance, are showing you incredibly valuable information about how the insulation is not cooling a house. In this case, it's hotter here because it's 100 degrees outside, and you know, it's not doing the job. Key terms, again, the goal: a non-invasive review of potential issues for your client, who is usually the buyer. Again, if you can get the current owner to pay for inspection, so much for you. Smart people might arrange an inspection every couple of years. Wouldn't be bad to dial in and say, hey, let me inspect your house every 5 years. Or you're not selling, don't worry, it's good maintenance. Again, and that's particularly good if you are coordinating with a contractor. You know, again, you can't be, you're not giving any price information, but if you find problems, you know, you might be helping to, again, everybody win-win. You're hooking the owners up with the contractors. But again, do that in a way, always think about the conflict of interest there. The 3 primary standards listed in the back of the book. The new book, I actually don't know, is it in the back? Either way, InterNACHI, ASHI, and AHI2. ASHI, I think, was much more popular 10 years ago. InterNACHI seems to be doing a pretty good job today. One of the reasons is they focus on teaching you how to make more money by getting you certification for other things. So this is a couple of quick badges that the InterNACHI guys will offer you if you've taken another 10 course on structure foundation, etc. I would remind you, though, with structure foundation in New York State, you're crossing a line into the world of the engineer. And if you're not licensed as an engineer or as an architect, and you're making comments in structural foundation, you could be putting yourself up to liability. I know I sound so paranoid about liability, but it's real. It's unfortunately real. Again, tools of the trade. What are you going to carry around? You might carry very little. You might carry a lot. Again, tracking your hardware. You know, thinking about going through 100 houses, find a way to track your hardware. Drones, we talked about. Again, legal, illegal. Answer is the larger drones actually require an FAA license. Believe it or not, to launch a exadrone like this, which weighs about 3 pounds, you actually have to notify the airport. You have to have an FAA pilot's license. You have to notify the tower at the local airport that you are flying and that what your flight path is. Am I kidding? No, I'm not. It's actually what's required. And in fact, a baseball team was recently flying a drone, I guess a couple of years ago, and they actually got like a $2,500 fine because they were bragging about their drone shots on the evening news. And somebody from the FAA said, hey, you don't have a license. You're getting a $2,500 fine. Crazy? That's the law. Sometimes law doesn't keep, most of the time, the law doesn't keep up with technology. And again, really, I can't stress enough, construction's a high-tech business. It's one of the largest industries in the world. And when things get better again and you get a chance to go to some of the construction trade shows, they're really sophisticated stuff these days. Whether it be, you know, buildings being built out of concrete by a 3D printer, yes, very real. Actually, that's been happening for 5 years. Or, you know, buildings that are essentially fabricated off-site and then assembled on site. But in the end, the craftsmanship on the site is going to make all the difference in the world that you're going to have a airtight, watertight product. You know, when they build aircraft, all those stuff is prefabricated, but in the end, that installer, leaving a couple,
speaking about the 787 scandal right now, leaving a couple of extra screws in the gas tank. That's not good. Not good at all. Yes, I'm not kidding. You can imagine the impact of a big bolt jamming up the fuel tank of a large jet at 30,000 feet. The point is that this is a high-tech business. You're going to constantly be learning and thinking about what to do. Again, the walk through the interior rooms, you're going to check the stairs for structure. You know, are they stable? Garages, decks, you know, everything as you walk around the building. A lot of this was in the structural chapter, so I'm kind of, again, there is a little bit of overlap. And as you go, hopefully that overlap will serve you as you think about the holistic and unified method of approaching. Again, you should all have this presentation now, so go ahead and read the slides. Again, inspection procedure, be consistent. Do every house almost the same way. Start at the bottom, start at the top, you decide. Okay. Again, when it's disaster related, I start at the bottom. When it's, you know, when it's a beautiful house and I'm only looking for cosmetic issues, I may start at the top. Again, thermals are a big impact. I love showing pictures because they just show so many interesting things. Standardization, how do you walk a room? You know, you walk, this is a type of inspection chart that actually is room-based. So you're doing the basement, you're checking the electrical, the pump, electrical, plumbing, et cetera, all at once by room instead of by system. So these are alternate ways of doing inspection. This one I showed you recently. Again, some software packages will integrate the room by room inspection with the overall inspection and do that cross-index report that, you know, you've walked through 11 rooms and it's going to go through and pull out all the problems in those 11 rooms and put them in a summary, or the electrical problems in 11 rooms, put them in a summary. These are examples of the value of some of the packages out there today. So that, you know, think about a dining room or a kitchen. You know, a kitchen, it reminds you, hey, check the millwork, check the floors, the ceilings, the electrical outlets, you know, all the lights, the trim, etc. You know, does it have a smoke detector? We always joke at the smoke detector in the kitchen, right? Hopefully it's not a hardwired smoke detector. Again, typical types of things per room. Again, you've done it per room, and then from the per room inspection, you're also going to apply this throughout the building. Again, interior doors, inspection habits. Again, we say, we think about how we would walk through each property. There's a bunch of floor plans on this you can look through. Also go through Street Easy and, you know, look at the listings in the brokerage. Look at a $20 million apartment in Manhattan or a $20 million townhouse. This, you know, and see how you might inspect it. This is one on the Upper East Side, 15 million bucks. You know, I don't care. Technically, I'm gonna, you know, be very methodical. Go, in this case, start at the bottom, go around, go around, go around, make my report. Hopefully, I didn't miss anything. Go cross-check everything, then go back to the seller, make sure all the mechanical systems are done, and then hopefully say goodbye, and I'm out the door. I've written my report. I go home, take one more look at it. I send it off to the client. Same thing, think about how you would walk through a property. As we think, we talk about doors and locks. Not very exciting, but it does add up. Actually, the red is as you'll see in the PowerPoint, the red is the review of the entire chapter. So I usually don't review the red part in the class, but it's worth looking at the red part and reading it again. So, you know, it's not visual, so I just let you guys slide on it. Most of these text pieces are put into the presentation. But so in both of these lectures, the red area is, again, the overall outline. Again, the doors. Doors are really interesting. One of the things I forgot about the doors, of course, I didn't talk much about hollow core doors. I showed you all the fancy exterior doors and the old interior doors. But in fact, in most modern construction, hollow core doors, really cheap, really lightweight, but they last long. You know, they're pretty good if you don't smack them up. And the hollow core doors are quite popular. Again, the exterior doors, heavy or solid, sometimes even fire rated. Where might you have a fire rated door? The door between the garage and a attached garage and the house. Again, for fire rated, basically says you have almost a vapor lock between the walls, and you'll be able to withstand a fire for an hour. Unless you're a Tesla, then you're all going to blow up. No, I'm just kidding. Again, if you want an interesting set of videos, Google
YouTube's Tesla spontaneous combustion. They're great cars, but they just happen to sit in garages and mysteriously catch on fire. Again, door sills, we entered the building outside, but then we also look inside. We go to each door, we test the hardware, make sure the hardware is logical, make sure there's no locks that aren't locked. What do you do with a room that's not locked? That's locked. You can't inspect it. Again, garage doors. There's the infamous garage door into the house. This is not per modern code because it does not have a closer. The closer is part of what makes it fireproof. Fire rated, not fireproof, but fire rated. This is not a rated door. Some fumes could get in, and that might be a problem. Garage door openers, again, it's often a place where you have, maybe it's been switched 2 or 3 times, so you get a lot of sloppy electrical work. The doors themselves and mechanisms, as you're testing each door, think about the mechanisms. Do they work? This is a press button lock system. If it doesn't work, it's $200 to replace. Doors, older doors, and how they settle. This is the old wood piece doors versus the more modern hollow core doors. Hollow core doors don't settle; they just fall apart. The older style doors often will settle and break because they're made of many pieces. Door inspection check, make sure they work properly, no leaks, no broken glass. If there's a key, make sure it works. These older styles, make sure they, I know he's got a little paint on it, don't worry about that, but make sure the lock closes properly. And this is a surface mount from the 19th century, and just make sure it works. More locked zooms. There's the doors again, same picture. Again, we check the frames. This is an example of a door that broke because it had too much paint on it. And somebody literally ripped it as it was, pulled, kind of stuck tight because of paint. As a reminder, doors swell in humidity and in temperature. So sometimes the doors can actually stick a lot, and that's a big problem. More settlement and damage and cracks and more damage. Walls and ceilings, here we go. A quick reminder of what's behind the walls and ceilings. The subfloor, typical stud walls in a plumbing chase wall, probably a rated wall. And up top here, if you guys all know these as TJI joists, which are, again, a wood member with plywood in between, and then wood as a truss type design on top. And those TGI joists are interesting. Some people hate them. The fire department in New York absolutely hates them because they can collapse pretty fast in a fire. Sorry. Again, continuing, more images of what behind walls. As you're looking around, if you see a wall that's really distorted, get out a level and check. This is a tool a lot of inspectors carry as a way of testing, particularly with older buildings. I'd plan on bringing a 4-foot level to really kind of document. Now, see, the level serves 2 purposes. Not only does it tell you that it's out of plumb, but the picture with the level is a great image to put in your report to show that it's out of plumb. So this picture right here shows that the wall is bowing out a couple inches. That's pretty important. Actually, I believe this is a ceiling. I think that's actually rotated 90 degrees, and that's a bowing ceiling. And why is the ceiling bowing? It might be the joist, it might be water. Again, wallpaper, speaking of walls again, are you going to pull up the wallpaper like this? Not unless it's loose. The wallpaper, what is it? It's non-permeable. It's waterproof. So the water builds up on the wall on the inside. This is a common place for mold. Plaster versus drywall walls. This is one type of plaster which actually has a wood lath backing. That's from the 19th century. More modern plaster uses a metal lath. That metal lath, as we see right here on the right, is really good because the plaster gets pushed through these metal holes in the lath, and it gets really good connection. And that connection makes metal lath plaster very thin and very strong. And again, a good material. It's almost like reinforced concrete, really, when it's in place. This is the good thing about plaster is how to fix it. It does repair. In this case, the guy kind of broke out the area. In drywall, you would just cut out a square area stud to stud. And similarly here, he's cut it out to put new outlets in. So look for updates and changes. Look for signs the house has been renovated or changed. And those are things that are going to be sometimes potential problems you're going to run into. Did he add the new outlets because there was a fire in the electrical system, or because he wanted to create a server farm? Again, wood panels, like any wood, like similar to wallpaper, it creates a non-permeable wall. Sometimes you have water built up behind. Sometimes you get scratch damage and settlement damage. And generally, paneling is out of fashion today, so a lot of people just kind of don't take care of it or rip it off the wall. In this case, the water had seeped through the impermeable behind the panel and collected on the floor and created a lot of mold. More plaster, more plaster. This is a very sad plaster that's been rotting for 40 or 50 years. And as you can see, the plaster's dissolved away and you're really down to the rotting wood. This is the right way to take it off. He's wearing a mask because this is very often loaded with asbestos. But as you can see, with plaster, there's not much to it. It's only a thin coat, ½ inch to 3/4 of an inch. But it's done in 3 coats of plaster. Again, now there's many exterior versions of this, but typical 3-coat plaster on steel, as we saw, as on the metal lath, as we saw earlier, this is a very good material to work with. Again, nice plaster, very, very sad plaster because it had a really, really bad fire. But the good news is the plaster did create a fire rating, a fire resistance, and that fire resistance got everybody safely out of this building. So I'm very happy about that. As I said, a similar building, very, very similar, almost exactly the same. Just a couple months later, 12 people died in the Bronx. Again, quick reminder of what's under the walls, literally, because the fire department tore off all the plaster, checked for fires. You can see the old, 1920s BX cable, the metal protected cable still there. If you look carefully, there's some steel beams in here too, because this building actually had a steel structure with wood in between. Why did they do that? Why not all steel? Because it costs money. Wood is cheap, easy to work with, and in this case, they were throwing housing apartments up right and left. Usually, when you have the steel, though, you have to have some protection. So that in that area, in this same building where there was wood lath in normal places, when it was near the steel beams or the steel columns, they actually switched to metal lath for fire protection. Impact. Oh, by the way, this is 1920s. The plaster is by law required to have horsehair and asbestos in it. Oh joy. Impact, stupid. Again, panel, stupid. Panel, kitchens. As we quickly talk about kitchens, in this case, we're looking at the panels, but you do want to walk around each kitchen looking at the water, the millwork, and the devices, make sure everything's plugged safely, no damage, no water impact. And it also has enough outlets. Again, I look at buildings from a disaster perspective a lot of the time. This is long-term settlement of water at the fireplace. The fireplace is supposedly structurally independent of the house. And because of that, it often is a place where water can get in. In this case, they pulled off the plaster, found a bunch of rotted wood, had to rip it all out. And I think they ended up actually getting rid of the fireplace on this one, which, by the way, I would never get rid of the fireplace. We talked about rated walls. This is what a rated wall is all about. Fire is in this room for 1 hour and it doesn't go out in the hallway. That is magic, because then people outside have had 1 hour to run past this apartment. The smoke is going out the windows instead of into the corridors. And in fact, fire department recently put stickers in my apartment building that says, they're very adamant and big. It says, make sure you close your apartment door in a fire. Make sure you close the stair door in a fire. Types of windows. Again, there are many types of windows. Picture windows are all glass, no operation. Single hung, one side moves, double hung, both sides move. The hoppers and transoms, these are windows that fold down. They have a lot of uses for just easy access. And again, a big panel of glass, a little bit of ventilation, easy to clean and easy to work with. The hopper can be mounted from the bottom, it can be mounted from the top, it can be pivot from the side. As you can see, there's lots of different window combinations. Each one of them has a different characteristic for water damage on the outside. They can be made of vinyl, fiberglass, steel, aluminum, combinations of all of those materials, wood. And they all eventually catch up. The nature catches up with them. Quick reminders on, again, hopper windows. You might have it inside this container here. Typical pivot window, very basic. Water damage. Again, water works its way down the side of the building with snow or ice or rain. Remember,
the siding is not waterproof. The siding is what's called a water screen. Okay, water is going to get behind it either by condensation or by force of rain, and then the water has to drain beyond. Many times when it drains, it hits the frame of the window rots away. So the window, picture windows and windows in general, both on the outside and the inside, it's very important to inspect. Again, walls and ceilings on the inside, beautiful post and beams. Sometimes these are fake. Stone wall at the hearth, probably fake. You know, I don't like movie set apartment rooms. I like if it's gonna be stone, I want 3 feet of stone. I'm kind of crazy. If it's beams, I want it to be real beams. I don't like fake stuff. But hey, I guess it sells, right? Your concern isn't whether it looks good or not. Your concern is whether there's water damage or structural damage that makes it useless. Popping nails. And popping nails sometimes is bad. Sometimes it's just regular settlement of a building. But if there's a lot of popping nails and it's recurrent, and you can see they've patched, there might be some real structural shifting going on in the building. Again, ceilings and water damage. Ceilings try to stop the water and it doesn't end well. Water runs down inside a building. It stays in places you wouldn't expect. And then next thing you know, it just eventually works its way, dissolves the side of the drywall, and bam, you've got the problem. With thermal cameras, you can often detect that problem before it happens. Again, this is where the house, there's no insulation where there's supposed to be insulation on the house. The roof, by the way, in the future, that's the most important place for insulation. The wall needs R19, the roof needs R38. R38 is about 10 inches of insulation. It costs a lot of money. But again, houses in the future, hopefully it'll save you a lot of money too. Again, water coming through the ceiling, not good. Mold is what happens when the water doesn't come through the ceiling and sits there, or the air is humid and not circulating. Mold is going to come in and do immense damage. What are you looking for? You're looking for water damage. This is a pretty useful device called a moisture meter. It either has a radiant detector or it's got 2 pins. You took the pins up, and even though there's a nice fresh coat of paint there, you gently push the pins through the paint. Nobody will notice that. And you can find out the drywall up above that vinyl paint is completely soaked. Again, bowed ceilings, that's a problem. Water popping through. Very often they put ceiling tiles on suspended ceilings or these panel sheets because they're trying to hide something. Again, water damage in this huge, expensive cathedral ceiling. You can tell by the discolorations, the areas around the can vents, as we saw it earlier, they're failing. They're letting in energy, and that because they're letting energy out, they're letting moisture in, and you can see the water damage forming in the ceiling. That's a big minus. This is like a $10,000 job to fix this. Again, you don't give cost estimates, but you want to think about it. Again, the ceiling above a ceiling. More is that cool fan again. Again, a sample report. No, it's okay to say, you don't have to say everything's negative. So just a quick report. The guy says, no, floors are okay. Time inspections. There's no deficiencies. There's cosmetic defects and general wear and tear, but the floors are okay. Ceilings. He's gone through a house and he says, you know, the wall, they're typical. It looks like there may be some settlement, so you do need inspection of the walls and ceilings. Typically looks for defects. In this case, they haven't found much and generally okay. Doors, hey, the door's all open. They function, the locks work. You know, there's a couple dings here and there as the nature of doors, but generally it's okay. Stairs, the railings are safe. In some cases, they wiggle a little bit, but generally they're okay. And here it says mostly okay. And in that case, he might be in his further on his report, he's pointing out maybe a couple of loose pieces of wood or a railing that's moving a little too much. And that is, the emphasis I want to show on this slide is you don't have to rip everybody apart in your report. Use a balance. The key thing is reasonable wear and tear. But you're there to find the kind of hidden stuff that a normal person might not spot. And that's your goal. Again, speaking of things that people might not spot, dust and mold. Again, air ducts. Yuck. Ceiling fails. Up in a ceiling here, we've got, this is the metal lath that's used as the former for the plaster.
once it starts coming off, this can be quite expensive to repair. If you don't have this exact mold, or you can match the mold, but you got to create a mold to reform this plaster, and it can be quite annoying and quite expensive. Again, ironically, with 3D printing these days, it's pretty feasible. Ceilings, again, this is water building up under a vinyl ceiling. The ceiling looks fine, except there's so much water behind it, the water can't get out. If you pop this bubble, it's literally going to pour 5 gallons of water on your head. How do I know? Because it happened to me. Termites, never fun. We'll talk about that more later. Sprinklers, fire sprinklers. Again, they're going to become more popular in residential buildings and larger buildings. They are 3 stories and above. They're required in New York City in most places. And of course, apartment buildings, you're going to be required to have them in the basements. Now, for your report, you're simply going to note that the sprinkler system is there, unless you're a fire suppression contractor, which we may have somebody here that does that, and in which case they can provide a more detailed report, but they're probably going to charge more money. Again, thinking about the floor systems, what are the enemies? Water, stress, weight, animals, staining, all these different problems. What's underneath? Subfloor, just sometimes OSB, sometimes 5/4 strip. Today's finished materials, again, they look like wood, but it's actually all vinyl. Is it good? It's what it is. You're just going to try to identify what it is and report to the buyer. I mean, they see it. They're going to know what they're buying. But if you see deficiencies, that's what you want to get. In this case, they may see just regular tile. You'll say, oh, that's 9-inch tile. It looks like it very well may have asbestos. Please check. Oh, and by the way, there's this black mold here along the inside, implies that there's probably moisture in the walls that have to be addressed. Again, vinyl, different types of floor materials, vinyl, woods. Wood can go from cheap to very, very, very expensive. In this case, the wood is exposed not only on the floor, but also on the ceilings. Again, some of the newer construction methods we're actually going back in time again, as I said. Some of the best new designs I've seen recently have the structure completely exposed like this, and then tons and tons of insulation on the outside, instead of insulation between the joists. The reason is by exposing the wood, you protect it from rot. So it's going to become more popular in the coming years. Again, wear and tear. At what point does this wear and tear on the floor become a cost issue? Well, this one on the left, it's wear and tear. I definitely mark it as wear and tear because the new owner may have to sand this down. Now, this one, that wear and tear, now that's bad, right? This is really going to require some mechanical and chemical treatments to make this good again. Again, this example of a 100-year-old floor, partially treated over the years, but to make this stabilize, what did somebody do? They cheated. They just put a carpet on top. Types of woods, again, what are we looking for? We're looking for the points where water, humidity, moisture is going to intersect with a building. In this case, the warm air coming out of the duct is there because in the wintertime, it's going to keep the window from fogging up. But again, because you're keeping the window from fogging up, there's going to be condensation. It's going to come back down. So there's going to be lots of areas for people walking in and out of the house where at the doors, you're going to look at this interface, indoor-outdoor interface for water damage. Water damage, bad floors, more floor alternatives, cracked floors and tiles. Tile materials, again, you're looking, a reasonable amount of settlement can occur. It's the nature of stone, but you got to make it right. Again, mold coming through the walls, tiles. This one's interesting on the right, very important. This is somebody trying to cover up fire damage. That's interesting. Water damage, again, they didn't know the water damage, so they lifted up the carpet, and then they found there was a ton of damage, maybe from 4 owners before, but it's there. But you can buff that out. Again, carpet checks, floors deforming because they got wet. Very, very nasty deformity of floors. As we look at the structure of floors, we look at this. This is called sistering, where you're attaching a beam to kind of reinforce that beam that's already there, because the beam may be rotted. In this case, it rotted at the wall probably because of the water pipes nearby. Floods, ouch. Stairs. We talk about the importance of inspecting stairs. The railings have to be safe. The stairs have to be even. The treads textured so you're not going to trip. Pretty basic stuff. Parts of a stair, you should all know them, of course. The handrails, the balusters, the vertical elements, a newel post at the base. Nosing is the edge of the stair. The tread is the main stair itself. The riser underneath the tread when there is one. And then, of course, most importantly, the stringer, which is the structural elements that hold up the stair. Good examples. Again, stairs can be very complex. As you can see, the many parts listed here, what you're really inspecting, you're not looking for the architectural part, you're looking for the structural part. Are any of these railings wiggling? Are they set on the walls? Are you no more than 4-inch openings in between? So the kids are safe. Again, lots of different stairs. A totally open stair, allowed in residential, not allowed in multifamily, and not allowed in public sections. Again, stone stairs. Wow. This is actually, I think this isn't stone. I think this is a plastic. Whatever. It's interesting. Again, the stair towers, you look at where the damage is, think about how the pedestrian flow is, where the scratches, damage, railing damage, etc. can happen. And of course, some cool spaces. Spirals, the one on the left, you're probably not going to see in the house. The one on the right is actually pretty common, particularly in New York City. There's a lot of spiral stairs. Again, what do you care? That it's solid, that it is evenly spaced so you don't trip. The railings are strong in case you trip, or excuse me, when you trip, because for the most part, these are not allowed in egress, but they are allowed inside of apartments. Quick example of a metal one you might see. I love this nightmare. Who the hell would be in this? Again, foam. Insulation. Let's talk about insulation for a minute. Again, insulation has no more time than now, right? I bet there's a lot of people in Texas wish they had more insulation in their houses. Well, probably with that much cold, that wouldn't have helped. But they might have lasted another day or two. But in fact, down in Texas, most people don't insulate their houses. So they had it pretty rough. So, in fact, it just got declared a major emergency. So I do hope they can help everybody out. But as you can see, heat goes through a lot of different places. The windows, the ceilings. Again, they solve this. A lot more insulation is required in newer houses. And we add, of course, where do we have the insulation? On the edges of the conditioned space. You know, again, it may not be in the attic ceiling, but it'll be in the attic floor to protect the space below. Again, types of insulation, fiberglass, rock wool, cellulose, spray-ons, all these different materials. Actually, I don't have spray here, but spray is like 6 inches. Really good stuff. What do we think about? We think about the insulation. We also think about the vapor barrier. The vapor barrier is the intersection where cold is going to hit hot. When hot air hits cold material, the hot air condenses, creates condensate, whether it be on a pipe in plumbing or on the walls of a house. That condensation, if it doesn't get drained away, becomes mold food and will destroy your house. Again, insulation types up in the attic, you might have flat insulation. Below ground, you'll usually have styrofoam. Above ground in the walls, you'll have perhaps roll insulation or rigid panels, or even EIFS materials, which are quite good. We talked about EIFS in the exterior as the exterior section. Again, here's rolling in some new insulation. Thinking about insulation, you have to think about that vapor barrier. Where does the heat stop? Where does the water stop? And is the heat managed and is the water managed? If it's not, you're doomed. In the 70s, they had spray-on insulation called UFFI. Over time, it shrank. Things to think about. Here's a good loose fill. Different types of loose fill, fiberglass, cellulose, asbestos / vermiculite, spray-on insulation, closed cell and open cell insulation is really becoming very popular. It's a spray-on. It actually is very hard when it sprays on, and it's really impressive in its numbers for insulation. But again, I have some problems with it because it seals air so well that you can have water back up behind it. Of course, remind yourself, public personal safety. Watch out for animals and stuff as you inspect the house. I know, gross, but it's very real.
think about insulation as a system. All the different parts working together, all the connections at every door, every window, at every electrical outlet, every part of the building has to work together. There's that vermiculite insulation, again, perlite insulation on the right side. This is just a type of just a light rock material, pretty good stuff. It's cheap, it's natural, and if it doesn't have asbestos, it will actually do a pretty good insulation job. Mineral wool, lots of different kinds of rock wool material out there now is great. In this case, this was a cotton fiber that had been sprayed in, not a mineral wool, and had been contaminated by lint from a dryer. Different types of plastics, again, polystyrene, polyisosanuate, yellow system, and polystyrene, expanded polystyrene, which we commonly know as styrofoam. Again, good materials. And as you can see, they're used in conjunction, expanded polystyrene and with spray on. And so you get this universal system. The goal is to have good water, vapor barrier and waterproofing, keeping the water out long enough so it can be brought away from the building. Accordions, blown in insulation. One on the right doesn't have enough. Again, lots of different types these days with the spray-ons, but also bad insulations. This is UFFI. There's spray-on from 40 years ago. It shrunk and it's now useless. Vapor barriers on the left, it did such a good job blocking that the water never got through, and you got a bunch of mold down there. On the right side, there's a great vapor barrier on the concrete foundation wall. It's not a treated space, but this does prevent a lot of cold air from entering into the house. Again, if you can keep that, if a basement goes to 10 degrees in the wintertime, it's gonna, some of that cold's going upstairs. If you keep it down to 50 down in the wintertime, then that mild air won't radiate as much upstairs. Again, typical fiberglass insulations. Fiberglass is good until it gets wet, then it sucks. Vapor barriers, again, lots of different kinds out there. The spray on again. Up in the attics, we talk about insulation, but we also talk about structure. Getting to the attic, and you might have a drop-down ladder. You might have stairs right up to the attic, or you might have a simply just an access panel like this. The access panel is probably the most dangerous because you've got to go up a ladder and to look around. Again, have the right size ladder. Do not do what this guy is doing. This guy is going up on a ladder that's way too short. That's not good. That's not safe. So get the right size ladder for the job and be careful. And also don't be afraid to use a pole camera and just stick a pole up there and look around. Again, we're in an environment today, you can put a pole camera and watch, have the camera up there and you're just watching a Wi-Fi of it on your smartphone. This is a good tactics that you can do. Attic insulation, again, it's so warm that the animals like it. This is a typical drop attic. Up in the attic, we talk about wiring quickly. We looked about some of these pictures today. Again, this is where people get sloppy. Here, the guy, even though he knew nobody would see it, he still did nice wiring. This guy, not so much. Again, ventilation is important up in the attic. These whole house ventilators are great, but you've got to have, this brings a lot of air up into the attic, so you better have some either a ridge vent or a soffit vent, not a soffit vent, or a roof vent to vent it. Why does it matter? Because if you do not have proper airflow between the conditioned space and the unconditioned space, you're going to get a mess. In this case, the insulation is coming up and flowing over the soffit to the unconditioned space. Is it okay that the attic is cold? Nobody cares, because in the summertime it's 200 degrees up here, and that air is just going to vent right out and never go down into the controlled space. Again, attic ventilation stupid. Cathedral ceilings, we saw the water damage on that one earlier. So this venting, there's a couple inches of gap between the insulation and the roof deck, and that gap allows for airflow and takes the moisture away from the cathedral ceiling. Again, these roof vents are on the sides in snowy climates, and in warmer climates, you might have a ridge vent instead.
Water damage over time, the wood rots. It's not perfect. Failure, again, we think back in the attic inspection, we think about all the moisture and airflow. Does it move properly? Is it, I don't want dust up there. Is it being cleaned? Is there enough insulation? Here you're blowing on some insulation. Get the garages quickly. Again, another red slide. These are slides with just the raw text. Garages, exterior garages, how do you inspect? Very often the exterior garages aren't maintained. This is the garage door. Again, you're going into the garage, so you've got steps up. You've got that elevation change because you might have fumes from the car, unless you're doing a Tesla. Not picking on Tesla. I think A, there's a lot of electric cars. B, there'll be a lot more electric cars. And C, the law requires you to have an outlet for an electric car these days. And D, I don't care about any of them because I'm a big hydrogen guy. Again, in those garages, non-heated spaces, you'll often see the roof, a lot of damage. This is a typical garage in backyards of Brooklyn, and they basically all collapse, and people just tear them down and get rid of them because they're functionally useless. They're too small for modern cars. Again, garages we saw today. Think about how the garage is connected to the house. You think about all the different places where not only the mud and dirt, but vapors can come in. I'm putting a carbon monoxide detector right there at that utility room. Again, gas furnaces in the garage sometimes. Why? Because, hey, again, that carbon monoxide factor, leave the combustion out there. It may not be as efficient, but it'll be a little safer. Exterior detached garages, you really inspect it like a house. Little tiny garage here I found. A connected garage, in this case, the problem, I got a garage door, but there's a residential door on it. What's going on there, guys? Yeah, that's an illegal apartment. Are you there to say what's legal or illegal? No. Are you noting that it's a one-family house and there's a separate apartment in the cellar? You might want to think about noting that. Again, garage door parts, key elements, the door, does the door open safely? Can it release manually, have a manual override? The manual override to let it close, but also the safety containers to make sure nobody goes underneath. A typical thing you might find is a broken spring. Again, why is there a safety thing on a garage within 6 inches of the ground? I think that picture says it all. Again, garage door openers, if they don't move perfectly, the door will break. And so this double really is in a world of pain. And that's a big expense, all because maybe some dirt got in the tracks on the right side of the building. I like this one, by the way, the drive-through garage door opener. Again, little tiny, the garage is very heavy and very powerful motor. And so just a little misalignment or a little dirt in the tracks, and it literally snapped the bracket right here. This guy's stupid. He cut a hole in the ceiling, more floor stuff in the garage. Again, a really nice garage, no real problems there. A garage that the guy decided to make out of his living room. Ouch. A garage turned into an apartment. Again, the laundry area. Now we go to the laundry. Again, a lot of these fixtures are appliances, not parts of the house. So you might only inspect the basics, connections of the house, and not, you inspect the sink, but not the appliances, which is the washer and dryer. Gas, utilities in the basement. We talk again about the importance of airflow, water release, water removal. What is a basement? A basement is less underground, but less than halfway underground. A cellar is all the way underground. So this first level is actually not a first level. That's a basement. From a building code perspective, this is a C plus, that's a C plus B plus 1, 2, 3, 4 plus penthouse. Penthouse is a super small level of the floor. And actually, if it's less than 1/3 of the size of the floor below, then it's called a penthouse. Again, basement or cellar, clearly a cellar, but nobody lives down there, so that's okay. Again, you can't live in a full cellar because it's not safe and you're not going to get out alive in a fire. Dampness in the cellars, more dampness, more sump pumps, very important. Check that. Check for rust in the equipment. Check for, again, mold. You see the black mold here. Behind the walls of that vapor barrier, that the vapor barrier is in, but it wasn't really draining properly, and moisture built up through, as the water soaked right through the concrete, created mold. More mold. More mold, reminder to check furnaces and stuff. We'll go about that next week. Crawl spaces. Are you going to get down in crawl spaces? You got to. If it's less than 36 inches, technically you don't have to by the SOP. It's more than 36 inches, you should be expected to go down there. Bunny suits, good idea. Confined space, dumb idea. Vapor barriers, good. Hopefully you'll have these because they're nice and easy to slide around on, of course, but they also keep moisture out of the cellar, which increases the life of the house. Again, fireplaces, lots of different fireplaces out there. What you're looking for is proper airflow. You see a lot of dirt built up above the hearth here, which tells me there might not be good airflow. Again, inserts in solid SFB, solid fuel burning appliances. It's not a fireplace stove. It's a solid fuel burning appliance. Yeah, right. Very often they insert these into older fireplaces to use. Older stoves, non-airtight stoves, they don't burn very fast. They don't burn very efficiently, and but you do have to worry about, obviously, with any fireplace fire. 18-inch clearances. You got to have reasonable clearances around all the pipes, and also in front of the stove. Think about how hot this is and the radiant heat. The radiant heat hits this wall. If you don't reflect it back into the room, A, you're wasting it, and B, you might cause damage to the wall or worse. Again, open door fireplaces. If it's open door like this, it's ornamental and not very efficient. If it's closed door, then you're going to start getting efficient. Here you can see a lock on the door. You're starting to get more efficient. These new ones, really, they treat it like a fuel and really try to burn it efficiently. Today's ones will even have catalytic converters where you're passing the air through a catalyst to take out a lot of the pollution. And as you can see by this, it's pretty good pollution reduction. So much so in New York City, you're not even allowed to use wood burning fireplaces anymore. The existing ones are more valuable. Again, the catalytic converter, just like a car, takes all the crappy gas, burns it a little faster, a higher temperature, and burns it and actually converts it to much more sanitary water and carbon dioxide. It also creates sulfur, but that's another story. The idea of catalytics, again, is to pass the air before it leaves, pass the air over that catalyst to convert its temperature, to convert its chemistry, also to catch as much of the heat as possible, and then go up the stack. Again, EPA stoves more efficient, more wood burning stoves. The idea, of course, is when you're dealing with a stove, it's got to pass through and out of the house in a safe way. In some occasions, in bigger houses and that are far away from other houses, you can have a side vent, but of course that vent's got to be in a place that you're not going to burn yourself as you walk by. Stove chimneys, quick ones, flues. Lots of different types of flues. The concept is the same. You're taking hot gas, you're moving it up through the building. You got to make sure the structure is protected so there's never any leaks, and also that there's no heat transfer so the chimney doesn't set the building on fire. That's a very simple system to a very complex problem. Again, whether it be lightning or water damage or whatever, chimneys and furnaces take punishment, so it's pretty important to inspect them. If you can get on the roof, great, but a binocular inspection might be all you can do. In this case, you got lots of problems you can see from the street, like there's a stone, there's a piece of slate put on top of the vent. That's not real smart. And that bricks are literally falling off, and from the spalling, from the water damage caused by the humidity from the air and the hot wall and cold, or in some case warm air coming out. Again, deflecting, bad chimney. If you can look down the chimney, fine. If not, you do what you can. Again, interesting. I did a lot of connective slides that aren't in here. Typical dampers, stove cleanouts, the hearth. Again, the importance of having at least 16 to 18 inches in front of the stove. Different types of older fireplaces. The narrow apartment fireplaces in New York City are often referred to as Rumford. Conventional ones in a larger house go much deeper. And again, each one radiates heat a little differently. The baffles keeping cinders from going up the tunnel, but chimneys take abuse. They really get knocked out. And in this case, large chunks of the chimney have actually fallen down into the firebox down below. Fireplace damage again, the hot warm air coming up, hitting cold brick, condensing, and slowly rotting the brick away. Chimneys are probably the worst for water damage. Again, more images. We've seen a lot of these. We saw these last time, and you just got the copy. So that kind of covers chapter 7. Okay, guys, I've covered a lot of ground today. We did chapter 9, electrical. Kind of went through it again quickly. We then have gone through chapter 7. A lot for you to read, think, take a look at the PowerPoints, study, and hopefully you'll get your license, be a home inspector, and make the world a better place, and help people make. What are you doing this for? To help buyers make good decisions with their product. So on that note, we're locking and loading for the night. How's everybody doing? Any last comments for the night?
Good. I have two questions. The first one is, when is the Wednesday lecture that you mentioned?
The Wednesday lecture is 4 to 8. It's actually this same phone number. I'm going to do my personal line for it. It is the M12 inspection for salespeople and brokers. And you're welcome to listen to it if you're paying for the home inspection. And if you're doing the brokerage or continuing education, you probably have to listen to it anyway. Usually I have about 30 or 40 people in that class, and I'm going to cover all of construction and environmental issues from relatively quickly.
And can we get the link for that Zoom meeting?
That one is 4 to 8.
That one is what?
4 hours, 4 p.m. to 8 p.m.
Yeah, but can we get the link for the Zoom?
It should be on the website, on the NY Real Ed website, but you can literally connect right to this same thing at 4 o'clock.
Same Zoom link?
Exact same link, yes.
Okay. And the second question is, when will we have an exam for this, and do we have another lecture next Saturday?
If you have, how many sections have you taken? Have you H1 and H2 or module 1?
No, I started from module 2. I took.
Okay, so you just started. So
yeah.
There's no class next week. 2 weeks from now, we'll do this again for module 3. So in this next week, you're going to study, you're going to review your materials, and you're going to contact John, and he's going to give you a test online. You might be able to go in school to take the test, or he might have a way to proctor it for you online.
Okay, and
so that's, you're going to contact the school regarding the testing.
And there's only one chance to do the exam, right?
If you fail, I think he'll let you do it again.
Okay.
Yeah, look, we want you to be successful. We want you to know the material. We're not going to be pricks. John's not a prick about it. He wants. He doesn't. If he's got to do it twice, I don't know. He may have to charge you, because I think he has to pay for the test. But I'll let you. First of all, you're going to study hard. You're going to pass the first time, so you're not going to care.
Right. No, I was just making sure what's the situation.
All I can say is he's very reasonable, and that I can guarantee. So, anybody else? Questions, thoughts? What bar are we meeting at tonight? I'm just kidding. I'm sure we're scattered to the 4 winds. Somebody dialing in recently for the class from Binghamton, and so he's 200 miles away. Is that okay? Yeah, it's perfectly okay. Yeah, I'm teaching for the entire state. So, which is a reminder of why we have to have, why my stuff talks about city as well as country houses in terms of the building design you're going to deal with. Okay, everybody, last chance. Everybody good?
Brian, question, quick.
Yes.
Thank you.
Go ahead.
In regards to getting this license extended to Florida, what would that process be? After I completed the heat?
Good question. Don't know. And a lot of people are asking that, including myself. I'm trying to get my architecture. Now, architecture is very difficult to be retroactive, or reciprocity. I have been told that it's pretty easy for a broker and home inspector. Any broker, anybody doing Florida yet? If you are, again, go to the Florida website. You literally type it in, Florida home inspector, and look at reciprocity and see what they say. Because it's going to be the state. And good move, dude. Very smart. I'm actually looking at that myself.
I'm actually next month going to look for a place to rent for a year so I can look for foreclosures down there.
Good luck. I would tell you, the biggest problem is right now, of course, is as long as they're, once that foreclosure ban goes away, it'll still take a year and a half in New York City before anybody starts getting foreclosed upon. But in Florida, they'll start the foreclosures in 60 days. I mean, they kick people out fast. And obviously with attrition, a lot of old people have passed away. I was just recently looking at some properties. You can buy, houses. I mean, it's nothing like 2008. 2008, you could buy houses in West Palm Beach for $25,000-$30,000, and now they're $400,000. So the price differentials are pretty wild. But definitely happy hunting. A hunt from Zillow on the short term, but of course you got to be on the ground. So,
right. What would be your ideal city? Just real quick.
Me, I only do one. I do Palm Beach. I go where the money is. I deal with investment bankers. I don't expect things less than $10 million. Well, that's not illegal. That's the stuff I do. I mean,
no. What would be your favorite city just to live?
I'm not picky. I can adapt to anything. My brother and I joked that many years ago we swore we would buy the 7 Mile Grill on Key Marathon, and that was always our goal. But one day at a time. Right now, to me, there's only one thing that matters: is what does my wife want to do? So, got to keep her happy. Right now, my waterfront may not be Florida; it might be Montenegro. We're seriously. I'm not kidding. We're seriously.
I like the. I would wish Sydney.
Sydney, Australia is quite interesting. Yes.
Yes, it is.
So anyway, the whole point is we are in the center of the world for now, although my Chinese friends were just debating that last night. But in the interim, we are New York City. From here, you'll do business anywhere in the world. I was negotiating a deal last night. I might design a building in Shanghai, in China, because I teach over there as well. But the key thing is that from here you can be anywhere, and obviously the entire rules of the global real estate game have changed in the last year. And ironically, New York City went way down, but the rest of the country went way up because of these low interest rates. And how it plays out, I don't know. Again, just in New York City, Manhattan went down, but Nassau, Suffolk, and Westchester went way up. So these lessons on home inspection are really important for all those closings that happen in the 50-mile radius of New York, and even more so in people who went way upstate, and went to 100, 200 miles north of here. Why they want to do that, I don't know, but they did. So as I put away my stuff, I want to wish you guys a good day. We'll talk again on the 6th. Actually, I hope you might want to dial in on the class on Wednesday night. One of the reasons why John wants you to do the class, A, we're a couple hours short on the class, and B, it gives you an opportunity to listen to some of the environmental stuff. I do talk about asbestos and stuff, but it is most importantly, it's a really good 4-hour class, just as a quick reminder of everything you learned. So I hope you dial in for that. And again, same bat channel, not same bat time, but you get the idea. So get out of here. Everybody have a good night, okay?
You too.
You too. Bye.
Peace, love, and vodka.